Our universe, a vast expanse brimming with complexity, continues to captivate and perplex us in equal measure. From the most minuscule particles that form the building blocks of everything around us, to the grandest cosmic structures stretching across unimaginable distances, the universe holds countless secrets waiting to be discovered. Among the most intriguing mysteries are those of the black holes, what lies hidden within their enigmatic depths. How did the first stars ignite the dark abyss of space, providing the light that eventually led to the formation of galaxies, stars, and planets? And perhaps the most tantalizing question of all, are we truly alone in the cosmos, or could there be other forms of life hidden in the dark corners of the universe waiting to be found? One such enigma lies just next door within our very own solar system, Venus, often called Earth's evil twin. Venus is one of the most extreme and inhospitable places in the solar system, a place that seems like an alien world, so different from Earth that it might be hard to believe they were once formed from the same cosmic origins. Its thick, suffocating clouds are choked with deadly sulfuric acid, and its surface reaches mind-boggling temperatures of 900 degrees Fahrenheit, hot enough to melt lead. If you were to stand on Venus, you would feel as if you had stepped straight into a vision of hell itself. Yet, scientists speculate that billions of years ago, Venus may have looked strikingly similar to Earth. It might have had vast oceans, a temperate climate, and conditions suitable for life. So, what went wrong? How did Venus transform from a potential paradise, a blue and green world teeming with life, into the hellish wasteland we see today? Could the story of Venus serve as a dire warning for the future of Earth? In November 2005, a new mission set out to explore this very question. A Russian Soyuz rocket, launched from Kazakhstan, carried with it a small European spacecraft called Venus Express. Its mission? To travel 250 million miles to investigate the reasons behind Venus's dramatic transformation. For centuries, Venus remained an unsolved mystery, its surface hidden beneath a dense veil of clouds. Early astronomers, assuming Venus was closer to the Sun than Earth, speculated that it would be a warm, humid world, perhaps even a lush, tropical planet. Some even dreamed of a steaming jungle beneath its clouds, teeming with strange, exotic life. In the 1950s and 1960s, many scientists believed Venus's climate might resemble that of Miami, Florida, warm, wet, and thriving. However, everything changed when the Soviet Union launched a series of probes to Venus, codenamed Venera. These probes sent back shocking images that shattered previous assumptions. Instead of the tropical paradise envisioned, the surface of Venus was revealed to be a barren, hellish desert. The ground was covered in lifeless, cracked rock with no signs of water anywhere. The dream of a Venusian Eden was quickly dashed. At first glance, Venus and Earth seem like identical twins, similar in size, composed of similar materials, and likely formed from the same cosmic cloud of dust and gas over 4 billion years ago. Yet, that's where the similarities end. While Earth blossomed into a vibrant, life-filled world, Venus turned into a stifling, toxic inferno. An astounding 85% of Venus's surface is covered in hardened lava from long-extinct volcanoes. The atmosphere is nearly entirely made of carbon dioxide, and the clouds are filled with sulfuric acid, making it impossible for life as we know it to exist. The atmospheric pressure on the surface is 90 times greater than on Earth, enough to crush a car in an instant. But perhaps the most terrifying difference is the temperature. Venus's thick, carbon dioxide-laden atmosphere functions as a supercharged greenhouse, trapping heat so efficiently that the surface temperature skyrockets to 900 degrees Fahrenheit. Here on Earth, rising levels of carbon dioxide are causing a gradual warming effect, but on Venus, the greenhouse effect spiraled completely out of control, transforming the planet into a blistering wasteland. When scientists first discovered just how hot Venus was, they were stunned. The heat is so intense that some of the rocks on the surface actually glow in the dark. If you somehow managed to survive the crushing pressure and the extreme heat, you would still be faced with another, even more disorienting challenge: complete and utter sensory deprivation. Venus is perpetually shrouded in thick clouds, meaning you would never see the sun, the stars, or even shadows. Day and night would be impossible to distinguish, and navigating such an alien world would be an absolute nightmare. To solve the mystery of how Earth and Venus became so vastly different, Venus Express was equipped with cutting-edge technology designed to peer through the dense atmosphere and study the planet's secrets. But before it could begin its scientific mission, the spacecraft had to accomplish a daunting task, arriving safely in orbit around Venus. Space travel is never without its risks, and entering orbit around Venus was no simple feat. If the spacecraft approached the planet too quickly, it would miss its target and be lost in the vast emptiness of space. Approach too slowly, and Venus's powerful gravity would pull the spacecraft down into its crushing atmosphere, where it would burn up and disintegrate. The team had only one chance to get it right. On April 11, 2006, after a 5-month journey through space, Venus Express reached its destination. In order to enter orbit, the spacecraft had to slow down by 3,000 miles per hour, a maneuver so precise that even a slight miscalculation could spell disaster. As the spacecraft executed this critical maneuver, it disappeared behind Venus, cutting off communication with mission control for agonizing minutes. Everyone on Earth held their breath, waiting in suspense. A mission of this magnitude, spanning 4 years and involving millions of dollars, hinged on this one moment of perfect execution. Then, at precisely 9:57 a.m., the spacecraft sent a signal back to Earth. It was a moment of triumph. Venus Express had successfully entered orbit around Venus, beginning a groundbreaking mission to unlock the many secrets of this mysterious planet. But before any discoveries could be made, the spacecraft needed to get much closer to Venus. Following an elliptical orbit, it flew over the planet's poles, diving down from an altitude of 40,000 miles to just 155 miles above the surface. And then, the real work began. The technology aboard Venus Express represented a massive leap forward from previous missions. The earlier probes, launched in 1990, could only study Venus's surface by landing, but the extreme conditions there, crushing pressure, intense heat, and corrosive clouds, made it impossible for them to survive for long. The ones that did manage to land were quickly destroyed. But with Venus Express, the team had developed a way to study the surface without ever having to touch down. The spacecraft used infrared light, wavelengths of light invisible to the human eye, to study the planet. Unlike visible light, which is scattered by Venus's thick clouds, infrared light can pass through the less dense regions of the atmosphere, allowing the spacecraft to see the surface below. This technology gave scientists their first ever 3D view of Venus, from its surface all the way up into the atmosphere. When you observe Venus with the naked eye, all you see is the thick, yellowish haze of the uppermost clouds. But with infrared technology, scientists were able to look much deeper, cutting through the clouds and studying the layers of atmosphere below. For the first time, they could map Venus in incredible detail, documenting the planet's differences from Earth and hoping to answer the question, why does Venus have such extreme conditions? What caused it to diverge so radically from Earth's path? Despite decades of exploration, Venus continues to surprise scientists. With each new mission, we uncover more about this hostile world, once thought to be Earth's twin, whose path billions of years ago diverged dramatically, transforming it into the scorched, inhospitable planet it is today. The discoveries made by Venus Express would forever change our understanding of our closest planetary neighbor and perhaps offer valuable lessons about our own planet's future. As the spacecraft Venus Express ventured to the outermost edge of Venus's atmosphere, it uncovered a clue that would reshape our understanding of the planet's history. For years, scientists had puzzled over the question of water on Venus. Did it ever have oceans, lakes, or even rain? Could Venus have been Earth's twin at some point, with its surface covered by vast life-sustaining oceans? The spacecraft's instruments provided the first tangible evidence. Particles, including helium, hydrogen, and oxygen, were seen escaping from Venus's atmosphere and drifting into space. These are some of the key elements that are critical for the formation of water. It was a tantalizing discovery, but it was also one that led to unexpected conclusions. For years, the prevailing theory had suggested that Venus may once have had oceans that spanned nearly 90% of its surface, much like Earth. However, the data collected by Venus Express told a different story. The amount of water vapor in Venus's atmosphere was shockingly low. If all the water vapor were to condense and cover the planet's surface, it would form a thin layer barely an inch deep. This discovery forced scientists to ask a fundamental question: where did all the water go? For a long time, the assumption was simple: the water evaporated, boiled away under the relentless heat of the sun. However, as the Venus Express mission continued, scientists started to rethink this idea. They still placed blame on the sun, but now the cause seemed more complicated. The sun, known as Earth's life giver, also constantly emits a stream of charged particles, moving at speeds of up to 1.8 million miles per hour. This phenomenon, known as solar wind, can have catastrophic effects on planets that lack the protective shield of a magnetic field. Earth is fortunate enough to have a magnetic field, created by the movements of iron in its core, which serves as a safeguard against the solar wind. Venus, on the other hand, lacks such a magnetic field, and scientists believe that this is due to the planet's slow rotation. While Earth's day lasts a mere 24 hours, a single day on Venus stretches an unimaginable 243 Earth days. This incredibly slow rotation has left Venus vulnerable to the full force of the sun's solar wind. The solar wind bombards Venus's upper atmosphere, stripping away its gases and moisture. Over time, it's become clear that a combination of intense evaporation caused by the planet's searing heat and the solar wind have been responsible for the disappearance of Venus's once thriving atmosphere and water supply. Being closer to the sun than Earth, Venus is much hotter, and its early oceans likely evaporated into the atmosphere. Any remaining water vapor became trapped in thick clouds, but eventually, the sun's ultraviolet radiation began to break down the water molecules. The ultraviolet light split the water vapor into hydrogen and oxygen, with the lighter hydrogen molecules escaping into space over billions of years. The result? Venus lost its oceans entirely, leaving only trace amounts of hydrogen and oxygen behind in the atmosphere. The water that once was is now gone, a distant memory of a more temperate, perhaps even Earth-like past. But the loss of water was just the beginning of Venus's dramatic transformation. As its oceans disappeared, another deadly cycle began. Ancient volcanic eruptions released vast amounts of carbon dioxide into the atmosphere. This kicked off a runaway greenhouse effect, a process where heat becomes trapped in the atmosphere, making the planet even hotter. This cycle intensified, and Venus's surface temperature surged to unbearable levels. The planet, once perhaps more hospitable, became the scorching, uninhabitable world we see today. The science behind Venus's transformation is deeply tied to the sun's energy. On Earth, sunlight passes through a thin atmosphere, warming the surface and driving our weather and climate. But on Venus, the situation is radically different. Its atmosphere is over 100 times thicker than Earth's, and most of the sunlight is absorbed by this dense layer of clouds and gases, heating up the atmosphere. Only a small fraction of sunlight reaches the surface, but that tiny bit of energy exacerbates the already extreme conditions, trapping even more heat. Standing on Venus's surface, the heat would be overwhelming. The ground radiates infrared energy, and the atmosphere is thick with heat-trapping gases. But what happens to this energy? Does it escape into space? In theory, it could, but it doesn't. The thick atmosphere traps most of the infrared radiation, and much of it bounces back to the surface, intensifying the heat even further. This runaway effect causes both the surface and the atmosphere to heat up to extreme levels, creating a vicious cycle that pushes Venus into a state of constant, unrelenting heat. In fact, Venus has become the hottest planet in our solar system, even more so than Mercury, the planet closest to the Sun. It has become a prime example of catastrophic climate change. It is a world where heat reigns supreme, a world in the grip of a never-ending heat wave. Venus is a cosmic nightmare, a planet where life is impossible, and where even the most resilient forms of existence would perish under the intense pressure and temperature. It's hard not to wonder, could Earth one day meet the same fate? Could our planet, if it were positioned even a little closer to the Sun, undergo a similar transformation? The major difference between Earth and Venus lies in their distance from the Sun. Though both planets likely formed from similar materials and under similar conditions, their positions relative to the Sun set them on drastically different developmental paths. Venus, being closer, became a furnace, while Earth, farther away, maintained the conditions necessary for life to thrive. The stark contrast between Venus and Earth is a sobering reminder of how subtle shifts in a planet's environment can lead to dramatic, irreversible changes. Venus once might have been a paradise with liquid water and a temperate climate. Today, it stands as a warning, one that reminds us how fragile the balance of life can be and how quickly a world can spiral into inhospitable chaos. Our existence here on Earth, with its perfect balance of conditions for life, may very well be the result of an improbable stroke of luck. When we contemplate the future, however, the long-term trajectory of our planet reveals a far less fortunate potential. As the sun continues to burn brighter and hotter over the course of billions of years, Earth's future may become eerily similar to that of Venus. Though this transformation will not occur in our lifetimes, or even for many generations to come, the vast timescales of the universe make it clear that Earth's fate could eventually mirror that of Venus, a hot, inhospitable world where life struggles to exist. For decades, scientists have pondered the possibility that Venus, too, might have once been a thriving planet much like Earth. But through various space missions, most notably the European Space Agency's Venus Express, our understanding of Venus has evolved dramatically. The spacecraft provided invaluable data about the planet's atmosphere and surface, revealing that Venus was not always the barren, lifeless world it is today. Despite its current desolation, the secrets concealed beneath Venus's thick clouds continue to intrigue scientists and challenge our understanding of planetary evolution. At first glance, Venus appears to be a calm and serene planet, with its shrouded skies of clouds stretching high into the atmosphere. But the true nature of this distant world is far from peaceful. Using infrared thermal imaging, spacecraft have uncovered a world in constant turmoil. Violent storms rage at its poles and massive cyclones spin with unrelenting force. The planet's atmosphere is in a perpetual state of chaos, its weather systems so extreme that they make the most ferocious storms on Earth appear tame in comparison. The intensity of Venus's weather systems is staggering. Storms here make even the strongest hurricanes on Earth look like mere breezes. But the discovery of Venus's tumultuous weather patterns doesn't stop there. As the exploration of Venus deepens, scientists have made an astonishing finding that continues to confound them. While Venus rotates incredibly slowly, taking 243 Earth days to complete one full rotation, its atmosphere moves with remarkable speed. In fact, winds on Venus circle the entire planet in just 4 Earth days. To put this in perspective, imagine if Earth's winds could move that quickly. In such a scenario, our planet's winds would sweep around the globe in just half an hour, reaching speeds of up to 50,000 miles per hour. But Earth's atmosphere behaves differently from Venus's, moving at a slower pace relative to the solid surface beneath it. On Venus, however, the atmosphere rotates far faster than the planet itself, a phenomenon known as superrotation. Superrotation leaves scientists scrambling to understand why Venus's winds move so much faster than its solid surface. The answer lies in Venus's thick, dense cloud cover, which reaches up to 12 miles in height. This cloud layer plays a critical role in trapping solar energy. Instead of allowing sunlight to penetrate to the surface as it does on Earth, Venus's clouds absorb much of the sun's energy, retaining it high in the atmosphere, around 40 miles above the surface. This trapped energy fuels the planet's wind systems, causing the atmosphere to whip around at speeds of up to 200 miles per hour, far stronger than anything Earth has ever experienced. As the investigation into Venus's atmosphere continues, the Venus Express mission uncovered another perplexing mystery: strange vortices at the planet's north pole. These vortices, resembling the hurricanes we see on Earth, baffled scientists for years. On Earth, hurricanes form when warm, moist air from the oceans rises, drawing in more energy, causing the clouds to rotate. But Venus has no oceans, so how could the planet sustain such powerful storms? The answer to this puzzle came when the Venus Express spacecraft ventured to the southern hemisphere. There, scientists found a massive vortex, one that stretched across 1,1200 miles and plunged 13 miles deep. This storm was 4 times larger than the largest hurricane ever recorded on Earth, and what made it even more remarkable was its unique structure. It had not 1, but 2 rotating eyes. These extraordinary vortices were a direct result of Venus's superrotation combined with the planet's own motion. The air near Venus's equator, heated by the sun, moves toward the poles, where it cools and sinks, forming a massive vortex that spans around 2,000 miles. The planet's rotation deflects the air, causing the formation of swirling storms. This phenomenon, driven by the Coriolis effect, a principle that describes how rotating systems cause moving air to veer off course, plays a key role in shaping these giant storms. To understand this, consider a rotating table with a ball placed on it. Without rotation, the ball moves in a straight line. But when the table rotates, the ball appears to move in a curve. On Venus, this effect causes the heated air to shift to the right in the southern hemisphere and to the left in the northern hemisphere, which contributes to the spiraling, swirling patterns of the vortices. While Earth's polar vortex remains relatively stable, the vortex at Venus's poles is anything but. The double-eyed vortex constantly shifts and changes, creating a chaotic, unpredictable weather system. To better understand this phenomenon, scientists have attempted to replicate the conditions of Venus's atmosphere in laboratory settings. In one such experiment, Dr. Wilson and his team used water to mimic the thick, dense atmosphere of Venus. By setting up a rotating tank and introducing a thin ring that spun faster than the rest of the liquid, they were able to simulate the movement of the atmosphere. The resulting turbulence was startlingly similar to the behavior of Venus's polar vortex. When colored dye was added to the tank, swirling, turbulent patterns emerged that closely mirrored the chaotic winds around Venus's poles. But the strange weather phenomena on Venus don't stop at these violent winds and swirling storms. On June 9, 2006, the Venus Express spacecraft detected an eerie, high-pitched whistle, followed by a burst of low-frequency electromagnetic energy. This strange occurrence set the scientific community abuzz, as it seemed to signal the presence of lightning. The idea that Venus might have lightning seemed implausible at first. After all, Earth's thunderstorms are driven by warm, moist air colliding with cold air, creating an electrical charge that discharges as lightning. But Venus's thick, cloud-covered atmosphere, devoid of oceans and moisture as we know it, seemed an unlikely candidate for lightning. However, Professor Christopher Russell of UCLA had long suspected that Venus could indeed experience lightning, albeit in a vastly different form from what we encounter on Earth. His suspicions were based on the fact that lightning can occur wherever there is sufficient electrical charge. On Earth, thunderstorms form when warm, moist air rises, causing ice crystals and water droplets to collide and build up static electricity. When this charge becomes too great, it discharges in the form of lightning. Could Venus, with its dense atmosphere and extreme heat, create similar conditions conducive to lightning strikes? The discovery of the unusual electromagnetic signals in 2006 raised more questions than answers, but it brought scientists closer to understanding the true nature of Venus's violent and mysterious weather systems. As humanity continues to peer into the depths of our neighboring planets, one thing becomes increasingly clear. Our planet, with its delicate balance of life-sustaining conditions, could be only a fleeting moment in the vast history of the universe. The future of Earth may one day resemble the inhospitable conditions we observe on Venus, an extreme, hostile world where the elements themselves seem to work against any form of life. As we study Venus, we not only learn more about our sister planet, but also gain a deeper understanding of the forces that shape the fate of planets throughout the cosmos. Venus, the second planet from the Sun, often evokes images of a barren, lifeless world, suffocated by thick clouds of sulfuric acid and subjected to extreme heat and pressure. With temperatures soaring to a blistering 900 degrees Fahrenheit, 475 degrees Celsius, Venus might seem like a place incapable of sustaining anything resembling life. But recent discoveries have begun to challenge this assumption, painting a far more dynamic and mysterious picture of our celestial neighbor. What scientists have uncovered over the years suggests that, far from being a lifeless planet, Venus could still harbor powerful, albeit hidden, forces at play beneath its hostile surface. The question of lightning on Venus was long a puzzle. The planet's atmosphere, mostly dry and stripped of water by the relentless solar wind, does not immediately suggest the presence of electrical storms. However, the answer began to emerge with data gathered from the Venus Express spacecraft. Russell's theory, based on findings from this mission, suggests that the violent storms on Venus could be caused by the planet's sulfuric acid clouds. On Earth, sulfuric acid clouds form when sulfur dioxide from volcanoes mixes with water vapor in the atmosphere, creating the perfect conditions for thunderstorms. A similar process happens on Venus. 2 decades ago, the first spacecraft to map Venus, Project Melon, provided clear evidence that volcanic activity has shaped the planet for millions of years. The eruption of Venusian volcanoes has released massive amounts of sulfur dioxide into the atmosphere. This sulfur dioxide either remains as a gas or combines with trace amounts of water vapor to form sulfuric acid clouds, which in turn are stirred by Venus's powerful winds. These clouds create an ideal environment for lightning to form, much like how water vapor creates thunderstorms on Earth. The sulfuric acid droplets collide, rubbing against each other, and generate both positive and negative charges that eventually discharge as lightning. When Russell and his team found direct evidence of lightning on Venus, it was a groundbreaking moment in planetary science. It confirmed that Venus's atmosphere was not only active, but also teeming with dynamic processes, some of which resemble those found on Earth. Yet, even as this discovery shattered preconceived notions of Venus as a dead planet, the surprises didn't stop there. In fact, a major breakthrough emerged in the understanding of Venus's geological activity. Fluctuating levels of sulfur in the atmosphere hinted that Venus's volcanoes might still be active. This discovery was profound, as only a few places in the universe, Earth being the most well-known, are home to active volcanoes. The continued volcanic eruptions on Venus could explain many of the atmospheric changes observed by scientists, making the planet far more dynamic than we had ever imagined. In 2007, the New Horizons probe made an exciting discovery, capturing images of an eruption on Io, one of Jupiter's moons. This was a milestone for the scientific community, signaling that active volcanoes still exist in the inner solar system. The discovery of ongoing volcanic activity on Venus was equally significant, suggesting that the planet, long considered a lifeless rock, might still be very much alive. The Venus Express spacecraft further unveiled the planet's secrets. Using infrared technology, it managed to peer through the thick sulfuric clouds shrouding the surface. What it revealed beneath these clouds stunned scientists. Massive mountains, deep valleys, smooth plains, and large, pancake-like flat-topped features, all shaped by lava. In fact, a staggering 85% of Venus's surface is covered by volcanic rock. But the question arises, why is there so much lava on Venus, and why does its surface appear so different from Earth's? Scientists have turned to Earth, Venus's twin planet, for answers. Earth's crust is made of tectonic plates that drift slowly over the molten mantle beneath, and much of Earth's volcanic activity occurs where these plates meet or diverge, allowing heat from the planet's core to escape. However, no mission to Venus has found any evidence of plate tectonics. Instead, its crust appears solid and unyielding. Without the mechanism of plate tectonics to regulate the planet's internal heat, Venus may have reached a point where the heat from its core built up until it could no longer be contained. This heat would have caused the entire planet to erupt in a massive planet-wide volcanic event, resurfacing Venus with molten lava. To demonstrate how this process might have unfolded, scientists conducted an experiment using pudding in a pan over a hot plate. The heat from the hot plate mimicked the internal heat of Venus. As the heat built up, the surface of the pudding cracked and molten lava poured out, covering the surface. This process illustrates how Venus may have undergone a massive resurfacing event around 500 million years ago, during which violent eruptions released trillions of tons of sulfur dioxide and carbon dioxide into the atmosphere, replenishing what had been stripped away by the solar wind. Despite the overwhelming evidence of volcanic activity, not all of Venus was resurfaced during this event. Some of the planet's older rocks, found in the highlands, are far older than the surrounding lava flows. These ancient rocks provide a tantalizing clue about Venus's distant past. Kevin Baines, a scientist studying these rocks, discovered something remarkable. These rocks were not formed on dry land, as one might expect on a planet with no liquid water. Instead, evidence suggests that they were created in the presence of water, possibly billions of years ago when Venus might have had oceans. This discovery raises the intriguing possibility that Venus, like Earth, could have once hosted life. The question of life on Venus takes on a new dimension when considering the role of lightning. Lightning on Earth is crucial for creating certain chemical compounds that are essential for life. For instance, when nitrogen and oxygen combine in the atmosphere, they form nitrogen oxides, which are critical for life's processes. If Venus once had water and lightning, it could have provided the perfect conditions to kickstart life, much as Earth's early environment did. Scientists have gathered considerable evidence that Venus and Earth were once quite similar. Both planets once had two key ingredients necessary for life: water and lightning. The presence of both would have created an environment where life could have potentially taken root. If Venus once had oceans and lightning, then the planet could have been the birthplace of life. Or perhaps it still is in some form. The Venus Express mission provided even more tantalizing clues. The spacecraft's camera, positioned 155 kilometers above Venus's surface, switched to ultraviolet light to peer through the planet's thick cloud cover. The images revealed strange, dark patches in the upper atmosphere where ultraviolet light was absorbed more than expected. These absorption patches intrigued scientists as they absorbed nearly half of the sunlight reaching Venus. Some researchers believe these patches could be linked to microbial life living in the sulfuric acid clouds, possibly using ultraviolet light in a unique form of photosynthesis. This discovery is supported by research conducted by biologist Lynn Rothschild, who specializes in extremophiles, organisms that thrive in the most hostile environments on Earth. Rothschild studies in places like Yellowstone National Park, where the hottest and most acidic thermal springs exist, have shown that certain organisms can survive in environments far harsher than anything most life forms could withstand. Some of these extremophiles, like Cyanidium, a type of algae, can survive in environments with low pH, high heat, and even pure carbon dioxide. These organisms show that life can adapt to extreme conditions. And if life can thrive in the acidic volcanic geysers of Earth, why couldn't it survive in the similarly hostile conditions on Venus? The surface of Venus remains incredibly harsh, with temperatures that could melt lead and pressures high enough to crush bones. However, if extremophiles can survive in Earth's most hostile environments, it's not out of the realm of possibility that some form of microbial life could exist in the sulfuric acid clouds of Venus, adapting to its extreme conditions. Venus may not be the lifeless, barren world it once appeared to be. Instead, it could be a place where life, in some form, has not only existed, but may still endure, hidden away beneath the planet's thick, turbulent clouds. However, things take a remarkable turn when we move just 30 meters into the thick clouds of Venus, where the temperature stabilizes at a surprisingly more tolerable 176 degrees Fahrenheit, 80 degrees Celsius. This is not just an arbitrary figure. This temperature is actually closer to the conditions in which certain types of microbes on Earth can survive. It opens up an intriguing question. Could life have once flourished in the ancient oceans of Venus? As Venus's surface became too hot and inhospitable, it's conceivable that life could have existed in these ancient oceans. But as the waters evaporated, the possibility arises that microbes might have been carried upward with it into the clouds. Now here's the tricky part. If there's no liquid water, how could life have survived? The good news is that Venus's clouds are rich in water vapor. Though it may not be in liquid form, it might still provide the hydration needed for life. On Earth, some organisms, like certain types of fungi, have been known to extract hydration from water vapor alone. Could the same be true for Venus? This opens up a new window of hope. If water vapor could support life on Venus, even in its harsh, acidic clouds, it suggests that the microbial life in these clouds might just have a chance to thrive. To investigate this theory, scientists like Rothschild have been experimenting on Earth. Rothschild collects air samples from above a hot spring, an environment on Earth with acidic steam very similar to Venus's clouds. When Rothschild examines these samples, she spots something surprising: a tiny speck of green. This small green patch hints at the possibility of something alive, and it's promising. It suggests that certain microbes could survive and even thrive in the hot, acidic steam, much like what we see in Venus's clouds. Taking this idea further, scientists like Lin have launched various types of microbes into the upper atmosphere. These microbes have been sent to altitudes as high as 100,000 feet, far higher than most creatures could survive. At these extreme heights, the temperatures and pressure are so intense that life as we know it would normally perish. Yet, remarkably, many of these microbes make it. Even more astounding is that some researchers have observed certain organisms reproducing in the rarefied air of the upper atmosphere. This shows that life may not only survive in extreme conditions, but could potentially reproduce at such altitudes. Venus's clouds are thick, swirling masses of gases that endure for long periods, making them a potentially ideal habitat for life. In theory, life could continue to thrive in these clouds, reproducing and spreading across the vast expanse of Venus's atmosphere. However, these organisms wouldn't remain in the clouds forever. Eventually, they would fall to the planet's surface. But as long as they could reproduce in the clouds, a self-sustaining colony could exist, floating and multiplying in the upper atmosphere. Research has shown that life in such extreme, hot, and acidic conditions is not just a speculative idea. It's entirely feasible. Furthermore, the dark patches on Venus, visible from space, have long intrigued scientists. The Venus Express mission, which orbited Venus for more than 100 weeks, uncovered evidence that Venus might once have been far more Earth-like. It could have had a climate that supported oceans and perhaps even life. Unfortunately, being so close to the Sun, Venus became the uninhabitable world we know today, as it was bombarded with extreme heat. While Earth flourished, Venus transformed into an oven. Yet the possibility remains. Life might still persist in the clouds of Venus, hidden in plain sight. We don't yet have definitive answers, but future missions to Venus might one day reveal the existence of life in the clouds of this mysterious world. Now, shifting our gaze to Jupiter, an entirely different giant of the solar system, our understanding of this immense, swirling gas planet remains one of the greatest puzzles in modern astronomy. Jupiter's size is staggering. It is so vast that it could fit over 1,300 Earths within its enormous volume. And yet, despite its size, Jupiter lacks a solid surface. Instead, it is a chaotic world of violent storms and turbulent winds, with winds reaching speeds of 400 miles per hour and storms so massive that the Great Red Spot alone could engulf the entire Earth. 3 times over, Jupiter presents an environment far more hostile than Venus. Despite its hostile nature, Jupiter holds the key to understanding the formation of planets and the mechanisms driving our solar system. And within this tumultuous world, scientists are uncovering new insights that could point toward one of the greatest mysteries of all. Is there life elsewhere in the universe? Over the past 50 years, missions to outer space have uncovered wonders we never dreamed possible. From towering mountains on Mars to the methane lakes of Saturn, the discoveries have been nothing short of extraordinary. However, no planet has captured our imagination quite like Jupiter. As the largest and most mysterious planet in our solar system, it continues to fascinate scientists and researchers alike. Much of what we know about Jupiter comes from the Galileo mission, launched in 1989 aboard the Space Shuttle Atlantis. The information gleaned from this mission has not only expanded our understanding of Jupiter, but has also provided insights into the very formation of our solar system. Galileo's groundbreaking discoveries have helped answer questions about the gas giant's composition, its atmosphere, and even its moons. Jupiter is a massive ball of gas and liquid, 11 times the size of Earth, and is constantly filled with violent storms and intense lightning bolts. These storms are thousands of times more powerful than the strongest hurricanes on Earth. Jupiter even has a faint ring system, though unlike Saturn's, it is too faint to be seen without specialized telescopes. One of the most notable features of Jupiter is the Great Red Spot, a colossal storm that has been raging for centuries, with winds that can reach speeds of 250 miles per hour. This storm is so vast that it could easily engulf Earth multiple times. Around Jupiter, there are 63 moons, each with its own unique characteristics. Of these, Galileo's mission focused on the 4 largest: Io, Europa, Ganymede, and Callisto. Each of these moons is a world unto itself, holding the promise of new discoveries and hidden secrets. Io, the closest moon to Jupiter, is a volcanic world, constantly reshaped by massive eruptions of sulfur dioxide. Its surface, painted in brilliant reds and yellows, has earned it the nickname the Pizza Moon. Ganymede, the largest of Jupiter's moons, is a world of ice and rock, while Europa, perhaps the most intriguing of them all, may harbor a hidden liquid ocean beneath its frozen surface, an environment where life could potentially exist. To probe the mysteries of Jupiter and its moons, a new generation of space missions is underway, including Juno, the Europa Clipper, and the underwater probe Endurance. These missions aim to reveal the secrets of these alien worlds, providing answers to questions that have baffled scientists for decades. Before the Galileo mission, space missions could only offer distant views of Jupiter. In the 1970s and 80s, the Pioneer and Voyager missions passed by the gas giant, giving us our first glimpses of this massive planet and its moons. However, these early missions left far more questions than answers. How did Jupiter form? What drives its intense storms? Why are its moons so geologically active? To tackle these complex questions, the Galileo team faced significant challenges. The spacecraft didn't have enough fuel to fly directly to Jupiter, so NASA engineers devised a brilliant solution. Instead of heading straight to the planet, the spacecraft would first fly to Venus, then Earth, using their gravitational pull to slingshot toward its final destination. This clever maneuver saved precious fuel and accelerated Galileo's journey to Jupiter. After a 6-year voyage, Galileo finally reached its target. The spacecraft deployed a small probe that descended into the depths of Jupiter's atmosphere, and where it would endure crushing pressure and extreme temperatures for just under an hour. In that brief window, the probe would collect invaluable data, offering insights into the heart of the planet. Scientists were eagerly awaiting the groundbreaking information that the spacecraft would send back, data that might help answer the profound questions humanity has been asking for centuries. As Galileo approaches the end of its mission, we are left with a sense of awe at the vastness of the universe and the mysteries that await discovery. The journey to understand these alien worlds has only just begun, and who knows what wonders await us in the years to come. It finds itself in the perfect position to witness one of the most extraordinary phenomena in the solar system. A colossal comet hurtling towards Jupiter is about to collide with the gas giant. This rare and unprecedented event could potentially unlock some of the most elusive secrets surrounding Jupiter's past and possibly the origins of our entire solar system. For years, scientists have been stumped by one central question: how was Jupiter formed? Up until this pivotal moment, the prevailing theory was that Jupiter was constructed from the leftover material left behind after the formation of the Sun, essentially a cold, primordial planet. If this theory was correct, then the chemical makeup of Jupiter should closely resemble that of the Sun itself. That meant the planet's composition would be primarily hydrogen and helium, the same elements that make up the vast majority of the Sun's mass. But the comet's impact promised something far more revealing. If this theory were to hold, the chemicals within Jupiter would be uniform and predictable. Yet, the collision could send shockwaves deep into the planet's atmosphere, stirring up hidden elements and allowing scientists to study a fresh and unexplored sample of Jupiter's deep internal chemistry. This was the perfect opportunity to test the validity of the long-standing theory. However, the scientists standing by were about to witness something far beyond what they ever anticipated. "I couldn't believe it," one scientist recalls. "We were about to watch one body in the solar system collide with another, with a front row seat to one of the most incredible events in astronomical history." The comet, known as Shoemaker-Levy 9 or SL9, was first discovered by astronomer David Levy, and its collision with Jupiter would mark the first time in recorded history that an object from space would directly strike a planet in such a dramatic fashion. There were no guarantees as to what this unprecedented event might reveal, but one thing was certain: it was bound to shake up everything scientists thought they knew. As the day of the collision arrived, telescopes across the world, from mountaintop observatories to space-based telescopes, were trained on a specific patch of the sky, their lenses fixed on the incoming comet. Theories varied. Some scientists believed that Jupiter's dense, turbulent atmosphere would simply absorb the comet, leaving no trace of the impact. Others were more hopeful, speculating that the collision would excavate materials from the deep layers of the planet, providing unprecedented insights into the true composition of Jupiter. Jupiter, being the largest planet in our solar system, is an imposing behemoth, and the comet was comparatively small. Many experts predicted that the event would be a non-event, little more than a brief display of fireworks. We thought it would fizzle out, one scientist confesses, but we had no idea how lucky we were. As the comet approached Jupiter, the immense gravitational pull of the gas giant began to tear the icy body apart, fragmenting it into 20 separate pieces, some as large as a mile across. Astronomers around the globe were on the edge of their seats, waiting for the next moment. The pieces of the comet rained down on Jupiter one after another, each impact releasing an unimaginable amount of energy, equivalent to the force of 300 million atomic bombs. With each explosion, a fiery plume of gas and debris erupted from the planet's surface, shooting up to 2,000 miles above Jupiter's thick cloud layers. The impacts didn't just create spectacular fireballs, they also unleashed massive black clouds visible across the entire southern hemisphere of Jupiter. These clouds were so enormous, they were nearly the size of Earth itself. The first clear images of this celestial drama came from the Galileo spacecraft and the Hubble Space Telescope. Yet, while the visual spectacle was mesmerizing, it was the scientific data that truly amazed the experts. The most astonishing discovery came from the shock waves that the comet's impacts generated as they rippled through Jupiter's upper atmosphere. These shock waves were unlike anything scientists had anticipated. It was like throwing a rock into a pool, one researcher explains. The ripples spread out in all directions, and the speed of these waves told us something we didn't expect. There was more water in Jupiter's atmosphere than we thought possible. The shock waves propagated in a pattern that revealed an abundance of water vapor, far more than scientists had believed was present in the gas giant. This discovery was groundbreaking. Jupiter was not the simple, sun-like planet they had once assumed. It contained far more water, which led to a cascade of new questions about the planet's origins. Could it be that Jupiter was formed in a different way than previously thought? Perhaps it wasn't a leftover chunk from the birth of the sun, but rather something far more complex. The discovery was so significant that it shattered long-standing assumptions about Jupiter's formation, calling for a completely new theory to explain the planet's makeup. As a result of this momentous finding, the scientific community now had a clear goal. A new theory was needed to account for Jupiter's chemical composition, one that could explain the presence of such a high concentration of water vapor in the atmosphere. But the questions weren't over yet. 17 months later, the Galileo spacecraft, equipped with the tools necessary to further probe Jupiter's mysteries, would make its final approach to the gas giant, eager to continue the search for answers. By the time Galileo reached Jupiter, the team of scientists was buzzing with anticipation. They had just learned that Jupiter contained at least 10 times more water than they had originally suspected. If this was true, it would force scientists to reconsider everything they knew about the planet's formation. The stakes were high. Galileo's first mission was to directly analyze the chemistry of Jupiter's atmosphere, with a particular focus on measuring the amount of water present. To do this, Galileo released a small probe into the heart of Jupiter's dense cloud layers. This probe was equipped with the ability to measure more than just the water content, and it was designed to collect data on wind speeds, atmospheric pressures, and temperatures at various depths. Critical information that could help explain the extreme and violent weather patterns observed on the planet's surface. But as the probe descended deeper into the swirling storm clouds, a palpable sense of excitement filled the air. Scientists hoped that the probe would detect the layer of water vapor revealed by the Shoemaker-Levy 9 impact years earlier. This discovery would, in turn, provide crucial evidence to answer the question of Jupiter's true origins. One scientist even joked, "I'd bet anyone $1 that the probe will find more water than expected." And so, as the probe continued its descent into the vast, uncharted depths of Jupiter's atmosphere, Everyone watched with bated breath, waiting for the moment that would finally reveal whether this gas giant was truly a distant cousin of the Sun, or something far more mysterious. The mission to unravel the mysteries of Jupiter's atmospheric anomalies began with a simple, yet astonishing discovery. As the probe entered a narrow gap in the clouds, a seemingly dry stretch, it expected to find the abundant water it had been searching for. But what it encountered instead was a thin, wispy layer of gases. The probe was soaring through a downdraft, encountering conditions that baffled the scientists monitoring its every move. Where was the water? Where was the expected moisture that should have been a cornerstone of Jupiter's weather system? It quickly became clear to the researchers that Jupiter's atmosphere was far from uniform. There were distinct dry zones along with wetter patches. The probe's data revealed weather patterns that were both unfamiliar and perplexing. For scientists, the most pressing question became clear. Why was there so little water present in the atmosphere, especially in areas where it should have been abundant? This new information called into question everything scientists thought they knew about the formation of the solar system. As the probe made its way deeper into Jupiter's atmosphere, the situation became even more puzzling. Instead of encountering the anticipated water, the probe instead detected a remarkable abundance of heavier elements: argon, krypton, carbon, and nitrogen, elements that were found in concentrations 2 to 3 times greater than those in the Sun itself. This discovery had major implications. These elements only form in environments of extreme cold, far colder than what Jupiter's present location would suggest. For astronomers, this discovery was as surprising as it was unsettling. It meant that Jupiter's formation was much more complex than they had ever imagined. The probe's findings hinted at the possibility that Jupiter might have formed in a much colder part of the solar system, potentially much farther out where temperatures were far lower. The heavy elements detected could have come from material that originated from these outer reaches, materials that somehow found their way to Jupiter. Alternatively, comets or asteroids could have brought these elements, along with water, to the planet. These revelations were nothing short of a bombshell. They forced scientists to reconsider the fundamental principles behind planet formation. The idea that Jupiter might have evolved in an entirely different manner from the Sun challenged long-held assumptions and opened up new avenues of inquiry. Could Jupiter have migrated inward from the outer solar system? Or had the early solar system been more chaotic than previously believed, with planets forming in unexpected ways? The probe's data raised these questions and more, but just as it seemed the mystery was about to be solved, disaster struck. Less than an hour after the probe had begun sending its groundbreaking data, it was destroyed, incinerated in the heart of Jupiter's inner atmosphere. Though the probe's data had illuminated many of the unknowns about Jupiter's composition, the most significant questions remained unanswered. However, in 2011, a new mission, Juno, would be launched with the goal of finally solving these mysteries once and for all. Juno's mission was to get even closer to Jupiter than ever before, gathering more precise data using state-of-the-art technology. One of its key instruments, a radiometer, would scan the planet's atmosphere in search of water, an essential clue to understanding Jupiter's origins and the processes that governed its formation. The question that scientists were now seeking to answer was more profound than ever before. What were the building blocks of Jupiter, and how could understanding them unlock the mysteries of planet formation? By studying Jupiter's composition, scientists hope to uncover the recipe that led to the creation of planets like Earth. The answers would help us understand not just Jupiter, but the origins of all the planets in the solar system. As Juno continued its mission, focusing on Jupiter's mysterious weather patterns became a priority. The most iconic of these features was Jupiter's Great Red Spot, a colossal storm system that had been raging for over 300 years. For scientists, the question was simple but profound. How could a storm 3 times the size of Earth continue to exist for centuries without losing its energy? On Earth, storms of that magnitude typically only lasted a few days or weeks. Yet on Jupiter, the Great Red Spot persisted, surviving for centuries. Jupiter's weather is a chaotic, unpredictable mix of massive storms, swirling clouds, and powerful lightning systems. While weather on Earth is driven by the heat from the sun, Jupiter is positioned far from the sun, over 500 million miles away. This posed a significant question. What other force was driving Jupiter's immense storms? What was fueling the Great Red Spot's unrelenting energy? The red coloration of the Great Red Spot itself offers some clues. Scientists believe it's the result of chemicals exposed to intense ultraviolet light, which react and change color. Yet even with this knowledge, the storm's longevity and power remain a mystery. Scientists had been observing the Great Red Spot for over 300 years, but there was still so much they didn't understand about its behavior. To uncover the energy sources driving these storms, the Galileo spacecraft, which was tasked with studying Jupiter, attempted to capture video footage of the Great Red Spot and other storms. However, the high-gain antenna, which was essential for continuous video recording, had failed. The team had to get creative. Instead of capturing footage in real time, they adopted a method of taking intermittent snapshots. The idea was to photograph the Great Red Spot at intervals, allowing them to track how it and other storms evolved over time. Their observations revealed that Jupiter's smaller storms, those marked by white spots, might hold the key to understanding how massive storms like the Great Red Spot were powered. These smaller white spots were likely the result of convection, rapidly rising air masses that could fuel larger storms. The team also detected intense lightning activity associated with these white spots, confirming the presence of thunderstorms. The identification of these storms was a critical step in understanding how they formed and interacted. In the 1930s, 3 white ovals appeared on Jupiter's surface, and over time, they merged into a single massive storm. 2 of these ovals combined into a larger storm, and 2 years later, the third oval merged as well. This fusion created a storm belt beneath the Great Red Spot, and over time, it transformed into a feature that resembled the Great Red Spot itself, though not as large. This new feature became known as the Red Spot Junior. The formation of this storm offered scientists new insights into how massive systems on Jupiter could gather so much energy and persist for so long. But this wasn't the only revelation. The smaller storms, which appeared to feed into larger ones, suggested a kind of natural food chain, where bigger storms consumed smaller ones. This process seemed to be one of the primary mechanisms through which Jupiter's enormous weather systems were powered. These tiny thunderstorms served as the primary energy sources for the entire planet, driving its chaotic and ever-changing weather. Still, there was a puzzle that remained unsolved. Why did these massive storms, including the Great Red Spot, last for so long? On Earth, storms like tornadoes are short-lived. They dissipate after a matter of hours or days. But on Jupiter, these vortices remain stable and powerful for centuries. The answer, it turned out, may lie in Jupiter's rapid rotation. The planet spins 22 times faster than Earth, and this could play a crucial role in the longevity of its storms. In fast-spinning systems, vortices tend to remain intact for much longer than they would in slower systems. Jupiter's intense rotational speed stabilizes its atmospheric systems, preventing storms from breaking apart. This discovery helped explain why Jupiter's storms, particularly the Great Red Spot, could persist for centuries without losing strength. Imagine for a moment mixing 2 different colored dyes into a jar of water. At first, the mixture looks chaotic, but eventually, distinct whirlpools form, stable and long-lasting. This is analogous to the behavior of Jupiter's storms. The planet's rapidly rotating atmosphere creates large, stable structures that are able to maintain their shape over time, rather than being torn apart by turbulent forces. Despite all the breakthroughs, the Galileo mission, though groundbreaking, couldn't explain everything about Jupiter. One of the planet's most iconic features, the striking red, white, and brown stripes, remained a mystery. Initially, scientists believed that these colors were caused by gases rising and sinking in Jupiter's atmosphere. However, Galileo's findings suggested that the full explanation was more complex. Jupiter's atmosphere is incredibly thick, hundreds of miles deep, and only its surface layer is visible to us. The planet's high-speed winds blow in opposite directions, creating the planet's colorful bands. These bands likely represent areas where gases are rising and sinking, but they may not all be confined to the surface layer. To truly understand the dynamics behind Jupiter's distinctive stripes, scientists needed a deeper view. This is where the Juno mission, launched in 2011, stepped in. Juno's mission was to go where no previous spacecraft had gone before, into the depths of Jupiter's atmosphere. The goal was to explore the inner workings of the planet, to uncover how it spins, and to understand its structure. Was Jupiter's atmosphere a solid mass, rotating as one entity, or was it more like an onion, with layers rotating at different speeds and directions? Juno would map Jupiter's atmosphere to a depth of over 350 miles, revealing the planet's deepest secrets. With each orbit, 32 in total, each lasting 11 days, Juno would collect new data, gradually shifting its path to scan new parts of the planet. Through this mission, scientists hoped to finally answer the lingering questions about Jupiter's weather, its storm systems, and its atmosphere. What they had learned so far was revolutionary, but the planet's true nature remained just beyond their grasp, waiting to be uncovered by the next wave of discovery. The rapid rotation of Jupiter is not merely a captivating feature in itself, but is, in fact, the driving force behind the planet's most immense and powerful feature, its magnetic field. This swirling rotation sets the stage for an extraordinary cosmic phenomenon, one that stretches far beyond the planet itself. By studying Jupiter's magnetic system, scientists gain not only insight into the planet's own majestic force, but also valuable clues about Earth's magnetic field. Earth's magnetic field, much like Jupiter's, is generated by the swirling motion of molten iron deep beneath the surface within the planet's core. While Earth's field is powered by a molten metallic core, Jupiter's situation is far more complex. Jupiter, a gas giant, has a core that is so intensely compressed that hydrogen behaves in a way that is unrecognizable from the hydrogen we know. It transforms into a substance that behaves like liquid metal. The immense pressure at the core causes the hydrogen to adopt metallic properties, and as it circulates within Jupiter's interior, it generates powerful electrical currents. These currents, in turn, create a magnetic field that stretches out across vast distances, influencing the surrounding environment in ways that are awe-inspiring. This magnetic field, generated by the churning metallic hydrogen at Jupiter's core, is not just a localized phenomenon. It is enormous, reaching far into space, spanning an area that extends all the way to Saturn and beyond. The magnetic field itself is a cosmic force of staggering proportions, reaching sizes up to 100 times the size of Jupiter. Its immense reach allows it to capture charged particles and gases, creating an influence so far-reaching that its tail stretches all the way back to Saturn's orbit, pushed by the constant force of the solar wind. Jupiter's magnetic field, the largest structure in the entire solar system, is so vast that if we could observe it from Earth, it would appear larger than our moon. But the sheer size of the field is only the beginning. Its strength is enough to redirect material expelled by Jupiter's volcanic moon, Io, in a dramatic show of cosmic influence. Io's constant sulfur emissions, the result of its volcanic eruptions, are funneled toward Jupiter's poles, where they interact with the magnetic field, creating dazzling auroras that are strikingly similar to Earth's northern and southern lights. These spectacular light shows are the result of charged particles from the volcanic eruptions interacting with Jupiter's magnetic field. For the first time, NASA's Juno mission is delving into these interactions, studying the auroras by flying beneath Jupiter's radiation belts and through the charged particles responsible for these extraordinary displays of light. By carefully analyzing the charged particles and magnetic fields at play, the Juno team hopes to uncover hidden secrets that could offer profound insights into the dynamic processes driving Earth's own magnetic field. Jupiter's magnetic field, however, is just one part of the intricate and mysterious Jovian system. Its moons are not lifeless rocks frozen in time. They are vibrant, dynamic worlds full of surprises and intriguing possibilities. These moons, with their own peculiarities and secrets, are crucial pieces in the puzzle of understanding the nature of life beyond Earth. The Jovian system, with its 63 moons, many of which are so massive they could qualify as planets in their own right, presents a wealth of unanswered questions. Why, for example, are these moons so hot and geologically active? What makes them different from smaller planets and moons, which tend to cool down relatively quickly over time? The answers to these questions may hold the key to understanding one of humanity's most profound mysteries, the possibility of life on other worlds. Among Jupiter's many moons, 4 stand out as particularly intriguing: Ganymede, Callisto, Io, and Europa. Each one is unique, with secrets waiting to be uncovered. These moons engage in a cosmic ballet, dancing in a predictable yet mysterious pattern. Ganymede takes 1 orbit around Jupiter for every 2 orbits completed by Europa, and Io orbits 4 times for each orbit of Ganymede. This extraordinary synchronization hints at a deeper underlying connection between the moons, one that suggests a complex gravitational relationship. When Galileo first observed these moons, astronomers expected to find cold, dead rocks coated in ice. Instead, they discovered vibrant, dynamic worlds brimming with activity, full of surprises and anomalies that defied expectations. First, Ganymede, the largest moon in the solar system. If Ganymede were orbiting the Sun instead of Jupiter, it would be classified as a planet. NASA's high-resolution images of Ganymede reveal a stunning landscape marked by mountains, valleys, craters, and even frozen lava flows. But what astonished scientists most was the unexpected readings from Galileo's magnetometer, which suggested that Ganymede might possess its own magnetic field. This was a groundbreaking revelation. Ganymede is the only moon in the solar system known to have its own magnetic field. However, this discovery posed a puzzling question. If Ganymede has a magnetic field, why hasn't it cooled down to the point of becoming solid throughout? Given its age, over 4 billion years, scientists had always assumed Ganymede's interior would have long since solidified. The presence of a magnetic field indicated that something extraordinary had occurred in the moon's past, something powerful enough to keep its interior molten. This discovery forced scientists to reevaluate everything they knew about the moon's evolution. Ganymede, once thought to be a simple satellite of Jupiter, emerged as a world unto itself, with a history more complex and dynamic than anyone could have predicted. But the surprises didn't end there. Galileo didn't just detect a magnetic field around Ganymede. The spacecraft found a second, varying field, which hinted at the presence of a liquid water ocean beneath the moon's icy surface. This tantalizing discovery raised more questions. What forces are at work inside Ganymede? What secrets could its hidden ocean hold? As Galileo's orbit carried it away from the moon, scientists were left with more questions than answers, eager to return and uncover the moon's mysteries in future missions. Callisto, the outermost of Jupiter's 4 largest moons, holds its own set of enigmatic features. A world of ice and rock, Callisto is home to one of the oldest and most heavily cratered surfaces in the entire solar system. Its surface bears the scars of ancient impacts from meteorites, and yet there is a strange feature that baffles scientists: bright-rimmed craters where the dark surface material has seemingly slipped away, revealing lighter layers beneath. This phenomenon has never been observed on Earth, leaving scientists wondering what could be causing this material to shift. As Callisto's mysteries unfold, it becomes increasingly apparent that this moon, too, defies simple explanation. Despite its surface temperature being a frigid 9,279 degrees Fahrenheit, data from the Galileo spacecraft suggests that Callisto, much like Ganymede, may not be completely frozen solid. The moon exhibits signs of a weak magnetic field, which suggests the possibility of an ocean beneath its surface. Yet, even more perplexing is the fact that Callisto appears to have a unique interior composition. Below its surface, about 125 miles deep, Callisto contains a mixture of rock, metal, and ice all the way to its core. According to standard models of moon and planet formation, such a large moon should have undergone a process of differentiation, where materials would have separated into distinct layers of rock, ice, and metal, due to the heat generated during its formation. But Callisto seems to have escaped this fate. Its lack of internal heating raises questions that challenge our understanding of how moons and planets evolve. And then there is Io. Slightly smaller than Earth's moon, Io is the closest of Jupiter's 4 largest moons. It is by far the most volcanically active body in the entire solar system, with over 400 volcanoes, some reaching diameters of over 120 miles. The landscape of Io is constantly changing, reshaped by its relentless volcanic activity. If you could view Io from above, you would witness towering plumes of gas, massive lava flows, and lakes of molten lava, all in an astonishing array of vibrant colors. The moon's surface is in a constant state of flux, and this dramatic geological activity is so intense that the appearance of the surface changes drastically over just a few decades. Pictures taken by Galileo look remarkably different from those taken by the Voyager spacecraft 2 decades earlier. Huge craters seem to appear and disappear, and it is believed that massive sulfur gas plumes shooting up to 200 miles into the atmosphere are responsible for this transformation. The material deposited by these plumes gradually erases the craters, revealing a constantly shifting and dynamic world. As we continue to explore Jupiter and its fascinating moons, we are reminded of just how much remains unknown about the universe. Each new discovery raises even more questions, fueling our curiosity and expanding the boundaries of what we thought was possible. Jupiter's magnetic field, its moons, and the extraordinary phenomena that occur within its gravitational influence remind us that the universe is far more complex and mysterious than we could have ever imagined. However, there's a remarkable mystery that surrounds Io, one of Jupiter's most intriguing moons. The intense volcanic activity occurring on this small, distant world demands an enormous amount of heat, far more than we would expect given its location. Io is situated about 500 million miles away from the Sun, in a region of space where the temperature should be incredibly cold, too frigid for such energetic volcanic processes to occur. So the question arises, where is all this heat coming from? The answer may lie in the gravitational forces of Jupiter itself. The massive gas giant's immense gravitational pull keeps Io locked in a steady orbit. But there's more at play. As Io moves along its orbit around Jupiter, it doesn't simply travel in a straight line. The moon's path brings it close to the orbits of Jupiter's other moons, and the gravitational forces exerted by these moons tug and pull at Io. This constant distortion of Io's shape creates friction within the moon's interior. That friction, much like the friction generated when two objects rub against each other, generates a considerable amount of heat, which melts the rock beneath Io's surface. This heat powers the moon's active volcanoes, producing dramatic eruptions that can shoot plumes of material hundreds of miles into space. It's a phenomenon not entirely unlike the tides we experience here on Earth, which are caused by the gravitational pull of the moon. But on Io, the effect is on a much grander scale. The entire surface of the moon rises and falls by more than 300 feet, a movement that creates an environment constantly in flux. This stretching and squeezing of Io's surface is so extreme that it makes the moon's surface appear to be a world under constant stress, as if it were being pulled apart like taffy. The incredible forces acting upon Io are a reminder of how dynamic and violent the processes shaping celestial bodies can be. As bizarre and awe-inspiring as Io's volcanic activity is, it might not even be the most unusual of Jupiter's many moons. Next in line is Europa, which presents its own set of mysteries. Europa's surface is a strange landscape of ice, etched with unusual geological features and a network of parallel cracks. But it's what lies beneath that icy shell that makes this moon so fascinating. Scientists suspect that beneath Europa's frozen exterior might lie a hidden secret, one that could contain the necessary ingredients for life itself. When the Galileo spacecraft passed by Europa, it captured detailed images of the moon's surface. These images revealed a pale, pinkish-white world, but there was something odd about the surface. It seemed to have fewer impact craters than expected. This anomaly suggested that something was erasing the craters after they had formed. At first, scientists could only speculate about the cause of this mysterious surface activity, but soon they began to hypothesize that beneath Europa's icy crust, there could be a vast hidden ocean of liquid water. This discovery opened a new chapter in the study of Europa and spurred scientists to extend Galileo's mission. The mission, which was initially designed to conduct only 3 flybys, was extended in order to explore Europa further after these surprising revelations. Galileo's primary objective was to capture more detailed images of Europa's surface, but researchers quickly realized that they needed to understand more about the moon's active processes. What was erasing the craters, and was this activity occurring rapidly or over long periods of time? At first, scientists thought that Europa's surface could be billions of years old, but as the data from Galileo accumulated, their thinking began to change. After just a few flybys, they revised their estimate to suggest that the surface could be only a couple of billion years old. As the mission progressed, the idea that Europa's surface might be only 100,000 years old began to take hold. It seemed possible that this frozen moon was still geologically active, with processes continuously reshaping its surface. One of the most puzzling findings came when scientists began studying Europa's magnetic field. As the moon orbited Jupiter, its magnetic field fluctuated in a way that indicated the presence of a conductive layer beneath the surface. This layer was allowing Jupiter's powerful magnetic field to pass through Europa. The only logical explanation for this was the existence of a vast ocean beneath Europa's icy crust, an ocean that was both surprising and remarkable. In fact, this hidden ocean could cover the entire moon to a depth of around 100 kilometers, making it the largest body of liquid water known in the solar system. But the real question was, how could this ocean remain liquid despite the freezing temperatures on Europa's surface, which can plunge as low as minus 260 degrees Fahrenheit? Scientists believe that the immense gravitational pull exerted by Jupiter could be the key. As Jupiter's gravity stretches and compresses Europa, it generates internal heat, which may be enough to keep the ocean beneath the surface from freezing solid. This process could also explain the moon's ever-changing surface, which shows evidence of tectonic-like movements. One of the most striking features of Europa's surface, as captured in images from Galileo, is a series of strange ridges that stretch across the moon for thousands of kilometers. These ridges didn't seem to match anything found on Earth, and at first, scientists couldn't figure out their origin. However, planetary scientist Bob Popal has since recreated the process in the lab using ice blocks to simulate the behavior of Europa's surface. As Europa is stretched by Jupiter's gravitational forces, its icy surface bends and cracks. Ice slides along these fractures, generating heat that causes warm ice to rise, forming the peculiar ridges that Galileo observed. This suggests that Europa's surface is in a constant state of movement, with heat from below playing a crucial role in shaping it. But the mysteries don't end there. Galileo's data also revealed signs of heat and movement beneath the ice, hinting at the possibility of ice volcanoes or geysers. In addition, scientists observed strange brown and red stains scattered across the surface, likely caused by salty material from the ocean below, which rises through cracks in the ice. These features, including pits and domes, could be the result of blobs of warm ice pushing up from beneath the surface, resembling the movement seen in a lava lamp. The search for life on Europa has become one of the most exciting aspects of studying this enigmatic moon. If the ocean beneath its icy crust is as vast and warm as scientists suspect, it could potentially harbor hydrothermal vents, hotspots for life on Earth. Galileo's data even suggested that carbon dioxide, an essential ingredient for life, might be leaking out from the ocean below. This discovery has sparked a growing belief among scientists that if life exists anywhere beyond Earth, Europa's ocean might just be one of the most promising places to search. In the coming years, Europa will once again take center stage in space exploration. A mission called Europa Clipper, scheduled for launch in the 2030s, will return to the moon to study its surface and internal structure in unprecedented detail. This groundbreaking mission will search for potential ways to access the hidden ocean beneath the ice, study the moon's gravity in fine detail, and analyze the surface composition to understand its geology. One of the primary goals of the mission will be to study the tidal forces that cause Europa's icy shell to flex, generating the heat needed to sustain the subsurface ocean. The Europa Clipper mission will employ advanced radar technology, which will provide scientists with a three-dimensional map of Europa's outer crust. This will allow them to determine critical details, such as the thickness of the ice shell and the depth of the ocean beneath. Understanding these key factors is essential to understanding whether Europa's ocean is truly vast, and if so, how deep it might go. Once scientists know the thickness of Europa's ice shell, the next challenge will be to break through it. To do so, a new generation of space probes will be required, vehicles designed to land on Europa and explore beneath the ice. One such robot, named Endurance, is currently operating in Antarctica. Endurance is an autonomous underwater submarine designed to navigate beneath thick ice. Unlike other space probes, which rely on commands from Earth, Endurance must make its own decisions as it explores hidden lakes beneath 15 feet of ice. This revolutionary technology could one day be used to explore Europa's ocean. But first, the problem of how to break through the thick ice must be solved. Melting through Europa's ice will be no easy task. It will require a tremendous amount of energy, and it's likely that a nuclear-powered system will be necessary. It could take weeks or even months to melt through the icy barrier, and once a spacecraft finally reaches the ocean beneath, a new and exciting world of exploration will open up. Discovering life on another world would be one of the greatest achievements in human history, and Europa's mysterious ocean may hold the key to answering one of the most profound questions humanity has ever asked. Are we alone in the universe? Imagine a world where the most basic building blocks of life exist in the most unexpected places. We are not talking about gigantic creatures such as fish or whales, but the possibility of the tiniest forms of life, microorganisms living in the depths of Europa's hidden ocean. Could there be single-celled organisms thriving beneath the icy surface of this mysterious moon? Even the discovery of something as simple as bacteria would be extraordinary, reshaping our understanding of life in the universe. Yet who knows? Perhaps even more complex forms of life are swimming in those alien waters, waiting to be discovered. The implications would be nothing short of monumental. The existence of life on Europa would challenge everything we know about the conditions required for life to thrive. If life can emerge in Europa's dark, frigid waters, then could it not be possible for life to exist in many other distant and seemingly inhospitable environments? Such a discovery would be mind-blowing, not only because it would prove that life exists elsewhere, but because it would suggest that life is far more adaptable and resilient than we ever imagined. In fact, it would mean that the potential for life could be widespread across the universe, lurking in places we have yet to explore. Europa is just one of Jupiter's many moons, each of which has been altering our perception of the solar system. While Earth remains the only known planet teeming with life, the moons of Jupiter have the potential to shift this paradigm completely. Europa, with its vast subterranean ocean, has become one of the prime targets for future space missions. If life can exist in such an extreme environment, it would suggest that Earth is not the only cradle for life in the cosmos. Who knows? The moons of Jupiter may not only reveal life, but perhaps even intelligence. In the grand scheme of things, Earth's existence is but a brief moment in the timeline of the universe. Our planet is around 4.5 billion years old, a massive sphere weighing an almost unfathomable 6 trillion tons. In this vast stretch of time, Earth has survived asteroid impacts, massive volcanic eruptions, and cosmic radiation, all forces capable of tearing apart entire worlds. Yet despite all these catastrophes, Earth remains steadfast. However, what if a more devastating force came along, one that could wipe Earth from existence? What if Earth's ultimate doom were not something out of our control, but the result of forces we could unleash ourselves? Using cutting-edge physics and planetary science, we can explore the most terrifying ways Earth could meet its end. Imagine a force so powerful that nothing, not even light, can escape its grasp. That force is a black hole, one of the deadliest objects in the universe. While they may seem distant and harmless, black holes are capable of devastating entire worlds if they come too close. The gravitational pull of a black hole is so strong that it would rip Earth apart in the blink of an eye. But what if one could form right here on Earth? Could we inadvertently create a black hole ourselves? Particle accelerators are already capable of smashing atoms together at nearly the speed of light in an effort to uncover the mysteries of the universe. But there's a disturbing possibility that these experiments could create microscopic black holes. While these black holes would be tiny, far smaller than an atom, they could still grow and expand, eventually consuming everything around them. To understand how this would happen, imagine Niagara Falls. The water cascades over the edge, and once it does, there's no going back. A black hole pulls everything into it with an irresistible force, much like a waterfall pulling water over the edge. Dr. Phil Plait, an astronomer and author, compares this to a kayaker approaching a massive waterfall. No matter how hard the kayaker paddles, once they cross a certain point, there's no escape. The same concept applies to a black hole. Once an object crosses its event horizon, it is doomed to be pulled in, unable to escape. Physicist Lawrence Krauss explains gravity with a simple analogy. If you hit a golf ball, it goes up and then falls back down. But if you hit the ball hard enough, about 11 kilometers per second, it could escape Earth's gravity and fly off into space. However, to escape a black hole's gravity, an object would need to travel faster than the speed of light. Since nothing can exceed the speed of light, nothing can escape a black hole's grasp. For now, black holes are safely far away in deep space. None are close enough to pose a threat to Earth. But as scientists continue to develop more powerful particle accelerators, some fear the possibility of an accident, creating a black hole on Earth that could slowly grow and devour everything in its path. Thankfully, these micro black holes would evaporate almost immediately, leaving no lasting threat. However, in rare cases, these accelerators might produce black holes large enough to cause real damage. Black holes vary in size, with some being enormous, like the one at the center of our galaxy, Sagittarius A Sti, which is 4 million times the mass of the Sun. In contrast, a black hole formed from a mountain's worth of material could be no larger than a marble, but even a black hole that small could still cause destruction. With a mass equal to that of Earth, about 6 sextillion tons, it would pull everything in, slowly consuming our planet until nothing remained but the black hole itself. If a black hole large enough passed near Earth, its immense gravitational force would begin stretching our planet in a process called spaghettification. Everything on Earth, from the oceans to the atmosphere, would be pulled apart. If it passed through the planet, it would vaporize everything in its path, creating a massive hole where Earth once stood. However, the likelihood of a black hole coming close enough to Earth to destroy it remains incredibly low. Black holes are exceedingly rare, and the chances of one entering our solar system are almost non-existent. But if black holes aren't the answer, what about another method of planetary destruction? Imagine the Earth veering off course, either closer to the Sun or further away. If Earth moved closer to the Sun, the temperature would rise to unbearable levels, making the planet too hot to sustain life. If it moved farther away, the Earth would freeze, plunging it into a new ice age. While this sounds like science fiction, scientists are starting to realize that such a thing might not be as impossible as it seems. In fact, we already use gravitational assists to maneuver space probes through the solar system, a principle that could one day be applied to move Earth itself. The Sun, which powers life on Earth, is not eternal. In about 2 billion years, the Sun will begin to expand, becoming hotter and brighter. This will render Earth uninhabitable, eventually turning the planet into a scorched wasteland. The Earth's oceans will boil away, and temperatures will soar to over 1,000 degrees Celsius. While this is an inevitability that we have no control over, some scientists have theorized that with enough energy, we could move the planet out of the Sun's path and avoid this fiery fate. The challenge is moving Earth, a planet weighing 6 trillion tons, but it's not as outlandish as it sounds. Using gravity assists, we could theoretically nudge Earth into a new orbit closer to or farther from the Sun. To accomplish this, we would need to send a series of asteroids on specific trajectories, using their gravity to gradually alter Earth's course. Over thousands of years, this slow, deliberate process could cause Earth to either spiral toward the Sun, making it an uninhabitable desert, or drift far enough away to become a frozen ice ball. This chain of events would trigger a catastrophic series of changes, one after another, as Earth inches toward its ultimate doom. The very act of moving Earth would be one of the most monumental feats in human history, and if successful, it would seal our planet's fate, one way or another. Would humanity be able to control its destiny, or would Earth succumb to the forces of nature and physics beyond our control? The future is uncertain, but the fact that we now have the ability to contemplate such possibilities marks a pivotal moment in our understanding of both our planet and the cosmos. As Earth edges ever closer to the Sun, the planet undergoes a series of transformations that spell its impending doom. With each passing moment, the atmosphere grows increasingly unstable, heated by the Sun's proximity, until it can no longer sustain itself. It is gradually blown away, dissipating into the vacuum of space. The oceans, too, begin to boil, their waters vaporizing into the air while Earth's surface becomes a chaotic, fiery landscape. The planet, once a vibrant blue orb teeming with life, now begins to resemble a massive comet, blazing a trail through the solar system. But this is merely the beginning of Earth's tragic tale. As Earth draws nearer, the sun's gravitational pull becomes stronger, and its effects are most noticeable on the side of the planet directly facing the star. On this side, the gravitational force exerts a relentless pull, tugging and stretching the planet like clay under the weight of a craftsman's hands. Meanwhile, the far side of the planet experiences far less gravitational force, creating a stark contrast. The result is a slow but sure deformation of Earth, its shape distorting as the sun's pull intensifies. Eventually, the gravitational forces from the sun become so powerful that they overcome Earth's own gravity. In a catastrophic event, the planet is torn apart, ripped asunder by the immense tidal forces. What was once solid and whole is shattered, disintegrating into countless fragments, reduced to dust. The Earth is no more, its remains scattered into the vast expanse of space, forever lost in the sun's embrace. Yet, even in its destruction, Earth leaves behind a faint, ghostly trace, a ring of debris encircling the sun, much like the majestic rings of Saturn. This haunting remnant of the planet's existence could persist long after its annihilation, a silent witness to the fiery end. Peter Schultz, a planetary impact geologist, offers insight into this phenomenon. He explains that when an object like Earth ventures too close to the sun, the immense gravitational forces at play will eventually tear it apart. This violent process would break the planet into a multitude of pieces, rocks, dust, and gas, forming a new, temporary structure around the sun, a ring of debris. This is not just a theoretical possibility, but a stark reality that could happen if Earth were to be dragged into the sun's gravitational grip. This realization is unsettling. To obliterate an entire planet, all one would need to do is guide it toward the sun. The process could be achieved by sending a series of asteroids on a carefully calibrated trajectory, pulling the Earth closer to its fiery demise. While humanity currently lacks the technology to move asteroids with the precision required to enact such a plan, the basic principles of asteroid manipulation are well understood. In theory, it could be possible to move asteroids into specific orbits that would gradually nudge Earth toward the sun. The technological challenges involved are immense, of course, demanding an unimaginable level of control over massive objects traveling at high speeds. But the idea is not entirely out of reach. After all, humanity has already explored the possibility of manipulating asteroids for various purposes, including planetary defense. Yet, if this method were deemed insufficient, there is a far more powerful option that exists in the realm of science fiction, but is grounded in real scientific theory: antimatter. This exotic substance, first theorized in the 1920s and detected in the 1930s, holds the potential for the most catastrophic explosion conceivable. In fact, antimatter is the most volatile substance known to humanity. When compared to ordinary matter, antimatter is far more energetic. Just a single pound of antimatter could unleash an explosion far more powerful than the most destructive nuclear weapons, including the hydrogen bomb. However, antimatter is not easily found. The matter we encounter in the universe, from the stars to distant galaxies, was created during the Big Bang, approximately 13 billion years ago. Alongside matter, antimatter was also produced, but it did not persist. The two, matter and antimatter, are perfect opposites. When they collide, they annihilate each other in a burst of energy so immense that it effectively cancels both out. This process is not just theoretical. It has been demonstrated in particle colliders, where particles of matter and antimatter are produced in minute quantities and then annihilate one another. The challenge of harnessing antimatter for use in a weapon is formidable. The process of creating antimatter is both complex and energy intensive. It's akin to firing a bullet at a target, where the bullet represents the energy required to produce the antimatter, and the target is a particle accelerator like CERN's Large Hadron Collider in Switzerland. In these accelerators, protons are propelled through a vast tube, guided by powerful magnets to speeds approaching that of light. Upon crashing into a metal block, a tiny fraction of these collisions results in the creation of antimatter. But for every million protons fired, only one antiproton is produced, making antimatter as rare and elusive as trying to catch a single drop of water from the mist of Niagara Falls. Creating antimatter in large quantities is incredibly difficult. However, let's imagine that we somehow manage to accumulate enough antimatter. The next hurdle would be containing it. Antimatter is notoriously unstable and will explode if it comes into contact with any regular matter. To store antimatter safely, it must be contained in a vacuum so pure that even the tiniest trace of air would cause an instantaneous explosion. The energy needed to create the required magnetic fields to contain antimatter is enormous, and the machinery necessary to sustain such a high-energy environment would be massive, far too large for practical, portable use. Despite these challenges, scientists have already demonstrated the ability to create, capture, and store small amounts of antimatter. But using it to destroy a planet presents an even greater problem. To cause maximum destruction, the antimatter bomb would need to be detonated deep within Earth, around 4,000 miles below the surface, much deeper than any human-made drill has ever gone. The deepest hole ever drilled is a mere 7.5 miles, a far cry from the depth required to reach the Earth's core. At present, humanity has produced just 20 nanograms of antimatter, which is so minuscule it would be invisible even from a distance. This tiny amount of antimatter, though potent, is far too small to cause the kind of destruction necessary to obliterate an entire planet. To create the devastation necessary, we would need 2.5 trillion tons of antimatter, the equivalent of Mount Everest in terms of mass. Even if we somehow manage to produce this amount, there is still the issue of delivery. Digging a hole to the core of the Earth, let alone placing a bomb there, would require technology and energy resources far beyond our current capabilities. To generate the antimatter required for such a task would demand the energy equivalent to the total output of the sun over an entire week. At our current rate of production, it would take longer than the entire age of the universe to produce enough antimatter for such a bomb. So, while antimatter presents an intriguing theoretical possibility for planetary destruction, the technical challenges make it a highly impractical solution. Fortunately, humanity is far from capable of carrying out such a cataclysmic event. However, history offers another, more familiar method of planetary destruction, one that has already occurred in the distant past. Space is a perilous realm, filled with objects that range from tiny pebbles to massive asteroids. These celestial bodies frequently collide, sometimes with catastrophic consequences. One such collision, billions of years ago, was responsible for the extinction of the dinosaurs. The impact of a single asteroid changed the course of history, and if a larger object were to strike Earth, it could potentially bring about the end of the planet itself. There is, in fact, a massive crater in Arizona known as the Meteor Crater, which serves as a testament to the destructive power of asteroids. Almost a mile wide and nearly 600 feet deep, it stands as a reminder of the cosmic dangers that constantly threaten our planet. The Earth's fragile existence is continually under siege from the heavens, and though we may not have the ability to destroy the planet through technological means, nature has already provided us with a glimpse of what such an event might look like. The Earth, once again, may face a catastrophic event from space, a reminder of its vulnerability in the vast, unpredictable universe. Scientists today have made remarkable strides in reconstructing the catastrophic events that took place on Earth thousands, even millions of years ago. Through painstaking analysis, they can trace back to some of the most profound impacts in our planet's history, events that shaped the very surface we walk on and the ecosystems that once thrived. Dr. Dandura, a planetary scientist, stands at the forefront of this research, offering insights into one such event that occurred roughly 50,000 years ago. In his description, imagine yourself in that very spot, witnessing a moment of unimaginable destruction. If you had been there, you would have observed the collision of an iron meteorite, roughly the size of a small office building, as it barreled through the atmosphere. Composed of a material similar to stainless steel, this extraterrestrial object came from the far reaches of space, carrying with it an unfathomable amount of energy. When it struck Earth, the energy released was equivalent to between 1 and 10 megatons of TNT. The devastation this event caused was nothing short of monumental. A massive crater, nearly a mile across, was formed, and the surrounding landscape, spanning an area as large as New York City, was utterly obliterated. The force of this impact was 600 times greater than the Hiroshima bomb, a detonation that, even by today's standards, remains a powerful symbol of destruction. And yet, that event was considered relatively small in the broader context of Earth's history. Looking back in time, 65 million years ago, a far more catastrophic asteroid struck our planet. This asteroid, about 6 miles in diameter, would have been a colossal sight, towering over Mount Everest by roughly half a mile. The collision created a crater more than 100 miles wide, a calamitous event that led to the mass extinction of nearly all life on Earth, including the dinosaurs. But as humanity looks toward the future, a chilling question looms large. What if something even larger were to collide with Earth? Could an asteroid large enough to completely obliterate our planet be on a collision course with us? The possibility, though remote, isn't entirely outside the realm of scientific consideration. Fortunately, scientists have already begun developing technologies aimed at protecting our planet from the threat of future asteroid impacts. Ironically, these same technologies, if they were to fall into the wrong hands, could be repurposed for far darker purposes. One such method involves sending a space probe to hover near an asteroid. The probe's mass generates a small but steady gravitational pull, which gradually alters the asteroid's trajectory. Over time, this subtle shift could be enough to steer the asteroid away from Earth. However, this technique, while seemingly a lifesaver, also carries a significant risk. In theory, the same gravitational manipulation could be used to direct an asteroid straight toward Earth, turning what would be a protective measure into a weapon of mass destruction. Another approach, known as solar sublimation, relies on the power of sunlight to shift an asteroid's course. Dr. Dura demonstrates this technique through a fascinating experiment in his lab, building a homemade comet using a variety of everyday materials: soil, dry ice, water, chocolate, and organic compounds. These substances mimic the composition of a real comet, which in the outermost regions of our solar system is largely made up of ammonia and other volatile compounds. By focusing sunlight through a magnifying lens onto the surface of this makeshift comet, the dry ice sublimates, turning from a solid directly into a gas, creating jets of gas that act like tiny rocket engines. These small bursts of energy slowly but steadily alter the comet's trajectory. It's a stunning realization. Sunlight alone can potentially alter the course of a massive space rock. However, this method has its limitations. For an asteroid large enough to cause global destruction, the power of sunlight might not be enough to prevent disaster. We would need something much more substantial, a force capable of altering the course of even the largest of objects. And such objects have collided with Earth in the past. Approximately 4.5 billion years ago, a rock the size of Mars collided with Earth in a glancing blow. The debris ejected from this impact eventually coalesced to form the Moon. If that asteroid had struck head-on, however, Earth as we know it, and perhaps all life, would have been forever changed. To better understand the potential for such catastrophic impacts, scientists have turned to a remarkable piece of technology at NASA's Vertical Gun Range in California. This enormous gun, weighing 12 tons, can fire projectiles at speeds of up to 4,000 meters per second, 6 times faster than the velocity of a bullet from a rifle. Professor Peter Schultz, a planetary impact expert, uses this device to simulate the impact of a Mars-sized object colliding head-on with Earth. The setup is dramatic. As the environment inside the space simulation chamber readies itself, Schultz fine-tunes the system. The moment of truth arrives, and the projectile, representing a Mars-sized object, collides with a scaled-down model of Earth. The impact is devastating. The model shatters completely, confirming the overwhelming destructive power of such a collision. The sheer force is so extreme that it's as something straight out of a science fiction movie has come to life. What does it take to truly destroy a planet? It's a combination of 3 critical factors: the size of the object, its speed, and the angle at which it strikes. The lower the angle of impact, the less likely it is that the object will completely pulverize Earth. To ensure total destruction, an object as massive as a planet would need to collide head-on with Earth at a velocity that could shatter the planet to pieces. Fortunately, such events are extraordinarily rare. Asteroids and comets, though capable of causing tremendous damage, are simply too small to bring about the end of the world. The real challenge, however, is the possibility of a collision with an object on a much grander scale. While Mars, for instance, might be able to inflict significant damage, it wouldn't be enough to destroy Earth. Venus, on the other hand, is nearly the same size as Earth and could potentially cause devastation on a planetary scale. However, even in the case of Venus, we currently lack the technological capability to redirect such a massive body with the precision required to strike Earth. While the threat of a catastrophic asteroid collision might seem remote, the idea of a planetary-scale disaster may not be as far-fetched as it once seemed. Yet, in the grand scheme of things, the true threat may not even come from space. A far more immediate danger could come from right here on Earth, where human innovation is pushing the boundaries of genetics, robotics, and nanotechnology. Researchers are delving into new realms where machines could play a pivotal role in both improving and potentially destroying the world. Already, robots are being designed to learn, adapt, and even build other robots, ushering in what could be a new era in technology. However, with great power comes great responsibility. While humans are still the masters of these machines, scientists are working toward developing robots that can think for themselves, even replicating without any human input. The idea of self-replicating robots is a tantalizing prospect, one that could revolutionize manufacturing, construction, and many other industries. Yet it also raises concerns. What happens if these robots begin to multiply uncontrollably? What if they become so efficient at self-replication that they outnumber us, potentially dominating the world? Professor Hod Lipson, a leading expert in robotics, is at the forefront of research into self-replicating machines. His team at Cornell's robotics lab is already developing machines that can build copies of themselves. These machines, though still in their infancy, represent a significant leap forward in robotic technology. As these robots become more advanced, they could eventually be made from minuscule building blocks, cubes just 0.5 millimeter in size. Such robots would replicate faster and more efficiently, potentially leading to an explosion in their numbers. If this self-replication process continues unchecked, it could quickly become impossible to stop, filling the space around them and transforming the landscape entirely. Lipson envisions a future in which these advances could drastically improve how we design and manufacture goods, but the risks are undeniable. The same technology that promises to enhance human life could just as easily become a tool for mass destruction. Thus, while the idea of a planet-ending asteroid seems improbable, the true dangers of the future may lie closer to home, in the very machines that we create. However, this rapid evolution in technology carries a shadowy and potentially catastrophic side. If nanotechnology advances sufficiently, the very tools created to revolutionize our world could spiral beyond our control, giving rise to self-replicating machines that, in an alarming twist, might threaten the existence of life as we know it on Earth. To understand the magnitude of this risk, one must first comprehend the scale of what is required to truly devastate the planet. For a robot to replicate itself, an act that could trigger a chain reaction of self-replicating machines, two key factors are essential: energy and raw materials. Essentially, the machine would need fuel or food to sustain its growth. The more resources it can access, the more machines it can create, thereby compounding the potential destruction. The most abundant source of food on Earth, the primary material that could fuel the replication process, is the planet itself. Imagine, for a moment, designing a machine that could tap into this vast reservoir using the energy and raw materials found in the very environment around it. Such a machine would not only be revolutionary, but could also reshape our understanding of what machines are capable of. This vision, inspired by the very principles of nature, could represent an unprecedented leap in technology, one that holds both promise and peril. At the core of this idea is the material most abundant on Earth: rock. Now imagine a robot capable of consuming rock, transforming it into usable raw material. This would grant it access to nearly limitless supplies of raw material, perhaps trillions of tons beneath its feet. This concept seems wildly futuristic, but the strange truth is that nature already features creatures that feed on rock. In the depths of the Earth's crust, bacteria thrive by consuming minerals found in the rock. These so-called rock-eating organisms contribute to life on the planet in unexpected ways. They play a role in soil formation and the overall cycle of life, converting rocks into biological molecules. Now, envision a world where robots do the same thing. Machines that not only consume rock, but also work together to build more of themselves, much like a colony of insects. These robots would need to be highly sophisticated, capable of working in unison to create a unified collective. One such project, led by Professor Alan Winfield, a noted roboticist, is aiming to design robots that can self-assemble into collaborative groups, swarming in a manner akin to insect colonies. The project, known as the Simon Project, is exploring the possibility of creating a network of 30 to 40 robots that function together as a single organism, working together to achieve common goals. The challenge here is not just in the technical design of the robots, but in fostering cooperation between them. How do you ensure that these robots can take on specialized roles, such as being a foot bot, a sensor bot, or even a brain bot, so they can function as one cohesive unit? This is a monumental task, and while we already have robots capable of reproducing and cooperating, the true leap forward comes when we combine these abilities. If we succeed, we could be on the verge of developing machines that not only replicate, but also consume the very planet itself. Consider the mathematics. If each robot is capable of replicating once per day, the results are mind-boggling. In just a month, there could be over 1 billion robots. After 1 year, the number could reach into the trillions. A single robot could potentially cover the entire Earth, endlessly replicating itself and consuming rock as it goes. Eventually, the machines would devour all available raw material, leaving nothing but a planet covered entirely by self-replicating robots, each one continuing the cycle. But these robots would need more than just rock to sustain themselves. They require other materials: iron, magnesium, aluminum, silicon, the very elements that make up the Earth's crust. So, if one of these self-replicating robots were to be set loose in the wild, it could start devouring everything in its path, replicating endlessly and consuming the Earth until nothing remains but a landscape of machines. While this might sound like a dystopian nightmare, we must keep in mind that Earth has withstood much worse. Throughout its 4.5 billion year history, the planet has endured cataclysmic events, massive asteroid impacts, drastic climate shifts, and other natural disasters. Despite all this, Earth has proven remarkably resilient. No matter what has been thrown at it, the planet endures. And while the self-replicating machines might wreak havoc, there is one certainty: Earth will remain. Now shift your focus from the realm of machines to one of the planet's most delicate and crucial features: the cryosphere. This frozen section of Earth, which includes ice sheets, glaciers, permafrost, and the frozen waters at both the North and South Poles, plays a pivotal role in regulating the planet's climate. By reflecting sunlight, the cryosphere helps maintain the balance of temperatures across the Earth's oceans and atmosphere. Without this frozen shield, Earth's climate would become far more unstable. However, this vital component of Earth's systems is under grave threat. Climate change is causing these ice masses to melt at an alarming rate, setting off a dangerous feedback loop. As the planet heats up, ice melts, leading to rising sea levels. These rising waters threaten coastal cities and vulnerable communities across the globe. Shockingly, nearly 99% of the Earth's fresh water is locked away in ice sheets, which form over land. As these ice sheets melt, they add enormous quantities of water to the oceans, further exacerbating the problem. The situation is dire, and scientists are working tirelessly to track and understand these changes. In 2017, NASA's Operation Icebridge conducted 7 major missions to study the planet's frozen regions. As NASA's longest-running airborne mission, dedicated to monitoring polar ice, Icebridge provides crucial data on the shifting ice sheets, glaciers, and sea ice. This mission acts as a bridge between satellite missions, ensuring scientists have continuous and up-to-date records of the planet's changing cryosphere. One of the leading figures in this field is Dr. Peter Sers, a world-renowned climate scientist and former astronaut. Having observed Earth from space during 3 shuttle missions and 6 spacewalks, he understands the urgency of the climate crisis better than most. He emphasizes that the Arctic region is warming at a rate 5 times faster than the global average, making it the epicenter of climate change. The ice there is melting rapidly, both on the ocean surface and across Greenland's vast ice sheet, which is crumbling into the Atlantic Ocean. To monitor these alarming changes, scientists use a combination of aircraft, satellites, and ground-based teams to collect data. This data is then analyzed to give a clearer picture of the damage being done. Since its inception in 2009, Operation Icebridge has been instrumental in tracking ice loss and providing vital information for climate modeling. The mission also collaborates with the European Space Agency to share data, ensuring a global approach to this pressing issue. But what is driving this rapid loss of ice? The answer lies in the increased concentration of greenhouse gases in the atmosphere. Gases like carbon dioxide, CO2, methane, nitrous oxide, and fluorinated gases trap heat, causing the planet to warm at an unprecedented rate. While CO2 has always been present in the atmosphere, human activities, especially since the Industrial Revolution, have dramatically increased its levels. The fluctuations of CO2 in the atmosphere have long been linked to shifts in Earth's climate, rising and falling in tandem with temperature changes. Yet today, the amount of CO2 continues to rise, accelerating the melting of ice and further destabilizing the climate. The state of the Earth's climate is rapidly deteriorating, and Colorado, a region already facing the strain of climate shifts, exemplifies the severe impacts of human-induced environmental changes. Fossil fuel consumption, deforestation, and industrial emissions are accelerating the rise in global temperatures, driving the planet into a crisis that is altering the natural world in profound ways. The burning of fossil fuels releases vast amounts of carbon dioxide, CO2, into the atmosphere, a greenhouse gas that traps heat, leading to an overall warming effect. This process, coupled with the destruction of forests that would otherwise absorb carbon, is pushing the Earth's climate into a new and dangerous territory. One of the most alarming trends is the rapid acceleration of ice loss across the globe. As global temperatures climb, ice caps and glaciers are melting at an unprecedented rate. This contributes to the rising sea levels, creating a feedback loop where the loss of ice exposes more of the Earth's surface to sunlight, absorbing more heat and further exacerbating the problem. The scientific community is struggling to comprehend the full scope of these changes. They now face an essential question: how exactly does climate change work in today's world? Historically, the Earth's temperature changes were closely linked to shifts in CO2 levels. During periods of warming or cooling, changes in carbon dioxide concentrations followed suit. However, this relationship reversed after the Industrial Revolution. In the pre-industrial era, temperature fluctuations were often caused by natural events, such as volcanic eruptions or changes in solar radiation, which could lead to shifts in CO2 levels. Since the advent of industrialization, the situation has reversed. It is now the increase in carbon dioxide that is driving the rise in global temperatures. This fundamental shift in how climate dynamics operate suggests that entirely new physical and biological processes are at work, and scientists are unsure what the long-term effects might be. These uncertainties are further complicated by the lack of natural forces capable of halting or slowing down the rapid rise in temperatures. CO2 continues to accumulate in the atmosphere unchecked, making the planet's future increasingly uncertain. The changes we're witnessing today are unprecedented, and the scientific community is grappling with what might come next. In recent years, the urgency of addressing climate change has only grown. October of this year was the hottest on record, with the year overall ranking among the hottest in modern history. To understand the broader implications of these temperature increases, scientists turn to long-term climate data, which helps to track patterns and predict future changes. This is where a new generation of Earth-observing satellites comes into play. The European Space Agency, ESA, and NASA have deployed an impressive array of satellites to monitor the climate. These include advanced missions like the Aeolus, METOP-C, Sentinel satellites, ICESat-2, and the GRACE follow-on missions. One of the key instruments these satellites carry is the radar altimeter, which measures the Earth's altitude with remarkable precision. The altimeter is crucial for tracking changes in sea levels, monitoring the thickness of ice caps, and even measuring the depth of lakes and rivers. The ability to track these changes with such precision has been groundbreaking. Take, for example, the METOP-C satellite, which carries 13 different instruments designed to monitor various environmental factors. Many of these instruments are shared with NOAA, the U.S. National Oceanic and Atmospheric Administration, as part of a long-term cooperative agreement between Europe and the United States. This collaboration ensures that both European and U.S. scientists can access the same high-quality data, fostering more accurate global climate assessments. Thanks to these advanced satellite technologies, scientists have been able to track the rise in sea levels with millimeter accuracy for the past 25 years. At first, there was skepticism about whether such fine-grained measurements were even possible. However, as technology has advanced, so too has the accuracy of these readings. Researchers now have confidence that global sea levels have been rising by about 3 millimeters per year, and more worryingly, the rate of rise is accelerating. At first glance, 3 millimeters per year might seem insignificant, but over the long term, even small increases in sea level can have catastrophic effects, particularly for coastal communities. As sea levels continue to climb, the risk of flooding, land loss, and extreme weather events will grow exponentially. To cross-check their findings, scientists rely on multiple observation systems. For example, the GRACE mission weighs the ocean every month by measuring shifts in the Earth's gravitational field. A fleet of 3,000 to 4,000 floating robots, known as Argo floats, measures ocean temperatures every few days, providing crucial data to confirm what the satellites report. When the data from radar altimeters, gravity measurements, and Argo floats are compared, the results align within just a few millimeters, offering solid proof that sea levels are indeed rising at an alarming rate. In addition to this, ESA has launched the Aeolus satellite, which is specifically designed to measure wind patterns from space. Wind plays a crucial role in weather systems, and by understanding wind flows more accurately, scientists can refine their climate models and improve predictions of future changes. The Aeolus mission, which employs advanced laser technology, was initially a short-term experiment to test the Doppler wind lidar system in space. If the results show that the system significantly improves weather predictions, scientists hope to launch a full-scale operational mission. One of the goals for the future is to deploy multiple satellites working together to provide continuous and highly accurate wind data. However, wind speed and direction are not the only important factors in weather forecasting. Temperature, air pressure, and humidity are also critical variables. Still, understanding wind patterns remains a central piece of the puzzle when it comes to forecasting how weather will evolve. Meanwhile, the Sentinel-3 satellites, which were launched in 2016 and 2018, focus on the study of Earth's oceans. These satellites measure vital data such as sea surface temperature, color, height, and the thickness of sea ice. This information is key to monitoring the rise in sea levels, tracking marine pollution, and understanding biological activity in the oceans. The data gathered by Sentinel-3A has already provided valuable insights, proving that this mission is playing a crucial role in advancing climate research. What sets the Sentinel-3 mission apart is its versatility. While it primarily serves marine research, it also contributes to land, atmospheric, and climate studies. One of its most significant contributions is analyzing ocean color data, which allows scientists to monitor marine ecosystems and detect harmful algal blooms. These blooms can pose serious threats to marine life, disrupting ecosystems and food chains. Additionally, Sentinel-3 tracks snow cover, providing crucial information on how melting snow influences flood risks and water supply. This data is essential for hydrology, climate science, and even weather forecasting. Looking ahead, the Sentinel mission is set to continue its work until at least 2040. New models of the satellite, Sentinel-3C and Sentinel-3D, are already in production and are expected to launch between 2023 and 2024, ensuring that data collection will remain uninterrupted for the foreseeable future. In addition, the JASON-CS mission, also known as SENT-6, is set to extend global sea level measurements for another decade. These long-term satellite programs are vital for providing accurate models of global warming trends and help scientists better predict the future. As the planet continues to warm, the impacts of rising temperatures on ice caps are becoming increasingly apparent. Greenland and Antarctica are both losing ice at an accelerated pace, and many glaciers are also melting. This ongoing loss of ice is contributing directly to rising sea levels, further exacerbating the climate crisis. The question that remains is not just how much more ice will melt, but what will the long-term consequences of these changes be, and how will they shape the future of life on Earth? The answers to these questions are crucial for understanding the trajectory of global climate change and for informing strategies to mitigate its most devastating effects. With each passing year, the urgency to understand and address climate change grows more pressing. Advanced technology, particularly satellites and observational systems, plays an indispensable role in giving scientists the data they need to monitor the planet's health. But the clock is ticking, and if the momentum of these changes isn't slowed, we may soon find ourselves facing a world where the worst impacts of climate change are irreversible. As the Earth's temperature steadily climbs, the consequences ripple through the planet's oceans in profound ways. One of the most noticeable effects of global warming is the expansion of water in the seas, with warmer temperatures causing the ocean to swell and rise, adding more volume to the seas that cover our planet. This gradual but undeniable change presents a growing challenge for scientists trying to track and understand these shifts in our environment. To tackle this, researchers are continuously refining their methods of collecting data, particularly from satellites, to gain a clearer and more accurate picture of these changes. One of the more innovative and unexpected approaches comes from Dr. Bob Bruin of the Plymouth Marine Laboratory. His groundbreaking technique may sound unconventional, but it has proven to be highly effective. Rather than relying solely on traditional methods, Dr. Bruin uses something that might surprise many: a surfboard. By attaching a specialized device known as a smart fin to his surfboard, Dr. Bruin can gather crucial data on sea surface temperatures and track the movements of coastal waters. With just a smartphone, he is able to collect vital information that will help him and his team better understand how our oceans are changing. The data he gathers from his surfboard is then combined with information collected from the Sentinel-3 satellites. These satellites are part of the European Copernicus program, which is designed to monitor and collect extensive data about our planet's oceans, atmosphere, and land. The Sentinel-3 satellites are equipped with 3 advanced instruments that measure a wide range of oceanic factors. These include ocean color, water quality, sea levels, and, perhaps most importantly, sea surface temperature. For Dr. Bruin, sea surface temperature is central to his research, as understanding temperature patterns is critical to comprehending the broader changes occurring in the ocean environment. Dr. Bruin's expertise in thermal radiometry, the study of temperature in the ocean, is based on over 40 years of experience, and it provides invaluable insight into how temperature shifts impact marine life and ocean dynamics. Advances in satellite technology have significantly enhanced scientists' ability to monitor these temperature fluctuations, especially in coastal regions. Temperature plays a crucial role in many aspects of the ocean's environment, from influencing the growth and reproduction of marine life to altering the physical properties of water, such as its density, which in turn affects currents. Temperature is also a key factor in marine chemistry, as many chemical reactions in the ocean are temperature dependent. Moreover, the transfer of gases between the atmosphere and the sea is heavily influenced by the temperature of the water. By studying these shifts in temperature, scientists like Dr. Bruin can gain a deeper understanding of how the oceans are evolving and how these changes might impact the global climate. The data collected from these studies is crucial because it helps to validate and support satellite measurements, such as those from the Sentinel program. Measuring the temperature of coastal waters from space is no easy feat, but researchers have found creative ways to gather more direct on-the-ground data in these critical regions. One such innovative solution is the smart fin, a device that allows surfers as well as other water sports enthusiasts to contribute valuable data while engaging in their favorite activities. This collaborative approach is part of a growing trend to leverage everyday actions for scientific discovery. But it is not just individual efforts that are pushing the boundaries of our understanding. At the same time, major space agencies are expanding their efforts to monitor the Earth's rapidly changing climate. In particular, NASA has launched 2 new satellite missions aimed at studying the regions of the Earth that are undergoing the most significant transformations, particularly the poles. Working in partnership with the German Research Center for Geosciences, GFZ, NASA has introduced the GRACE-FO mission, which builds upon the success of its predecessor, GRACE. Additionally, NASA's ISAT-2 mission, which is equipped with an advanced laser altimeter system, is providing groundbreaking capabilities for studying ice sheets, glaciers, sea ice, permafrost, and snow cover, collectively referred to as the cryosphere. The cryosphere is integral to maintaining stable conditions for life on Earth. As the ice sheets melt, they contribute to rising sea levels, which in turn can have far-reaching effects on communities across the globe. ISAT-2 is designed to measure the height of ice sheets with an unprecedented level of accuracy. By taking repeated measurements over time, scientists can track how ice sheets are changing. ISAT-2 also measures the height of sea ice, providing crucial information about its thickness, which is vital for understanding how changes in the cryosphere are influencing the global climate. Built and designed at NASA's Goddard Space Flight Center, ISAT-2 takes full advantage of the latest advancements in satellite technology. The satellite's 6 beams provide scientists with far more detailed data than previous missions, making it an exceptional tool for studying ice sheets and sea ice. Sea ice is particularly important because it plays a significant role in regulating the exchange of heat and water vapor between the ocean and the atmosphere. When sea ice thins or thickens, it impacts how much heat is exchanged, thus influencing climate patterns. Additionally, as ice sheets melt, their water flows back into the ocean, contributing to rising sea levels, which is a major driver of global environmental change. To ensure the instruments on ISAT-2 are as precise as possible, NASA scientists have traveled to Antarctica to calibrate the satellite's equipment. By taking altitude and radar depth measurements, they fine-tune the satellite's instruments to ensure the accuracy of its laser measurements. Special corner cube reflectors were even deployed in the field, each containing tiny pieces of glass designed to reflect the satellite's green laser light, helping to confirm the precision of the elevation readings. In one experiment, scientists used bamboo poles with small white caps containing glass pieces that reflect the laser light. This innovative calibration method ensures that the satellite's measurements of ice sheet elevation are accurate, allowing researchers to track the dynamic changes occurring at the poles. Ice sheets are constantly in motion, flowing under their own weight from the center of the continent toward the edges. In extremely cold regions, large amounts of snow accumulate, and if conditions remain cold enough, the snow compacts over time, contributing to the mass of the ice sheet. This process is known as firn densification and is crucial to understanding the health of the ice sheets. When scientists refer to the health of ice sheets, they are discussing the balance between the accumulation of new ice and the melting of existing ice. This mass balance is delicate and influenced by various factors, including atmospheric temperature, ocean currents, and winds. In Antarctica, katabatic winds, powerful gravity-driven winds, play a significant role in shaping the ice sheets and influencing the melting process. These winds move in a clockwise pattern around the continent, building speed as they travel across the unimpeded landscape. These winds, combined with the presence of large ocean currents, have a dramatic impact on the ice shelves along the coastline. One of the most important factors in ice sheet melting is basal melting, where warm ocean water infiltrates the cavities beneath ice shelves, melting the ice from below. The dynamics of these processes are complex and influenced by both regional and global currents, as well as the strength of the katabatic winds. By measuring changes in the height of the ice sheet's surface, scientists can track how much ice is melting and contributing to rising sea levels. This data is crucial for understanding the future of our planet's oceans and coastlines. In Greenland, the situation is particularly urgent. The ice sheet is thinning more rapidly along its coastlines than scientists had anticipated. This thinning is occurring upstream of where the ice is anchored to the bedrock, meaning that the melted ice flows directly into the ocean, further accelerating sea level rise. Since the launch of the ERS-1 satellite in 1992, scientists have been using radar measurements to track the changes in the ice sheets, and over the past 25 years, they have observed a steady increase in sea level. This rise, approximately 8 centimeters globally, has been a key indicator of the ongoing impacts of climate change and the melting of the polar ice sheets. As satellite technology continues to evolve and our understanding of the Earth's polar regions deepens, scientists are gaining more insight into how the ice sheets are responding to a changing climate. These developments are critical for preparing for the challenges of rising sea levels and understanding the broader environmental shifts that will shape life on Earth in the years to come. In the tropics, there are noticeable regional differences when it comes to the effects of climate change, particularly in sea level rise. Over the past 5 years, scientific data has shown a concerning acceleration in the rate at which sea levels are rising. Previously, the global average sea level rise was approximately 3 millimeters per year. However, recent observations suggest this rate has now nearly doubled, reaching 5 millimeters per year. This dramatic shift in data has been shared with climate scientists across the globe to help them refine their projections, with some models suggesting that by the year 2100, sea levels could rise by as much as 2 meters compared to current levels. While these figures paint a stark picture for coastal areas around the world, they also raise questions about the future of humanity's adaptation to the changing environment. Yet, the real-world implications of such a drastic rise are still not fully understood. Much like the data on Earth, the human experience of space, specifically aboard the International Space Station, ISS, also offers fascinating insights into the challenges of living in an entirely different environment, far removed from Earth. Astronauts and cosmonauts who train for missions aboard the ISS undergo years of rigorous preparation. Their journey to the space station begins long before they even step foot aboard the spacecraft. For months, they undergo intense physical and mental training, learning how to work and live in the most challenging conditions. They practice zero-gravity exercises, study complex scientific procedures, and prepare themselves for the technical and psychological demands of their missions. However, once these astronauts finally launch into space and begin their missions, their experiences often take an unexpected turn. Despite the thrill of their once-in-a-lifetime journey, most astronauts share a surprising thought upon returning to Earth. They can't wait to go back. Paolo Nespoli, an astronaut who has now completed 3 space missions, describes the psychological transformation that occurs when you leave Earth's gravity behind. It's like becoming an extraterrestrial, he reflects. You stop thinking like an Earthling. Gravity, up, down, all those things stop mattering. Your mind adapts to a completely new way of thinking, a way of living, where your movements, tasks, and even your sense of direction become totally different. Living in space is not the carefree experience many people might imagine. In fact, the process of adapting to life in zero gravity takes time, effort, and concentration. Nespoli explains that astronauts must learn to move smoothly without crashing into objects or drifting away from their tasks. They have to understand how to manage equipment properly, how to work with efficiency, and even how to sleep when there is no gravity to pull them into a restful position. It takes about a month or so to fully adapt, Nespoli continues. After that, you're completely at home in space. A typical mission aboard the ISS lasts about 6 months. During this time, astronauts spend the first few weeks adjusting to the space environment, which means they operate at a reduced capacity until their bodies fully adapt. Once they settle in, they are able to perform at their peak, managing a packed schedule that lasts from 7:30 a.m. to 8:30 p.m. every day. Half of this time is spent maintaining the space station, fixing equipment, moving cargo, and preparing for spacewalks. The other half is dedicated to conducting research, from studying life sciences to advancing technology and medicine. For Nespoli, the experience of working on the ISS was not just a job, it was a personal adventure. It felt like being a kid again, he recalls. There's this urge to experiment, to push boundaries. Sometimes you think that idea won't work, but then you try it and suddenly you've discovered a whole new way of thinking. That feeling of discovery is incredible. Despite the challenges, the astronauts' role is invaluable. Mission control centers, like those in Houston and Moscow, rely on astronauts to work at full capacity, ensuring that every minute spent in space contributes to the broader goals of the mission. Even astronauts with specialized training, like Nespoli, are expected to adapt to a wide range of tasks, from engineering to conducting experiments. For Nespoli, this variety kept him engaged. It's a bit like being back in school, he says. You get that rush of adrenaline, like taking an exam. You want to prove what you know, but at the same time, you have to be cautious. One mistake and things can go wrong quickly. Interestingly, despite his success, Nespoli isn't the only one reaching new milestones in space. Among the active astronauts in the European Space Agency, ESA, there are many seasoned veterans, each with their own unique contributions. At 60 years old, Nespoli is one of the agency's oldest astronauts, but age is no barrier to his performance. At 60, I'm expected to perform just like everyone else, he says. I feel truly honored to have the chance to return to space. It's been years of preparation to stay qualified, and now I get to use it once more. The significance of each mission becomes even clearer when considering the astronauts who are preparing for their next journeys. Alexander Gerst, who has spent 165 days in space, including 6 hours of spacewalk experience, can't wait to return. It's an amazing feeling to be back in training, he shares, standing in front of a full-scale replica of the ISS. This is the closest thing on Earth to being in space, and I've definitely missed it. His last mission ended in 2024, but after 3 years of preparation, he's ready to go again. This time, Gerst won't just be conducting research. He'll take on the critical role of ISS commander, a responsibility that requires strong leadership and the ability to ensure the safety of the crew and the station. For me, this role as commander is an incredible honor, Gerst says. It's humbling to know that I have been trusted to lead this team and ensure that everything runs smoothly. He goes on to explain that the leadership duties of a commander are far more demanding than the previous roles he's had. In my earlier missions, I only had to focus on my own training, but now I have an entire crew to support and guide. The responsibility of keeping everyone safe and maintaining the efficiency of the mission is a big challenge. One of the most important aspects of an astronaut's mission, especially those who have completed multiple assignments, is the knowledge and experience they bring back with them. Seasoned astronauts like Gerst, Nespoli, and others play a vital role in passing on their expertise to the next generation of space explorers. Their firsthand accounts of life in space, their insights into dealing with the physical and mental demands of long-term space missions, and their leadership skills are all crucial in training the new recruits who will follow in their footsteps. For the newest astronaut in the ESA, Maya Moga, training alongside these veterans has been both a privilege and a transformative experience. Moga, who is still in the early stages of his career, is learning directly from astronauts like Tim Peake and Luca Parmitano, who have extensive experience conducting spacewalks, or extravehicular activities, EVAs. Moga describes the training process as not just exciting, but eye-opening, with each lesson offering new insights into the realities of working in space. Training with these veterans is an incredible opportunity, Moga says. It's not just about learning the technical skills, but also about understanding the mindset required to thrive in space. The lessons and experiences shared by astronauts who have returned from space are invaluable. Their stories of adaptation, discovery, and leadership will continue to shape the future of space exploration, inspiring and preparing the next generation of astronauts for the challenges that lie ahead in the great unknown. Tim Peake, the renowned British astronaut, has always expressed how truly rewarding the process of astronaut training is. In fact, for him, it's something far beyond a job. It's an exhilarating journey, one filled with a sense of discovery and connection. It's actually a lot of fun, Tim explains. I get to connect what I'm doing on the ground with everything I experienced while I was in orbit. It gives me a deeper understanding of how everything fits together. The thrill of this process is compounded by the fact that the training is continually evolving. The instructors are not just teaching, but actively encouraging feedback from astronauts to refine and improve future training methods. It's a unique, symbiotic relationship where both instructors and trainees work hand in hand to enhance the preparation for future space explorers. For Tim, being back in Houston, the epicenter of astronaut training, stirs feelings of nostalgia, but it's also undeniably exciting. Soon, he will find himself once again at the Neutral Buoyancy Laboratory, NBL, the massive, state-of-the-art underwater facility that simulates the zero-gravity conditions of space. In this vast pool, astronauts practice the meticulous and challenging task of spacewalking. These simulated conditions provide astronauts like Tim a crucial taste of what it's like to work outside the International Space Station, ISS. Alongside his German colleague Matthias, Tim shares insights, hands-on techniques, and strategies to tackle the challenges of working in the vacuum of space. Looking back on his own 6-month mission aboard the ISS, Tim is filled with a profound sense of awe when he reflects on his spacewalks. If I had to pick just one highlight, it would definitely be stepping outside the station, Tim says, his voice carrying the weight of the memory. Looking down at Earth, seeing the vastness of space, it was a level of awe I can't even describe. Floating in my spacesuit, I turned around and looked back at the station from the outside. At that moment, everything changed. It gave me a whole new perspective on just how incredible this experience really is. Despite being one of the most remarkable aspects of space exploration, training for a spacewalk on Earth is a completely different experience. The NBL offers the best available method, yet the unique challenges of microgravity still cannot be perfectly mimicked. In the lab, astronauts are submerged in water to simulate the sensation of weightlessness. But when it comes to the real thing, the difficulties of moving in zero gravity are far more complex. Simple tasks on Earth, such as setting down a toolbox, become an intricate ballet of awareness and control in space. On Earth, a toolbox remains stationary, but in space, turn your head for just a second, and suddenly it's floating away along with any tools you placed inside it. It's an environment that demands constant vigilance. Maintaining awareness of where everything is, keeping track of objects that drift away, is just one of the many hurdles astronauts face in microgravity. Watching new trainees suit up for their training sessions in the giant pool, Tim can't help but reflect on the enormity of the effort and precision required. It really puts things into perspective, Tim says. The NBL is an incredible facility. It's the best place on Earth to prepare for working outside the space station. But no matter how much we train, nothing can truly compare to the real experience of stepping out into the vastness of space. Becoming an astronaut in Europe involves an exhaustive and precise process of training, especially when it comes to learning to operate in the unique environment of space. European astronauts who often work with American-built spacesuits must undergo extensive training to master the technicalities of these suits. It's not just about wearing the suit, it's about learning how to maneuver in it, how to efficiently complete tasks despite its bulk, and how to manage the physical strain the suit places on the body. Spacesuits are much more than protective garments. They're necessary for survival, but they also impose limitations on movement. Simple movements that take seconds on Earth, like bending down to pick something up, can take astronauts upwards of 30 minutes in space. The suits are bulky and restrictive, and even the most basic tasks become exhausting. After finishing a spacewalk, astronauts often feel a deep ache throughout their entire body. The suit's limitations become all too apparent, especially when it comes to arm movement, making even routine tasks incredibly challenging. However, despite these challenges, spacewalks remain one of the most awe-inspiring aspects of space travel. Astronauts describe stepping outside the station as a life-changing experience, one that alters their entire perspective on the universe. Instead of gazing at Earth through a window, they see it firsthand, with only the thin visor of their helmet separating them from the void. The view is nothing short of breathtaking, an uninterrupted panoramic image of the blue and white sphere floating serenely below them. Training for spacewalks involves a variety of simulated environments, including underwater exercises designed to replicate the weightlessness of space. Though these exercises are the best available method of preparation, they still fall short of mimicking the sensation of moving in a true zero-gravity environment. Astronauts appreciate the freedom to move their arms and legs naturally again once they return to the ISS, something they can only fully grasp after working within the restrictive confines of a spacesuit. Inside the ISS, life is equally demanding. The station is a busy hub with multiple spacecraft constantly arriving and departing. Coordination with Russian colleagues is vital, especially when it comes to transporting cargo through different sections of the station. This cooperation is further complicated by the ever-changing layout of the ISS, as modules are relocated, scientific experiments are conducted, and emergency protocols evolve. For astronauts, this means that no matter how experienced they are, retraining is always necessary. Even the most seasoned astronauts must stay up to date with new procedures and protocols to ensure mission success. Even with this ever-present sense of challenge, seasoned astronauts remain excited and eager to see what the future holds. One of the most thrilling prospects is the upcoming deployment of the Orion capsule, one of the most advanced pieces of technology designed for deep space exploration. This capsule represents the next great leap in space travel, and astronauts can't wait to be a part of it. The Orion capsule is not just a piece of machinery, it's a symbol of humanity's continued quest to explore beyond our planet. It's the vehicle that will carry astronauts to the moon and eventually to Mars, and Europe plays a pivotal role in this venture by providing the service module necessary for the first exploratory missions to the moon. While astronauts continue to work aboard the ISS, the station's operational life is gradually winding down. Plans are already underway to convert the ISS into a commercial space station, and attention is shifting toward deeper space exploration. The ISS, which orbits Earth at a relatively low altitude of about 400 kilometers, will soon be eclipsed by missions that aim to venture farther, like the Orion capsule, which is capable of traveling tens of millions of kilometers into deep space. The moon is about 400,000 kilometers away from Earth, 1,000 times further than the ISS. The possibilities for exploration are vast, and humanity's curiosity is leading us toward even greater frontiers. Mars, once a distant dream, is now the next destination. Astronauts know their experiences aboard the ISS contribute invaluable knowledge to the scientific community. One fascinating aspect of space exploration is how biological samples collected during missions continue to advance fields such as space medicine and nutrition. For instance, samples of urine taken during a 10-day mission to the ISS have given scientists crucial insights into the effects of space travel on the human body. This research is vital for the planning of future long-duration missions, as it sheds light on energy use and nutritional needs that are essential for astronaut survival. But it's not just about the science of space travel, it's also about the food. Although it might seem like a small consideration, food in space is far more complex than simply packing snacks. Astronauts must choose their food carefully, taking into account how it will be stored, prepared, and consumed in microgravity. One astronaut shared that initially they didn't think food would be a big deal, but after spending a month in space, it became clear that the wrong food choices could make the entire mission much more difficult. Eating in space presents its own unique challenges. Astronauts often experience changes in their taste buds due to the altered conditions of space, which can make certain foods taste different. Some astronauts even report cravings for foods they never liked before. For example, one astronaut confessed that before the mission, they couldn't stand broccoli or cauliflower, but in space, they found themselves really enjoying them. These vegetables are rich in protein, an essential nutrient for astronauts in space, which could explain why their taste preferences shifted. On the ISS, astronauts enjoy a mix of American, European, and Russian foods. Russian space food, known for its rich and flavorful seasonings, often includes more spices, salt, and fat, which can sometimes be overwhelming for astronauts. On the other hand, American and European meals tend to be healthier, though astronauts occasionally crave the bold, savory flavors of Russian food and indulge in those familiar comforts. Food is more than just sustenance. It's a part of maintaining morale and creating a sense of normalcy during long missions. Astronauts often come together to share meals, listen to music, and tell stories from their week. These moments of camaraderie are essential for building a sense of community, keeping spirits high, and providing astronauts with much-needed breaks from the demands of space exploration. But it's not just about food or science. Space missions are also about cooperation. The European Space Agency, ESA, has taken a significant step in fostering international collaboration by leading astronaut training activities in China. This cross-cultural cooperation is key to ensuring the future of space exploration. Astronauts from different nations, like Samantha Cristoforetti and Matthias Maurer, have been paired with Chinese Murtae. Samantha and Ruki, two astronauts from the European Space Agency, ESA, are accompanied on their journey by a flight surgeon and a training specialist. Both of these experts have been working closely with their Chinese counterparts, and together they've had the opportunity to witness firsthand how China's space program uniquely blends ancient Chinese medical traditions with cutting-edge modern medical practices. This collaboration, which might seem unconventional to some, speaks volumes about the profound mutual respect and the knowledge exchange between these two great nations. The fusion of traditional Chinese medicine with contemporary medical techniques is not just an innovation, but a testament to the evolving relationship between the ESA and China's space agency. It's an opportunity for both space agencies to learn from each other, drawing on their respective histories and resources to shape a future of space exploration that is richer and more diversified. The training exercises conducted in China are just one facet of a much broader and long-term collaboration. It's a partnership that began in 2015 with an agreement to strengthen the ties between the two organizations, laying the groundwork for deeper cooperation in years to come. One of the most exciting possibilities emerging from this partnership is the idea of European astronauts journeying to China's space station, a goal that could become a reality as early as the 2020s. This training is just the first of many steps toward that ambitious dream. With both agencies working hand in hand, they are paving the way for a future where astronauts are not only prepared for interstellar exploration, but also capable of crossing the threshold of national boundaries to achieve their shared goals. This isn't the first time ESA and China have teamed up. Back in July of 2016, Chinese astronaut Wai Guangfu participated in ESA's demanding caving course in Sardinia, a program designed to simulate the extreme conditions astronauts might face in space. This early collaboration laid the foundation for the current training exercises, demonstrating the growing bond between these two powerful space agencies. It also proved that space exploration is not just about technological breakthroughs, but about cultivating unity across borders. The joint training initiatives serve a dual purpose. They're not just about preparing astronauts for the rigors of spaceflight, but also about fostering cross-cultural exchange. The hope is that these astronauts will not only become better prepared for their missions, but also gain a deeper understanding of one another's cultures, philosophies, and approaches to space. It's about building lasting partnerships where the ultimate goal is to unite humanity in the shared pursuit of knowledge beyond Earth's atmosphere. Astronauts like Samantha Cristoforetti, who reflects on her past mission titled The Blue Dot, understand this perspective all too well. Space travel, she notes, offers a completely new lens through which to view our planet, a lens that makes Earth appear as a fragile, small speck in the vastness of the universe. For Samantha, the mission she's about to embark on, named Horizons, holds even greater significance. It symbolizes not just the quest for scientific advancement, but also the enduring spirit of exploration, the very same spirit that propelled the great explorers of the past to sail into the unknown. Just as those early explorers ventured into uncharted waters, the evolving cooperation between the ESA and China represents a new chapter in the story of human space exploration. The collaboration between these two agencies is not just about achieving technological feats, but about expanding our collective knowledge of the universe while fostering mutual respect and understanding. The partnership stands as a beacon of what humanity can achieve when we work together for the greater good, demonstrating that space exploration has the power to build bridges between nations. But space exploration isn't just about astronauts and training exercises. It's also about pushing the limits of what's possible in science and technology. One of the most daring missions set to redefine the boundaries of human knowledge is the Parker Solar Probe, a groundbreaking spacecraft poised to venture deeper into our solar system than any spacecraft before it. It will embark on an audacious journey to the very heart of the sun, something that once seemed purely the stuff of science fiction. This mission, years in the making, and represents a major milestone in our quest to understand the sun's mysteries and the origins of solar winds, phenomena that have baffled scientists for decades. What makes the Parker Solar Probe so extraordinary isn't just its mission, but the technology behind it. Weighing only 685 kilograms, the spacecraft was launched aboard a massive United Launch Alliance Delta IV Heavy rocket, whose thrust of nearly 9,700 kilotons seems almost excessive, but is absolutely necessary for the mission at hand. The probe must travel faster than anything humanity has ever built before in order to reach the sun. In fact, when it begins its journey, it will become the fastest human-made object in history, pushing the limits of speed in ways previously thought impossible. This audacious plan, however, did not come together overnight. The idea for the Parker Solar Probe was first conceived in 1958, and for decades it remained at the top of scientists' wish lists. Yet, the mission could not begin until technology had advanced enough to make such a daring feat possible. The scientists who first envisioned the mission had to wait decades for the necessary breakthroughs in materials science, propulsion, and heat protection before their dream could take shape. Now, after over 60 years of tireless work and innovation, the Parker Solar Probe is finally on the launch pad, ready to embark on a journey that has the potential to change everything we know about our closest star. The Parker Solar Probe isn't just a spacecraft. It's the culmination of decades of planning, innovation, and relentless teamwork. Hundreds of engineers, scientists, and visionaries have worked together to turn this dream into a reality. For those who've spent years on the project, watching the spacecraft launch is nothing short of a monumental achievement. As one engineer shared, after dedicating a decade to the mission, seeing it come together was an unforgettable experience. Being part of such a talented team, they said, is beyond amazing. But why, you might wonder, is this mission called the Parker Solar Probe? The spacecraft is named after Dr. Eugene Parker, the visionary scientist whose groundbreaking work on solar winds and the sun's outer atmosphere laid the foundation for this mission. Parker's theories, which were once met with skepticism, are now at the heart of the mission, and his ideas have profoundly shaped our understanding of the sun. It's a fitting tribute to the scientist whose work changed the course of solar research forever. The Parker Solar Probe's journey is not just about answering questions we've had for centuries about the sun. It's about rewriting our entire understanding of the solar system's central star. Equipped with cutting-edge technology and advanced sensors, the probe will gather invaluable data that could alter the way we think about space, science, and the sun itself. This mission isn't just a singular achievement. It's a new chapter in our quest to explore and understand the universe, and its legacy will be felt for generations to come. After more than 6 decades of anticipation, the Parker Solar Probe is finally ready to take humanity closer to the sun than ever before. This is more than just a mission. It's a testament to human perseverance, ingenuity, and the unyielding desire to explore the unknown. As it plunges into the sun's corona, it will bring us closer to understanding our star, and by extension, the very origins of life itself. In the realm of space exploration, few missions have captured the imagination of both scientists and the general public, like the Parker Solar Probe. This extraordinary mission, which began its journey in 2018, holds a truly unique distinction. It is the first space mission ever to be named after a living person. That person is Eugene Parker, an astrophysicist whose contributions to the field of solar physics have forever altered our understanding of the sun, its behavior, and its influence on our entire solar system. Parker, born in 1927 in Houghton, Michigan, has had a remarkable and at times challenging journey to prominence. His career, marked by groundbreaking ideas and occasional setbacks, was far from smooth. Like many visionary scientists, his early work was met with resistance and skepticism. Yet it was Parker's unwavering belief in the power of his ideas and the strength of his scientific method that eventually won out. After earning his PhD in physics from the California Institute of Technology, Caltech, in 1951, Parker embarked on a journey that would ultimately reshape the field of astrophysics. However, it wasn't until 1958, when Parker was still in the early stages of his career, that he proposed one of his most revolutionary theories, the concept of the solar wind. In contrast to the accepted view at the time, which held that the space surrounding the sun was a vacuum, Parker suggested that the sun constantly emitted a stream of charged particles, which we now know as the solar wind. This theory was not simply a creative hypothesis. It was a radical rethinking of how the sun interacted with the rest of the solar system. At the time, the idea was considered highly unconventional, and many in the scientific community dismissed it. Despite this, Parker persisted, confident in the validity of his theory. His predictions about the solar wind, its velocity, and its direction were groundbreaking. He also proposed that the sun's magnetic field extended far beyond its surface, forming a spiral shape that now bears his name, the Parker spiral. The skepticism that Parker faced from his peers was intense. Despite the brilliance of his ideas, his groundbreaking paper on the solar wind was initially met with fierce resistance. Reviewers criticized his work, suggesting that there were errors in his math and that his conclusions were flawed. Some even went so far as to claim that his theory was mistaken. But Parker's response was not to cower or retreat. Instead, he stood firm in his conviction, patiently walking his critics through his equations and demonstrating the soundness of his research. His persistence, coupled with the growing body of evidence supporting his claims, eventually led to the acceptance of his theory. By the 1970s, spacecraft such as the Pioneer and Voyager probes were confirming Parker's predictions about the solar wind. The solar wind, as Parker had theorized, was real, and it extended far beyond the orbit of Pluto. It wasn't just a scientific theory anymore, it was a fact, and it was reshaping our understanding of the sun's influence on the solar system. The validation of Parker's theories by spacecraft data was a pivotal moment in the history of space exploration. Parker's career, however, was not just about triumphing over doubt and skepticism. It was about a vision, one that continues to shape the field of space exploration. His research laid the foundation for many of the most important missions that followed, including the Parker Solar Probe itself. Acknowledging his decades of work and vision, NASA decided to name this groundbreaking mission in his honor, a gesture that deeply moved Parker. He had never imagined that his name would be carried into space on a mission to study the very force he had spent his life investigating. The Parker Solar Probe mission is a fitting tribute to the legacy of Eugene Parker, whose contributions to the field of solar physics have made an indelible mark on science. The Parker Solar Probe is not just an exploration mission. It is an engineering marvel that pushes the boundaries of what was once thought possible. The spacecraft was designed to get closer to the sun than any previous human-made object. Its mission is one of the most daring and ambitious in the history of space exploration. The challenge of sending a spacecraft to the sun is immense, not only because of the sun's intense heat and radiation, but also because of the incredibly high speeds required to reach the sun. The Parker Solar Probe's velocity is unmatched, reaching speeds that no spacecraft before it has ever achieved. To put it into perspective, imagine traveling from Chicago to Beijing in less than a minute. That is the kind of velocity the Parker Solar Probe will reach as it journeys closer to the sun than any other spacecraft in history. However, speed alone is not enough to ensure the spacecraft's survival. The sun's outermost layer, the corona, is so hot that the temperatures there can soar to around 2,500 degrees Fahrenheit. The spacecraft's instruments, which are designed to measure the solar corona, could not withstand such extreme heat without significant protection. To meet this challenge, the team behind the Parker Solar Probe developed one of the most advanced heat shields ever created. This heat shield, made of carbon-carbon composite materials, is capable of withstanding the intense heat while ensuring that the rest of the spacecraft remains at a temperature that allows its delicate instruments to function. The heat shield is coated with a special white material designed to reflect the sun's light, a simple yet brilliant solution inspired by the way lighter colors reflect sunlight and keep things cool. In addition to the heat shield, the spacecraft features several other cutting-edge technologies designed to ensure its success. For instance, the spacecraft's lightweight titanium truss, weighing only about 50 pounds but standing 4 feet tall, helps to minimize heat conduction between the heat shield and the rest of the spacecraft. This careful design ensures that the probe's sensitive instruments remain protected as it flies ever closer to the sun. One of the most interesting aspects of the Parker Solar Probe's power generation system is its use of solar panels. Initially, the team had considered using a nuclear power source for the spacecraft, but this option was ultimately abandoned in favor of solar panels. While this choice introduced its own challenges, including the need to design panels that could survive extreme temperatures, it ultimately proved to be a more practical solution for long-term space exploration. Solar panels are a familiar feature on many spacecraft, but what makes the Parker Solar Probe's solar panels so unique is that they are exposed to sunlight far more intense than anything experienced by previous spacecraft. As the probe approaches the sun, it must rely on these panels to generate the power it needs to operate. This is no small feat, as the spacecraft is subject to temperatures that would destroy ordinary solar panels. The team had to develop a specialized system to ensure that the panels could continue to function at peak efficiency, even under the most extreme conditions. Looking back at Eugene Parker's legacy, it is clear that his ideas were far ahead of their time. His theory of the solar wind was dismissed by many, but he never lost faith in the power of scientific inquiry. Today, his name is synonymous with some of the most important discoveries in space science. The Parker Solar Probe mission is a fitting tribute to a man whose work has reshaped our understanding of the sun and its role in the solar system. It is a mission that will continue to provide insights into the nature of the sun, its magnetic fields, and its influence on the entire solar system for many years to come. The Parker Solar Probe is not just a technological marvel. It is a testament to the power of perseverance, vision, and the unwavering pursuit of knowledge. However, the Parker Solar Probe faces a significantly more daunting task compared to its predecessors. Unlike many other spacecraft, it must not only generate electrical energy, but also deal with a staggering amount of heat. Every watt of power it produces requires it to dissipate 13 watts of thermal heat energy. This intense demand makes the spacecraft's cooling system vastly more complex than what we typically see in other space missions. The cooling technology aboard the Parker Solar Probe operates in a way that's similar to the radiator in your car, but on a much more advanced level. The spacecraft is equipped with 2 specialized water pumps that circulate coolant through the spacecraft's solar panels and into large radiators. These radiators then release the excess heat into the cold void of space. Unlike the car radiator, which releases heat into the surrounding air, the radiators of the Parker Solar Probe send the excess thermal energy far into the depths of space, where the temperatures are near absolute zero. The challenges the Parker Solar Probe faces are magnified when it reaches its closest point to the sun, where temperature extremes become mind-boggling. The front surface of the spacecraft's heat shield, which is exposed directly to the sun's radiation, can reach temperatures up to a blistering 2,500 degrees Fahrenheit, 1,307 degrees. Meanwhile, the rear side of this same heat shield, facing the spacecraft's delicate instruments, can reach temperatures around 600 degrees Fahrenheit, 350 degrees Celsius. Despite such extreme conditions, the spacecraft's main body, the bus, remains at a comfortable 85 degrees Fahrenheit, 20 degrees Celsius, thanks to the protective heat shield. This extraordinary shield acts like a superhero, preserving the spacecraft's delicate electronics and instruments, allowing them to function flawlessly despite the scorching heat, and even as it ventures closer to the sun than any spacecraft has ever dared to go before. What's even more remarkable is the scientific ambition driving this mission. The Parker Solar Probe is tasked with addressing a monumental gap in our understanding of the sun, a gap that has been open for centuries. The The spacecraft is not just following in the footsteps of its predecessors, it is pioneering new territory, venturing deeper into the sun's environment than any other mission before it. For the first time, humans will have the opportunity to explore the sun's corona, the outermost part of its atmosphere, a region we have never studied up close. This is true exploration, setting out to answer questions we've never dared ask, and ultimately uncovering mysteries that might completely reshape our understanding of solar science. While we have many questions about the sun, we also know that there are still unknown unknowns. Some of our current theories about solar activity may very well be wrong, and the Parker Solar Probe is poised to set the record straight. As it peers into the sun's most extreme and enigmatic regions, it will not only answer questions we've been pondering for decades, but also generate new questions that could spark future missions and discoveries. The sun, a source of light and life, has been a mystery for so long, but with the Parker Solar Probe, that mystery is finally on the verge of unraveling. NASA's Parker Solar Probe is approaching a historic milestone. Soon it will fly closer to the sun than any spacecraft ever has, coming within about 4 million miles of its surface. To put that in perspective, that is a mind-bogglingly small distance compared to previous spacecraft missions. Getting this close, however, is no simple feat. It requires an incredible amount of energy and precision. When a spacecraft is launched from Earth, it has to carry with it the velocity of Earth's orbit around the sun, which is about 30 kilometers per second. To send a spacecraft even closer to the sun requires not only a significant amount of energy to overcome this velocity, but also extra speed to bring the probe within the sun's intense gravitational pull. In fact, the energy needed to send the Parker Solar Probe to the sun is 55 times greater than what's required to send a spacecraft to Mars, and twice as much as the energy needed to reach Pluto. The mission is not only challenging because of the immense energy requirements, but because the spacecraft must navigate through a chaotic and dangerous environment filled with intense heat and radiation. These factors pose a huge risk to communications with Earth. As the spacecraft gets closer to the sun, the radiation and heat could distort or even block signals, making it harder for mission control to maintain contact. This is where innovation comes in. To mitigate this challenge, the engineers at NASA designed a system known as rule-based autonomy, a form of artificial intelligence that allows the spacecraft to function independently, making real-time decisions without relying on constant communication from Earth. The system was designed with foresight. Engineers anticipated potential problems the spacecraft could face and programmed solutions into the system, allowing the Parker Solar Probe to solve issues autonomously. In the event of a failure, the spacecraft can troubleshoot itself, keeping its instruments operational even when contact with Earth is impossible. One of the most pressing concerns about such a mission is the possibility of encountering solar flares or coronal mass ejections, CMEs, explosive bursts of energy and charged particles from the sun. These events can look catastrophic when observed from Earth, but in reality, they are not as dangerous as they might seem. While they are powerful bursts of energy, the particles from these solar events are too diffuse to cause significant damage to the spacecraft. In fact, scientists would be thrilled if the Parker Solar Probe were to encounter one of these events, as it would provide an unprecedented opportunity to study the sun's explosive behavior in real time. The Parker Solar Probe is equipped with an array of sophisticated instruments designed to capture data from these solar phenomena. The spacecraft is equipped with instruments that can measure the sun's electromagnetic fields, high-energy particles, and even the visible light emitted by the sun. One of the most notable tools is the Wide Field Imager for Solar Probe, WESPAR, which is capable of taking stunning images of solar winds and other key phenomena surrounding the sun. WESPAR is designed to look in the direction of the spacecraft's motion, capturing light that is scattered by the dust and particles surrounding the sun, giving scientists a clearer picture of the sun's environment than ever before. As the Parker Solar Probe continues its journey toward the sun, it is not just a mission to study our star. It is a bold step into the unknown, one that will yield answers to questions that have eluded scientists for centuries, while opening the door to a future of discovery that will extend far beyond the reaches of our current understanding. Through this mission, humanity is on the verge of unlocking the sun's deepest secrets, and in doing so, learning more about the very forces that shape our solar system. The Parker Solar Probe is not just a spacecraft. It is a symbol of humanity's endless curiosity and drive to explore the cosmos. However, that's just the beginning. Once the dust has settled and the data clears, the true revelations begin to emerge. The whispers of data, often subtle and elusive, begin to reveal something far more captivating than initially anticipated. The light, scattered by electrons within the sun's corona and carried across space by the solar wind, carries secrets waiting to be uncovered. This is where the Parker Solar Probe comes into its own, offering unprecedented results. While previous instruments stationed some 93 million miles from the sun, about 1 astronomical unit, or AU, could only gather indirect data, this trailblazing spacecraft has dramatically closed that gap. By getting much closer to the sun, the Parker Solar Probe is able to observe our star in ways no previous mission ever could. This proximity means that it can study the sun with remarkable clarity, undisturbed by the interference of the space dust and particles that often cloud our view from Earth. In this sense, the spacecraft's vantage point offers a kind of pristine observation, allowing scientists to peer deeper into the sun's behavior and its immediate surroundings. But what truly sets this mission apart is its unique ability to push beyond the limits of past observations. The Parker Solar Probe can penetrate into regions that are otherwise obscured from afar, revealing the solar environment in its most untainted form. Alongside the spacecraft's powerful array of scientific instruments, there are other components designed to capture and measure specific phenomena within this uncharted territory. For instance, there are 3 key sensors tasked with measuring the magnetic fields surrounding the sun. These sensors are positioned on a specialized boom, a long arm that extends from the spacecraft itself, ensuring they are safely shielded from the intense sunlight and solar radiation. This careful placement minimizes interference, allowing the instruments to gather precise data on the sun's magnetic environment. Furthermore, the Parker Solar Probe is equipped with 5 electric field sensors that extend into the heart of the solar wind, capable of withstanding the sun's extreme heat. These sensors measure the plasma voltage, a critical factor in understanding the sun's behavior and the dynamics of its energy. Interestingly, scientists use 2 primary techniques to measure electric fields in space: the double probe method and the method that detects plasma waves or radio waves. The Parker Solar Probe integrates both of these methods, combining them for the first time. This groundbreaking approach is expected to produce a wealth of data, offering a more nuanced understanding of the sun's electrical activity. Initially, the data gathered might appear as nothing more than a collection of raw numbers. However, these seemingly simple measurements hold the potential to paint a much richer picture. Scientists will use the data to create detailed visualizations, such as spectrograms, and compare it with pre-existing models to help clarify how the sun's corona behaves and how its magnetic fields operate. Among the primary goals of this mission is to unravel one of the most enduring mysteries about the sun: how its corona, the outermost layer of its atmosphere, gets heated to such extreme temperatures. To accomplish this, scientists need to understand the intricate flow of energy within the corona, a process known as Poynting flux. The key to this understanding lies in measuring both the magnetic and electric fields that permeate the corona. By placing its sensors directly within the plasma, the superheated electrically charged gas that surrounds the sun, the Parker Solar Probe is now collecting data in an environment no spacecraft has ever dared to explore before. The scientific instruments aboard the probe are diverse and finely tuned to provide new insights into solar phenomena. One such set of tools is the SWEEP and ISIS packages, which are specifically designed to study particles emitted by the solar wind. For example, the ISIS instrument analyzes energetic particles across a broad range of energies, from the relatively mild particles of the solar wind to the far more intense bursts released during solar flares. By studying these particles, scientists can gain invaluable insights into the processes that govern solar behavior and the broader solar environment. The sweep investigation, on the other hand, consists of three separate instruments that focus on measuring different types of particles in the solar wind. These instruments will provide critical data on the solar wind and the solar atmosphere itself, helping to uncover how the solar wind is heated and how energy is transferred throughout the sun's outer layers. By measuring the movement of particles like electrons, hydrogen, and helium ions, as well as other minor ions, scientists will be able to deduce a great deal about the temperature, density, and pressure of the solar wind. These combined efforts promise to unlock many of the sun's long-held mysteries. They will shed light on phenomena like solar flares, coronal mass ejections, and the general behavior of the solar wind. All of these discoveries are not only crucial for understanding the sun itself, but also for grasping its broader effects on our solar system, and specifically, our planet. The Parker Solar Probe is at the cutting edge of this journey, but it is not the only mission tasked with unveiling the sun's secrets. The European Space Agency, in collaboration with NASA, is preparing to launch the Solar Orbiter, a mission that will work in tandem with the Parker Solar Probe. The Solar Orbiter, however, will not follow the same path. While the Parker Solar Probe will get closer to the sun than ever before, the Solar Orbiter will take a higher inclined orbit, allowing it to study the sun from an entirely different perspective. Specifically, it will be able to observe the sun's poles, areas that the Parker Solar Probe cannot reach. Together, the Parker Solar Probe and the Solar Orbiter will provide an unprecedented, multifaceted view of the sun. The Parker Solar Probe will delve deeper into the solar atmosphere than any spacecraft before it, while the Solar Orbiter will offer a broader view from higher up. The combination of these two missions will yield a comprehensive understanding of the sun's behavior, helping to illuminate the forces that shape not only our star, but the entire solar system. The findings from these two spacecraft will revolutionize our understanding of space, energy, and the forces that govern the very fabric of our solar system. They will provide critical insights into the sun's behavior, from its magnetic fields and electric currents to the particles emitted by solar flares and coronal mass ejections. As scientists continue to analyze this data, we will be able to understand not only how the sun works, but also how it impacts Earth and the other planets that orbit it. In many ways, the sun is the heartbeat of the solar system, and by unlocking its deepest secrets, we are coming closer than ever to understanding the fundamental forces that shape life on Earth. As the Parker Solar Probe presses onward into the unexplored frontier, and as the Solar Orbiter follows close behind, humanity is on the brink of a new era of solar exploration. What they discover will have profound implications, not just for space science, but for our everyday lives here on Earth. The Earth itself, a blue and vibrant sphere, is surrounded by a thin but critical layer of gases known as the atmosphere. Though often invisible to the naked eye, this layer is anything but simple. It is a complex and delicate system that plays a pivotal role in sustaining life, regulating climate, and protecting us from the harshness of space. The more we learn about the sun, the more we realize the intricate interdependence of these systems, as our sun's behavior has a profound influence on the atmosphere and, by extension, the life that it supports. Understanding the sun through instruments like the Parker Solar Probe may one day offer us the key to unlocking more than just the mysteries of space. It may offer us deeper insight into the fragile balance that keeps life on Earth possible. Our planet's atmosphere is far more than just a thin layer of air. It's a complex and vital shield, silently working to protect life in ways that often go unnoticed. Beyond just giving us the air we breathe, it serves as a barrier against the vast, hostile emptiness of space, preventing us from drifting away into the void. It absorbs and deflects harmful solar radiation, which, if left unchecked, could devastate living organisms across the planet. Moreover, it maintains the delicate balance of gases, such as oxygen and carbon dioxide, that sustain plant and animal life. The atmosphere is not just a passive element in our survival. It is an intricate system, one that we are only beginning to fully understand. With every new advancement in technology, we uncover more about how this fragile system functions and how we can better protect it. One of the most exciting developments in atmospheric science is the launch of a new satellite by the European Space Agency, ESA, designed to provide a clearer, more detailed picture of our atmosphere's behavior. This satellite, known as Aeolus, represents a groundbreaking effort to use cutting-edge technology to study wind patterns on a global scale. Using advanced laser technology, Aeolus will give scientists a never-before-seen look at wind movement around the planet. For the first time, they will be able to observe wind profiles, speed, direction, and movement in real time. This technological leap will dramatically enhance weather prediction accuracy, a crucial factor for everything from daily forecasts to long-term climate modeling. Before Aeolus, wind data was gathered through limited methods such as weather balloons and aircraft, which could only capture information at specific points on Earth. These traditional methods provided snapshots, but they left vast gaps in our understanding. Wind is dynamic, shifting constantly at varying altitudes, and these gaps meant that scientists were only seeing parts of the whole picture. Aeolus, however, will fill in those missing pieces. By collecting data from space, the satellite will offer a comprehensive global view of wind patterns, from the surface all the way up to the upper reaches of the atmosphere. The mission is groundbreaking not only because it will allow for global real-time wind observation, but because it's the first time a satellite has used a laser system to study wind profiles. Wind flows at different speeds and directions at various altitudes, and understanding these movements is key to predicting everything from weather changes to major climate phenomena like storms, temperature shifts, and rainfall patterns. With Aeolus, scientists can track wind at different heights, offering insights that were previously impossible to gather in such detail. Aeolus will orbit the Earth at an altitude of 3,020 kilometers, following a sun-synchronous path. This means that the satellite will pass over the same region of the planet at the same local time every day, ensuring that the data it collects is consistent across seasons and time periods. Every 90 minutes, Aeolus will transmit its findings to a ground station located between Norway and the North Pole. This data will then be distributed to meteorological institutions across Europe, significantly enhancing the accuracy of weather forecasts worldwide. When you watch a weather report on television, you'll know that it's based on more up-to-date and precise information, thanks to the contributions of Aeolus. The heart of this mission is the satellite's Aladdin instrument, a highly specialized piece of technology that uses an ultraviolet laser to study the atmosphere. As the laser beam travels through the air, it interacts with tiny moisture particles in the atmosphere. Since these particles move with the wind, the way the light reflects back to the satellite reveals crucial information about wind speed and direction at different altitudes. This process leverages the Doppler effect, a phenomenon that measures the change in the wavelength of light as it reflects off moving particles. By analyzing these shifts, scientists can determine wind speeds with remarkable precision. But achieving this level of precision hasn't been easy. The development of the Aeolus mission has taken more than 16 years of research, testing, and adaptation. During the early stages of development, the team encountered unexpected challenges. When they first activated the instrument, it worked flawlessly, but when they placed it in a vacuum chamber, it stopped functioning. This revealed a critical oversight. To keep the laser active in space, oxygen was required. This discovery led to a series of redesigns and solutions that involved rethinking the system from the ground up. It was a valuable lesson in problem solving, and despite the setbacks, the team pressed on. The final design of the satellite incorporated a range of advanced technologies, some of which had never been used before in space. One of the key breakthroughs was the creation of a highly stable laser system capable of functioning in the harsh conditions of space. Ensuring the laser stability was a challenge in itself, but the team succeeded by developing a robust optical system to direct and focus the beam. The laser's power and reliability are essential to the satellite's ability to gather and transmit accurate data. Furthermore, advancements in coding technology help protect the optical components, ensuring that the system would perform optimally in space's extreme environment. Aeolus is just one example of the ESA's broader Earth Explorer missions, which aim to collect critical data about our planet's ecosystems and atmosphere. The mission highlights the European space industry's expertise and its commitment to improving our understanding of Earth's delicate systems. The successful launch of Aeolus will provide valuable data that could help mitigate the effects of climate change, improve weather forecasting, and ultimately save lives. The importance of understanding our atmosphere doesn't end with wind patterns. Air pollution is another pressing issue that ESA is addressing through its Earth observation programs. The European Union's Copernicus program, for instance, aims to monitor and track atmospheric pollutants to improve air quality worldwide. Satellites like Envisat and the Sentinel-5 precursor are critical in this effort, providing data on harmful gases like ozone and tracking pollutants that negatively impact both the environment and human health. Envisat, one of the earlier satellites in this series, was instrumental in gathering large-scale atmospheric data, but as it reached the end of its operational life, there was a need for continuity. This is where the Sentinel-5 precursor comes into play. Launched as a successor to Envisat, it ensures that atmospheric pollution monitoring continues seamlessly. The Sentinel-5 precursor uses a sophisticated spectrometer called tropomi to detect trace gases in the atmosphere, particularly pollutants that can cause significant health problems. By tracking the depletion of ozone, for example, it provides crucial information about the protective layer that shields us from harmful ultraviolet radiation. The Sentinel-5 precursor is a crucial step in a larger mission to monitor Earth's atmosphere continuously. It serves as a gap filler between past and future satellite missions, ensuring that vital data is collected during transitions. It is especially significant given the alarming rise in air pollution, which is responsible for millions of premature deaths each year, according to the World Health Organization. With this satellite, scientists can actively improve air quality forecasts, which are vital for people suffering from respiratory conditions and for the general public as well. As these space missions continue to evolve, they will provide invaluable insights into how we can better protect our planet and the delicate systems that support life. Whether it's understanding wind patterns, tracking air pollution, or monitoring ozone depletion, the technology driving these missions is not just advancing our scientific knowledge, but also contributing to a future where we can more effectively address the global challenges that threaten our environment and well-being. During large-scale environmental events, such as devastating wildfires or widespread smog outbreaks, the ability to track pollutant emissions over time becomes invaluable. By utilizing advanced tools like the tropomi spectrometer aboard satellites, scientists can meticulously track changes in pollution levels and their immediate and long-term effects on the atmosphere. The data derived from this technology offers crucial insights into how pollutants spread, interact, and impact both local and global environments. For instance, when new environmental regulations are introduced, scientists can use emission tracking data to assess their effectiveness. A drop in pollutant levels after a new policy is enacted typically indicates that the measures are making a positive impact. Conversely, if emission levels remain persistently high, it signals that the policies might not be sufficient, prompting the need for further action. This real-time analysis is vital for adjusting strategies aimed at curbing air pollution and mitigating its health impacts. Smog, one of the most visible and harmful consequences of air pollution, not only severely compromises public health, but is also a leading driver of climate change. Pollutants such as carbon dioxide, CO2, and methane, CH4, play a critical role in global warming by trapping heat in the atmosphere. Understanding how these pollutants are released, transported, and accumulated is essential for creating effective mitigation strategies. To better understand air pollution and its far-reaching consequences, scientists rely on a combination of both local and global measurement stations. For example, a mobile air measurement station in Bremen, Germany, provides highly localized data detecting industrial emissions and local smog levels. This data can complement and validate satellite observations, ensuring that researchers have a more accurate and nuanced understanding of air quality across different regions. Satellites, such as those used in the European Space Agency's ESA Sentinel missions, play a pivotal role in providing global data for atmospheric research. These satellites monitor changes in atmospheric conditions, giving scientists access to critical information about the movement of pollutants, how they interact with clouds, and their eventual deposition back to Earth. Through this technology, researchers can track how pollutants are transported across vast distances, often traveling from one country to another, adding complexity to the global fight against pollution. One of the key challenges in atmospheric science is distinguishing between natural events and human-induced anthropogenic changes. While the planet's atmosphere is constantly in flux due to natural processes like volcanic eruptions or forest fires, human activities such as industrialization, agriculture, and urbanization have dramatically altered these systems. Accurate identification of human-driven pollution versus natural occurrences is crucial for effective policymaking. Without this distinction, policies aimed at reducing pollution may either fail or overreach. The Sentinel-5P mission, launched by the European Space Agency, represents a significant leap forward in environmental monitoring. One of its most groundbreaking features is the ability to observe air quality with unprecedented detail. The satellite's instrument, the Tropomi spectrometer, is capable of detecting trace gases such as nitrogen dioxide, NO2, sulfur dioxide, SO2, and methane, key contributors to poor air quality and climate change. With a pixel size as small as 5 kilometers by 7 kilometers, the Sentinel-5P provides a high-resolution view of pollutant distribution, allowing scientists to track how these emissions move, concentrate, and dissipate across the globe. The real power of the Sentinel-5P mission lies in its ability to integrate satellite data with ground-based air measurements. While satellites provide a broad bird's-eye view of global pollution patterns, local air stations provide finer detail on specific areas. This combination of satellite data and on-the-ground monitoring gives researchers an accurate and complete picture of air quality, helping to guide policies and inform the public on pollution levels and health risks. Air pollution remains one of the deadliest global challenges, contributing to millions of premature deaths every year. It is estimated that between 3 and 7 million people die annually from exposure to polluted air. This staggering figure highlights the urgency of monitoring and addressing pollution at both local and global levels. With the help of missions like Sentinel-5P, scientists and policymakers are better equipped to understand the sources and movements of pollutants, providing the necessary data to craft laws that reduce harmful emissions and improve public health. Atmospheric measurements provide more than just data on pollution levels. They also help to identify air quality trends over time, revealing the effectiveness of government regulations. For example, Europe has passed numerous laws aimed at reducing greenhouse gas emissions, and satellites like Sentinel-5P play a key role in verifying whether these laws are having the desired impact. By monitoring emissions across vast regions, satellites help ensure that countries remain accountable to their environmental goals. In the early 2020s, the Sentinel-4 and 5 satellites will further extend the capabilities of the Sentinel-5P mission. Sentinel-5P orbits the Earth in a low polar orbit, allowing for detailed global atmospheric monitoring, while Sentinel-4 will be stationed in geostationary orbit, offering real-time, continuous data collection. These complementary satellites will provide a fuller, more immediate picture of atmospheric changes, tracking everything from air quality to larger climate shifts. The data collected by the Sentinel missions is part of the larger Copernicus Earth Observation Program, CERNUS, which integrates observations from across the planet to provide a comprehensive understanding of environmental changes. In addition to monitoring the atmosphere, CERNUS tracks ocean conditions, land surfaces, ice caps, and more. This holistic approach helps scientists, policymakers, and citizens alike stay informed about the planet's health and take action when necessary. Beyond air quality, the Sentinel-5P mission also contributes valuable data on ultraviolet UV radiation levels. By monitoring UV radiation, scientists can provide real-time alerts to the public, warning about the dangers of prolonged sun exposure. These alerts help people make safer decisions when spending time outdoors, potentially reducing the risk of skin cancer and other health issues linked to UV exposure. Sentinel-5P data also has the potential to improve public health outcomes by offering precise information about pollutants like ozone, nitrogen dioxide, sulfur dioxide, and particulate matter. These substances have serious implications for people with respiratory or cardiovascular conditions. By tracking these pollutants, Sentinel-5P enables governments to target interventions more effectively, protecting vulnerable populations. In Europe, exposure to air pollution is responsible for over 400,000 premature deaths each year. Although pollution levels have improved in some regions, such as Europe, the United States, and Japan, the problem persists in many developing countries, particularly in Asia. Rising energy consumption and an increasing number of vehicles are contributing to worsening air quality. However, countries like China are taking bold steps to address the issue. China has introduced stringent regulations and implemented cutting-edge technologies to reduce pollution, mirroring the progress made in other industrialized nations. The role of satellites in monitoring air quality cannot be overstated. They provide critical insights into pollution patterns, offering a global perspective on where pollutants are being emitted, how they travel, and where they eventually settle. However, satellites alone cannot give a complete picture. To fully understand pollution, satellite data must be compared with ground-based measurements, which provide finer details about local conditions. By combining these two data sources, scientists can develop more accurate models of pollution, making it easier to predict air quality and implement effective policies. Atmospheric pollution, including gases like CO2, methane, and ozone, plays a significant role in climate change. Predicting how these pollutants will behave in the atmosphere is complex, even with advanced computer models that simulate atmospheric conditions. These models, while sophisticated, are sometimes incomplete, failing to account for all the variables that influence atmospheric chemistry and physics. As a result, scientists frequently discover new, surprising phenomena about how pollution behaves in the atmosphere. Despite the complexity of atmospheric science, satellites like those in the Copernicus program provide essential insights into pollution patterns. By combining satellite data with ground-based observations, scientists can improve their predictions about air quality and climate change. This ability to predict pollution levels helps inform public health strategies, guiding individuals and communities in making informed choices about their environment. The Copernicus program is a key example of how satellite data can be used to monitor and protect the planet. Through continuous observation and analysis, CERNUS helps policymakers make data-driven decisions about climate change, pollution, and other environmental challenges. The program provides free satellite data to anyone around the world, offering a vital tool for understanding and preserving our planet's health. For more than 50 years, humanity has directed its attention toward Mars, sending countless probes, orbiters, and landers to study the red planet. These missions have mapped Mars's rugged terrain, analyzed its atmosphere, and searched for signs of life. Yet their ultimate goal extends beyond mere exploration. These robotic pioneers are preparing the way for human settlement. The next generation of robotic explorers is already being designed, pushing the boundaries of technology to ensure humanity's future presence on Mars. One day, astronauts will step foot on Mars, not only to explore, but to claim it as a new home for mankind. However, Mars has presented yet another formidable challenge: how to adjust the spacecraft's orbit without relying on traditional fuel. Instead of using conventional propulsion methods, scientists have turned to an innovative technique known as aerobraking. This ingenious process involves guiding the spacecraft to skim the thin upper layers of Mars's atmosphere. By doing so repeatedly, it makes use of the planet's air resistance, gradually slowing the spacecraft down without expending any fuel. It's a delicate dance, demanding highly precise calculations, as the density of Mars's atmosphere is notoriously unpredictable. Any error in the calculations could result in mission failure. In fact, this method took more than a year to complete, with every maneuver requiring fine-tuning and constant monitoring. The primary goal of the mission was to send the trace gas orbiter to search for methane in Mars's atmosphere. Methane on Earth is produced by both geological processes and living organisms. If scientists were able to confirm that the methane on Mars is of biological origin, it would be groundbreaking. It could indicate that despite Mars's arid, desolate exterior, life may exist, or may have existed, beneath its surface. This tantalizing possibility has led to the question: Is the methane a product of geological processes, or is it a sign that Mars is not the lifeless planet we thought it to be? With the Trace Gas Orbiter collecting invaluable atmospheric data, the next phase of Mars exploration takes a giant leap forward, sending a rover to investigate the surface up close. The ExoMars 2020 mission, later renamed Rosalind Franklin, aims to land a sophisticated rover on the Martian surface, equipped with a specialized drill capable of burrowing deep beneath the soil, far enough to escape the planet's harsh radiation. Scientists believe that if Mars ever supported life, any potential remnants or traces of it would likely be found in the subsurface, shielded from the destructive rays of the sun. As a result, the team carefully selected potential landing sites. 2 locations, Oxia Planum and Marth Vallis, were shortlisted based on strong geological evidence that they may have once contained liquid water, an essential ingredient for life as we know it. The goal is to land in a region that dates back over 3.9 billion years, when Mars may have had conditions strikingly similar to those on early Earth. More crucially, the presence of ancient, slow-moving water in these areas increases the likelihood that organic molecules could have been preserved over time. As robots continue to conduct the majority of the exploration, every mission, every probe, and every piece of data we collect takes us one step closer to the moment when humans will finally set foot on the Martian surface. Technology continues to advance, knowledge grows, and the dream of walking on Mars moves closer to reality. The next wave of missions to Mars is already underway, led by NASA's InSight mission, which represents a groundbreaking shift in the way we study the red planet. For the first time in history, a spacecraft launched from California's Vandenberg Air Force Base is headed to Mars. Engineers and scientists have spent years ensuring that every aspect of the lander is prepared to perfection, undergoing rigorous pre-flight testing. After these extensive checks, the spacecraft was transported to the launch site, ready for liftoff. Unlike previous missions that focused primarily on surface exploration or the search for signs of life, the InSight mission is designed to study Mars from the inside out. It is a geophysical mission, meaning it seeks to investigate the planet's internal structure, its crust, mantle, and core. By studying the heartbeat of the planet, scientists aim to better understand how Mars formed and evolved over billions of years. To accomplish this ambitious goal, the InSight spacecraft is equipped with several advanced scientific instruments. Among the most critical is a highly sensitive seismometer designed to detect vibrations caused by Marsquakes, which are the Martian equivalent of earthquakes. By analyzing these tremors, scientists will be able to map Mars's internal layers in much the same way doctors use ultrasound to view the inside of the human body. This data will provide invaluable insights into the Martian interior, just as seismology has allowed us to explore Earth's core. Another key instrument aboard InSight is the Heat Flow and Physical Properties Package, HP3, which includes a heat flow probe that will burrow deep into the Martian soil by drilling up to 16 feet below the surface. By measuring the amount of heat escaping from Mars's interior, scientists hope to gauge how much energy remains inside the planet. This will offer clues about whether Mars was once geologically active and whether there may still be molten material beneath its surface. Additionally, the Rotation and Interior Structure Experiment, RISE, will measure how Mars wobbles as it orbits the Sun. This subtle movement, caused by the interactions between the planet's core and outer layers, can reveal vital details about the size, composition, and density of Mars's core, information that has been elusive up until now. Together, these instruments promise to revolutionize our understanding of the Martian interior and provide crucial data on how planets like Mars and Earth evolved. Mars's unique characteristics make it an ideal Goldilocks planet, neither too large nor too small, but perfectly situated for studying planetary formation. If Mars had been much larger, its geological activity over the ages would have erased important evidence about its early history. Conversely, if it had been smaller, it may never have undergone the same geological processes that shaped Earth and other rocky planets. As a result, Mars offers an unparalleled opportunity to investigate the early stages of planetary evolution, And by studying its deep interior, InSight is poised to help answer fundamental questions about the formation of planets. Scientists have long believed that all rocky planets, including Earth, Venus, and even exoplanets in distant star systems, underwent similar developmental stages. But until now, we've lacked direct data on the internal structures of other planets. InSight is poised to fill that gap, providing valuable insights that were once only theoretical. Meanwhile, NASA is not alone in its pursuit of Mars exploration. Other space agencies, including the European Space Agency, ESA, Russia's Roscosmos, and new entrants like China, Japan, India, and the United Arab Emirates, are intensifying their efforts to study Mars. As more countries invest in space exploration, humanity is entering a new era of interplanetary discovery, one that may one day lead to human settlements on the Red Planet. Sending humans to Mars is one of NASA's most ambitious goals, and they are not working in isolation. Many other space agencies and private companies are equally committed to making this dream a reality, propelling us ever closer to a future where humanity becomes a multiplanetary species. Getting to the Red Planet is far from a simple feat. It's not just about designing and launching a massive rocket. The journey involves a myriad of challenges: engineering obstacles, logistical complexities, and intricate political considerations that must be addressed before humanity can embark on a successful voyage to Mars. While NASA's Space Launch System, SLS, and the Orion spacecraft are key components, they represent only small parts of a much larger puzzle. To make the dream of interplanetary travel a reality, collaboration between space agencies from all around the world is essential. NASA, the European Space Agency, ESA, the Canadian Space Agency, and Russia's Roscosmos are among the key players working together to build a crucial piece of infrastructure for deep space missions: the Gateway. The Gateway is a planned space station that will be positioned in a unique orbit between the Earth and the Moon. This space station will serve as a critical waypoint for future deep space exploration, acting as both a launch pad and a staging area for astronauts heading to and from the Moon, Mars, and beyond. It will be much more than just a stopover. The Gateway will facilitate a wide range of activities, including the gathering and processing of lunar resources, which prove vital for sustainable space exploration. Ultimately, it will become an assembly and construction hub where spacecraft bound for Mars will be built and prepped for their interplanetary journeys. A key element in this ambitious plan is NASA's partnership with private companies. One such collaboration involves Orbital ATK, which has been selected as one of 6 companies tasked with advancing technologies for missions beyond Earth. Through the Next Step 2 program, Orbital ATK is working on a vision to build a space station in lunar orbit, what they call a staging post. This station will serve as a crucial waypoint for astronauts and spacecraft before they venture further into space. Orbital ATK's plan builds upon the success of their Cygnus cargo spacecraft. The first phase of the project involves launching a habitat module into space using NASA's powerful SLS rocket. This module, along with the Orion Crew capsule, will be positioned in lunar orbit, laying the foundation for a base that will support scientific experiments and missions. By 2025, additional modules will be added, expanding the habitat and enabling the delivery of supplies, crew, and even waste disposal systems. One of the most compelling aspects of a lunar base is the opportunity to tap into the Moon's rich resources, particularly water. Scientists believe that large quantities of frozen water exist in the permanently shadowed craters near the Moon's south pole. If this water can be harvested and converted into hydrogen and oxygen, it could be used to produce rocket fuel, breathable air, and drinking water. This would be a game changer for future missions, as it could drastically reduce the cost and complexity of space travel. Astronauts could also venture down to the Moon's surface to mine valuable resources, making lunar exploration a stepping stone for deeper space exploration. The possibilities extend beyond water mining. The far side of the Moon, shielded from the interference of Earth's radio signals, provides an ideal location for building astronomical observatories. With the absence of radio noise and radiation, this area offers the perfect environment for studying the universe in unprecedented detail, potentially unlocking secrets about the origins of the cosmos. Beyond the Moon, The Gateway will lay the foundation for human missions to Mars, with aspirations for the first crewed expeditions slated for the 2030s. As more habitat modules are added, the lunar station could evolve into a launch platform for Mars-bound missions. These missions, which are expected to last up to 1,000 days, will test humanity's ability to survive for extended periods in space, working through challenges like long-duration isolation and limited resources. Boeing, the primary contractor for NASA's SLS rocket, estimates that it will take 5 or 6 SLS launches to send a crew to Mars. The journey itself is fraught with difficulty, largely due to the orbits of Earth and Mars. Every 2 years, there is a narrow window in which the two planets align in a way that allows for the journey. Even with the optimal timing, the trip to Mars will take about 7 to 8 months. Once astronauts arrive, they will have to wait for the planets to align again, which means staying on Mars for at least a year before embarking on the return journey, another 7 to 8 months. A lunar space station is not just a necessary stepping stone for NASA and its partners. It also opens up exciting prospects for international collaboration and commercial opportunities in space exploration. Lunar exploration, technological advancements, and scientific discoveries will not only advance humanity's presence in space, but also create a wealth of new possibilities for private companies and countries alike. Once humans have mastered operations in lunar orbit, the next step will be to send astronauts to Mars itself. This ambitious mission will help refine the spacecraft and systems necessary for a full-scale landing on the red planet. Eventually, astronauts will set foot on Mars, conducting experiments and uncovering its many secrets, some of which have been hidden for billions of years. Lockheed Martin, a leading aerospace manufacturer, is working on a bold plan to send humans to Mars. Their vision goes far beyond the concept of a simple spacecraft. Under development is a multi-module system that includes several interconnected units, each serving a specific function in the Mars exploration process. At the heart of this system is a power and propulsion unit, which supplies electricity and movement to the entire mission architecture. In addition, 2 habitat modules will house astronauts during their long journey, with an airlock module for spacewalks and a logistics module for essential equipment and supplies. The spacecraft will rely on cargo and crew modules from both the United States and Russia. When fully assembled, this system could serve as a long-term transport vehicle and home for astronauts on deep space missions. The first stage of the plan involves building a space gateway in lunar orbit, which will serve as a platform for assembling the Mars base camp. Lockheed Martin's vision for Mars Base Camp is a self-sustaining space station designed with redundancy in all critical systems to ensure the safety of the crew. It will feature 4 large solar panels to generate power and 2 cryogenic stages to provide propulsion. The system will also include 2 tank farms for fuel storage. The crew will live in habitat modules, with a central living area where they can sleep, eat, and exercise. Orion, NASA's crewed spacecraft, will serve as the command center, providing all navigation, communication, and avionics systems necessary to keep the mission on course. Mars Base Camp will enable exploration not just of the planet itself, but also of Mars's 2 moons, Phobos and Deimos. Astronauts will deploy landers and robotic explorers to these moons, gathering valuable data and samples to better understand the Martian system. The ultimate goal, however, is to use the station as a launch pad for human landings on Mars. Once in orbit, astronaut scientists will guide robotic missions, directing rovers and drones to explore the Martian surface and identify the best landing sites for future crewed missions. One of the most exciting developments in Mars exploration is Lockheed Martin's proposed Mars lander, known as the MV lander. Unlike many science fiction depictions of space travel, the MV lander is based on proven technology, including systems from Orion and the Space Shuttle. Designed to be reusable, the MV lander can safely land on and take off from Mars multiple times, making long-term exploration of the planet more feasible. The key to making Mars missions more affordable and sustainable lies in reusability, and innovation is at the heart of this strategy. Meanwhile, SpaceX is focused on lowering the costs of space travel with its ambitious BFR program. The BFR, or Big Falcon rocket, is designed to be a direct transportation system to Mars, making the journey more efficient and affordable. The plan starts with the launch of a reusable booster, followed by a brief stop in low Earth orbit to refuel. From there, the spacecraft will head directly to Mars, taking about 2 months, taking about 3 months to reach the red planet. Once it spacecraft will use local resources to refuel, preparing for the return journey to Earth. The reusability of the BFR means it can make repeated trips between Earth and Mars, dramatically reducing costs over time. SpaceX is also working on the Falcon Heavy rocket, which is expected to make its first flight soon. One of the biggest challenges in traveling to Mars is the long cruise time. The BFR addresses this by significantly reducing the journey time to just 3 months, compared to the 7 or 8 months required by other spacecraft. Shortening the trip means fewer resources are needed to sustain the crew during the journey, easing the logistical challenges of long-term space travel. One potential breakthrough technology that could further speed up the journey is nuclear thermal propulsion, NTP. NTP works by using the heat generated from nuclear fission to superheat hydrogen propellant to temperatures as high as 2,420 degrees Celsius. This hot hydrogen is then expelled through an exhaust nozzle, providing twice the efficiency of the best chemical rocket engines currently in use. With the use of low-enriched uranium, safer than the highly enriched uranium used in conventional nuclear reactors, NTP technology could significantly cut down the travel time to Mars, reducing the amount of food, water, and energy required for the crew, while also minimizing the risks of long-duration space travel, such as exposure to harmful cosmic radiation and the effects of microgravity. Each step forward in these developments brings humanity closer to realizing the dream of traveling to Mars. It is a journey that will require ingenuity, international cooperation, and relentless determination. The challenges are immense, but the potential rewards are beyond measure. Through innovation and collaboration, we are preparing to push the boundaries of human exploration further than ever before. In the vast expanse of space, the development of advanced technologies is essential for the success of future missions to the Moon, Mars, and beyond. One such technology, nuclear thermal propulsion, NTP, could play a pivotal role in supporting long-term human presence on distant celestial bodies. These systems would not only provide the power necessary for life support and communication, but could also facilitate industrial applications on these far-off worlds, enabling sustainable exploration and habitation. Nuclear thermal propulsion represents a crucial first step toward achieving the development of more advanced propulsion systems that could revolutionize space travel. The potential of NTP technology could drastically reduce travel times across the solar system, paving the way for missions that were once thought to be far beyond our reach. With its promise of higher efficiency, NTP could even enable humanity to venture deeper into the cosmos, unlocking new possibilities for exploration and discovery. Meanwhile, on a smaller but equally ambitious scale, the Japanese Hayabusa 2 mission has been making history by investigating an asteroid 300 million kilometers from Earth. Launched by the Japan Aerospace Exploration Agency, JAXA, on December 3, 2014, the mission's goal was clear: to collect valuable samples from the surface of the asteroid Ryugu. This follow-up to the original Hayabusa mission, which had returned asteroid samples back to Earth in 2010, carried the hopes of scientists worldwide who sought to unlock the mysteries of our solar system's formation and the origins of life. Hayabusa 2 reached its destination, Ryugu, on June 27, 2018, after nearly 4 years of travel through the void. This carbon-rich asteroid, previously known as 1993 JU3, holds critical information about the early days of our solar system. These types of asteroids are considered to be some of the oldest, and their material is thought to contain clues about the formation of planets, as well as organic compounds and water, key elements that may have played a role in the development of life on Earth. For over a year, the spacecraft remained in orbit around Ryugu, studying the asteroid's surface from various altitudes to map out its geography. Equipped with advanced scientific instruments, Hayabusa 2 began its crucial task of gathering samples. The mission's groundbreaking accomplishments would not end with just one asteroid, though. The spacecraft's journey is set to continue until at least 2031, with plans to visit another asteroid, 1998 KY26, a fast-spinning body in space. This future exploration will provide even more opportunities to better understand the nature of these celestial objects and their role in the grand narrative of our solar system. One of Hayabusa 2's remarkable innovations was its array of advanced tools, including 4 miniature rovers. Deployed to explore Ryugu's surface, these rovers gathered essential data on the asteroid's environment and geology. The data gathered by these rovers could help scientists shed light on questions that have baffled researchers for decades. How did our solar system form? How did water and organic compounds, the building blocks of life, come to exist on Earth? These questions may be answered with the help of Hayabusa 2's findings, opening up new avenues for understanding not just our own origins, but the potential for life elsewhere in the universe. The mission's first major milestone occurred on September 21, 2018, when Hayabusa 2 released 2 rovers, Rover 1A, Hibu, and Rover 1B, Owl, which safely landed on Ryugu's surface after falling from a height of approximately 55 meters. These rovers performed as expected, sending back valuable data that was used to assess the surface conditions of the asteroid. Just days later, on October 3rd, a third rover, Mascot, was successfully deployed. Operating for 16 hours, Mascot completed its mission, providing even more insight into the asteroid's surface features. Despite these successes, the mission faced challenges. Initial plans to collect samples from Ryugu's surface in late October 2018 were delayed due to an unexpected problem. The asteroid's surface was not suitable for gathering the desired soil samples, as it was filled with large boulders and other obstacles. As a result, the mission team had to rethink their approach, delaying sample collection until February 2019. However, their perseverance paid off. On February 21, 2019, Hayabusa 2 succeeded in its first sample collection, marking a significant achievement in the history of asteroid exploration. Yet, this was only the beginning. In April 2019, the spacecraft released an impactor designed to create a small artificial crater on the asteroid's surface, allowing it to gather material from beneath the outer layer. This operation would allow scientists to study pristine materials that had been shielded from the harsh conditions of space. While the mission faced setbacks, such as a failure in May 2019 when Hayabusa 2 was unable to drop special reflective markers necessary for guiding its descent and sample collection, the spacecraft's engineers remained resilient. By June 4, 2019, they successfully released one of the markers from a mere 9 meters above the surface, setting the stage for the final successful collection of subsurface samples on July 11, 2019. With its mission to Ryugu complete, Hayabusa 2 departed the asteroid on November 13, 2019, embarking on its long journey back to Earth. On December 6, 2020, the spacecraft successfully delivered its precious samples by parachuting them into a designated drop zone in southern Australia. The samples were quickly retrieved and transported to Japan for analysis, where they are now being studied to unlock the secrets of the early solar system. The spacecraft's design was a significant improvement over its predecessor. Weighing in at just 600 kilograms, Hayabusa 2 was equipped with advanced ion engines, enhanced navigation systems, and better antennas. Among its many innovations was the use of a kinetic penetrator, a device that used a high explosive charge to burrow into the surface of Ryugu, revealing fresh material from beneath the asteroid's exterior. This breakthrough allowed the spacecraft to collect pristine samples that would otherwise have remained hidden. In terms of propulsion, Hayabusa 2 relied on 4 solar-powered ion engines known as Micro-10 thrusters. These engines used microwaves to turn xenon gas into plasma, which was then accelerated by solar panels to propel the spacecraft through space. Despite the small force generated by these engines, they were highly efficient, allowing Hayabusa 2 to reach speeds of up to 28 kilometers per second while consuming only 66 kilograms of xenon fuel. This made the spacecraft capable of traveling great distances with minimal energy consumption. To help it navigate and remain oriented while in space, Hayabusa 2 was equipped with a set of reaction wheels and chemical thrusters. It also carried a sophisticated communication system, which included high-gain antennas that transmitted data back to Earth at speeds ranging from 8 bits per second to 32 kilobits per second. The spacecraft's optical camera system, including a telescopic camera and wide-field cameras, was essential for capturing detailed images of Ryugu's surface and assisting in navigation. Among its many instruments, Hayabusa 2 carried a thermal infrared imager to study temperature variations on the asteroid's surface. This imager could measure temperatures ranging from -40 degrees Celsius to 150 degrees Celsius, and could detect fine temperature variations as small as 5 centimeters in diameter. The spacecraft also used a laser altimeter LiDAR to map the surface of the asteroid, measuring the distance between itself and the surface with incredible precision. Through its long and groundbreaking mission, Hayabusa 2 has provided invaluable data about the origins of our solar system, and it continues to push the boundaries of space exploration. The mission demonstrates the incredible advancements in technology and innovation that are enabling humanity to reach new heights in our quest to understand the cosmos. By collecting samples from Ryugu and beyond, we are gaining unprecedented insights into the history of our planet, the materials that make up the universe, and the potential for life elsewhere in the solar system. By tracking the radio signals emitted from Earth, the spacecraft was able to provide crucial insights into the asteroid's gravitational field, offering a deeper understanding of the distant rock it was sent to explore. This innovative approach helped reveal not only the surface characteristics, but also the very forces that shaped this ancient celestial body. Hayabusa 2, a state-of-the-art spacecraft designed to unlock the mysteries of space, carried a set of 4 highly specialized rovers, each playing a vital role in the mission to explore the surface of the asteroid Ryugu and gather invaluable data for future scientific studies back on Earth. Since Ryugu is a relatively small object with an extremely weak gravitational pull, the usual methods of exploration, such as rolling or driving across the surface, were not feasible. Instead, the rovers were designed to overcome this challenge by hopping from one location to another, propelled by specialized mechanisms that utilized the weak gravity to their advantage. These small, nimble robots were launched from an altitude of about 60 meters above the asteroid's surface, dropping freely due to the asteroid's minimal gravitational field. As they fell, they were designed to bounce gently upon landing, making them perfectly suited for exploration in this foreign environment. The first 2 rovers, named Heibu, formerly Rover 1A, and Owl, formerly Rover 1B, successfully landed on Ryugu on September 21, 2018. Their mission was straightforward yet crucial: to gather data about the surface that would help inform the larger goal of obtaining samples to return to Earth. Shortly after, on October 3, 2018, the 3rd rover, named Mascot, followed suit and touched down on the asteroid's surface. The Mascot rover's mission, unlike that of the previous rovers, involved more complex scientific experiments aimed at understanding the asteroid's internal composition and surface features. However, the journey of the 4th rover, called Rover 2, also known as Minerva 22, was fraught with difficulties. Initially planned for release from Hayabusa 2, it encountered technical problems that prevented its deployment on time. Despite this setback, Minerva 22 was later sent into orbit around Ryugu on October 2nd, 2019, to study the asteroid's gravity from above. Sadly, this rover's journey ended in failure when it crashed onto the surface just a few days later on October 8th, 2019. Nevertheless, this rover was an important part of the Minerva mission, a follow-up to its predecessor, the Minerva lander, which had also been part of Hayabusa 2's overall scientific objectives. The Minerva 22 container housed 2 main rovers, Rover 1AA, Heibu, and Rover 1B, Owl. These 2 rovers shared a similar design: small cylindrical shapes with a diameter of 18 centimeters and a height of 7 centimeters, each weighing only about 1 kilograms. Despite their tiny size, they were equipped with rotating masses that enabled them to hop across the surface of Ryugu. Their mission was not only to capture images and videos, but also to conduct a range of experiments to gather critical data about the asteroid's surface. With stereo cameras, wide-angle lenses, and thermometers on board, they sent back valuable information for analysis. Rover 1A, for instance, operated for 113 days on Ryugu, capturing an impressive 609 images during its mission. In contrast, Rover 1B operated for a shorter period of 10 days, sending back 39 images. Their combined efforts helped provide a clearer picture of Ryugu's surface characteristics, including temperature variations and mineral compositions. Minerva 22 also carried Rover 2, developed by a collaborative team of universities, with Tohoku University in Japan taking the lead. Rover 2 was a unique octagonal prism design, measuring 15 centimeters in diameter and 16 centimeters tall, weighing just 1 kilogram. This rover, unlike its cylindrical counterparts, was equipped with a set of advanced tools designed for specific tasks. These included cameras, thermometers, and accelerometers, as well as optical and ultraviolet LEDs to detect and illuminate tiny floating dust particles on the asteroid's surface. Although Rover 2 faced technical difficulties before its deployment, it eventually contributed to the mission by carrying out gravity measurements during its time in orbit. Unfortunately, it too met its end when it crashed onto Ryugu in October 2019. The Mascot rover, a collaboration between the German Aerospace Center, DLR, and the French space agency CNES, was another key player in the Hayabusa 2 mission. Smaller than the other rovers, Mascot measured just 29.5 centimeters in length, 27.5 centimeters in width, and 19.5 centimeters in height, with a weight of 9.6 kilograms. Despite its compact size, it was equipped with 4 advanced scientific instruments: an infrared spectrometer, micromega, a magnetometer, massmag, a radiometer, MARA, and a camera, MCAM. These instruments enabled Mascot to conduct detailed studies on the asteroid's surface, including examining its small-scale structure, surface material distribution, and texture of the regolith, loose surface material. Mascot's mission was groundbreaking. During its 16-hour operational period, powered by a non-rechargeable battery, it made several key discoveries that have reshaped our understanding of asteroids. For instance, one major finding was that C-type asteroids, such as Ryugu, are far more porous than scientists had previously thought. This discovery also explained why meteorites from these types of asteroids are rarely found on Earth. Their fragile structure makes it difficult for them to survive the intense heat and pressure of atmospheric entry. Another significant discovery was that Ryugu is composed of 2 types of nearly black rocks, both lacking internal strength. Surprisingly, despite this lack of strength, no dust was detected on the asteroid's surface, a finding that defied expectations. These results were published in prestigious journals like Nature Astronomy and Science, providing critical insights into the composition and characteristics of Ryugu. Mascot's mission was not without its challenges. Initially, it was meant to collect 3 types of samples from the surface: materials with evidence of water-related minerals, those with minimal to no signs of aqueous alterations, and samples from below the surface. However, in late October 2018, the rover encountered a significant obstacle. The surface was densely covered with large and small boulders, leaving little exposed ground for sampling. This delayed the sample collection, and the mission team decided to explore other possibilities. Eventually, the first surface sample was collected on February 22, 2019, after the rover successfully gathered a significant amount of topsoil. A second sampling attempt was unfortunately canceled to reduce risks to the mission's success. The final sample came from material that had been forced out of the surface by a kinetic impactor shot from a distance of about 300 meters. This technique was based on technology developed for earlier missions, including Hayabusa 1. The samples collected were carefully sealed in separate containers and placed within a return capsule for the journey back to Earth. The Hayabusa 2 spacecraft's technique for collecting surface samples was modeled after its predecessor, Hayabusa, and involved a high-speed impact with the asteroid's surface. As the spacecraft descended toward the surface on February 21, 2019, a small 5-gram tantalum projectile was fired from the spacecraft's sampler horn, traveling at speeds of around 300 meters per second. This projectile struck the asteroid's surface with enough force to create a burst of debris, which was then captured by a catcher located at the top of the sampler horn. This method relied on the momentum of the debris itself to collect material in the weak gravitational field of Ryugu. To gather deeper, fresher material that had not been exposed to the harsh conditions of space, including radiation and micrometeorite impacts, an even more powerful technique was required. This came in the form of the Small Carry-On Impactor, SCI, released on April 5, 2019. The SCI carried a 2.55 kilogram copper projectile that was launched at the asteroid using a small explosive charge, creating a small crater. The goal of this maneuver was to reach material that had remained untouched by the external environment, offering a glimpse into the asteroid's deeper, more pristine layers. While Hayabusa 2 carried out this bold experiment, it also deployed the DCM-3 camera, which monitored the impact and mapped the location where the explosion occurred. Meanwhile, the spacecraft moved to a safer position on the other side of the asteroid to avoid any potential debris from the explosion. This impact experiment was expected to provide important data on the resurfacing process of small celestial bodies, helping scientists understand how asteroids like Ryugu evolve over time. The Hayabusa 2 mission marked a historic milestone in asteroid exploration. With its successful sampling techniques, innovative use of multiple rovers, and groundbreaking discoveries transforming our understanding of the building blocks of our solar system. When the spacecraft took its post-impact images, it became immediately apparent that the impact had caused surprisingly little shaking. This revelation suggested that the asteroid's surface was far weaker and less solid than scientists had originally anticipated. Around 40 minutes after releasing the impactor, once the Hayabusa 2 had retreated to a safe distance, the device was activated. The activation was achieved by detonating a 4.5 kilograms explosive charge, which propelled a copper projectile toward the surface. The projectile, fired from a height of roughly 500 meters, collided with the asteroid with such force that it created a crater roughly 10 meters in diameter. This impact exposed pristine material, untouched by the elements, and never before seen by human eyes. On June 4, 2019, Hayabusa 2 marked a significant milestone in its mission. It placed a highly reflective marker near the newly formed crater. This marker wasn't just a symbolic gesture. It would serve as a guiding point for the spacecraft's next phase, landing and collecting samples. The team's precision was critical. Their next goal was to land on the asteroid's surface, retrieve samples, and then return those samples to Earth, where they would be studied in laboratories. Finally, on July 11, 2019, the spacecraft carried out the delicate touchdown and sample collection operation. After securing the precious samples, the containers were carefully sealed to preserve their integrity. These sealed containers were placed inside a specially designed return capsule, which would protect the samples from the harsh conditions of space, including the extreme temperatures encountered during re-entry. The capsule itself, a compact yet sophisticated piece of engineering, measured approximately 40 centimeters in diameter, was 20 centimeters tall, and weighed around 16 kilograms. Its specially designed thermal insulation ensured that the samples inside remained at the right temperature throughout their journey back. In November 2019, after completing the science phase of its mission, Hayabusa 2 shifted its focus. Using its ion engines, the spacecraft adjusted its orbit, beginning the long journey home. The spacecraft traveled a staggering distance of 5.24 billion kilometers, more than the distance from Earth to Neptune. By late 2020, just before making its final flyby of Earth, the spacecraft released its capsule, which made its way toward the planet's atmosphere. At precisely 5:30 a.m. UTC on December 5th, 2020, the capsule, spinning once every 3 seconds, re-entered the Earth's atmosphere at an incredible speed of 12 kilometers per second. To slow its descent, it deployed a radar-reflective parachute when it was about 10 kilometers above the ground and ejected its heat shield, sending out a signal to assist with tracking its position. The capsule then successfully touched down in the Woomera test range in Australia, where it was retrieved. Before the sealed containers inside the capsule could be opened, any volatile substances within them would be carefully collected. The samples, which had traveled more than 5 billion kilometers, were then prepared for analysis at JAXA's Extraterrestrial Sample Curation Center in Japan. From there, scientists from around the world would be able to request small portions of the samples for further study. What made these fragments especially valuable was their composition. They came from the Ryugu asteroid, which is rich in carbon. These fragments held the potential to unlock the mysteries of how water and organic molecules may have been brought to Earth in ancient times, an essential question for understanding the origins of life on our planet. In an unprecedented step in international cooperation, JAXA shared a portion of these Ryugu samples with NASA. In return, NASA would send JAXA a portion of the sample collected from the asteroid Bennu by its OSIRIS-REx spacecraft when it returned to Earth in September 2023. In November 2024, a study published in Meteoritics and Planetary Science analyzed a sample returned from Ryugu. Despite stringent efforts to prevent contamination, microorganisms from Earth were found on the sample. Scientists concluded that these microorganisms had likely come from Earth during the preparation of the sample, not from the asteroid itself. This discovery underscored the immense challenge of keeping extraterrestrial samples uncontaminated, even in highly controlled laboratory environments. But even as Hayabusa 2 completed its primary mission, it was far from finished. The spacecraft still had around 30 kilograms of xenon propellant left in its tanks, enabling it to continue its exploration in the years ahead. In July 2026, Hayabusa 2 is set to fly past asteroid 98943 Torun, an S-type asteroid, in a high-speed pass. This will be a particularly challenging encounter, as the spacecraft's cameras were not designed for such rapid observations. But the real groundbreaking mission lies ahead. In 2031, Hayabusa 2 is scheduled to rendezvous with asteroid 1999 KY26, a small, fast-rotating microasteroid that spins once every 10 minutes. This will be the first close encounter with such a rapidly spinning object. Additionally, between 2021 and 2026, the spacecraft will take time to observe distant exoplanets. There is even a possibility that Hayabusa 2 will fly by Venus on its way to an encounter with asteroid 2001 AV43. This extended mission, known as Hayabusa 2 Sharp, has taken on a new symbol, a musical note that raises a pitch by a half step. This symbol represents not only the higher stakes and challenges of the mission, but also highlights its new goal, to investigate small asteroids that could pose a threat to Earth in the future. The Sharp in the mission's name emphasizes the growing complexity and difficulty of the task at hand. At the same time, new space exploration projects are steadily progressing. Hardware is moving into the testing phase, and new designs are being developed for even more advanced missions. In the coming years, we can expect a significant increase in flight tests, demonstrations, launches, and priority missions, some of which are on schedule while others are experiencing delays. One such project is the Sierra Nevada Corporation's Dream Chaser, an unmanned cargo spacecraft that will deliver supplies to the International Space Station. On the runway at Armstrong Flight Research Center in Edwards, California, Dream Chaser sits, waiting for a helicopter to lift it into the air. Once airborne, the helicopter releases Dream Chaser, which then makes an unpowered descent, successfully completing another test. The Dream Chaser project, part of a 10-year program, has faced many obstacles, but it is closer than ever to achieving its goal of delivering cargo to the space station by 2020. Meanwhile, Boeing's CST-100 Starliner capsule has undergone a series of high-altitude drop tests, focusing on its parachute and airbag systems. While there have been some delays, mainly related to weight and aerodynamics, other aspects of the design are progressing well. For instance, the new spacesuit designed for astronaut safety is one of the standout innovations. This suit is airtight, capable of withstanding extreme pressure changes, and can protect astronauts from emergencies such as cabin leaks or fires. Under the shoulder covers, a special material allows astronauts to move freely, even in the vacuum of space, without overheating. The gloves are lightweight and equipped with connectors that make it easier for astronauts to interact with touchscreens, an essential feature in modern spacecraft. The helmet, modeled after Russia's Soyuz design, attaches to the suit and is sealed with a zipper. Boeing is also utilizing a capsule trainer, allowing NASA astronauts to familiarize themselves with the Starliner capsule. The trainer helps astronauts practice key steps, such as understanding the spacecraft's systems and procedures, so they're well prepared for real missions. Though the idea of sitting on a rocket can be daunting, astronauts have found that becoming familiar with the spacecraft makes the experience far less intimidating. The training program includes uncrewed orbital tests later in 2018, with a crewed flight scheduled for the end of that year. Given the intricate nature of spacecraft engineering, it's no surprise that the timelines for critical tests and launches can sometimes be stretched. Space exploration is an unforgiving field, one that requires near perfection in both design and execution. This means that delays of 12 to 24 months are a real possibility, something many aerospace companies are prepared for in their long-term planning. Yet, despite these challenges, several private companies are pushing the boundaries of what we thought was possible, bringing bold new innovations to space exploration. Among these trailblazers, SpaceX stands out as a company making substantial progress. The private aerospace manufacturer has set an audacious timeline for its Dragon capsule, with an uncrewed test flight expected in early 2018, followed by a manned mission just 4 months later. This kind of ambition, if successful, would mark a historic shift in space travel, breaking away from the confines of traditional governmental space agencies and ushering in a new era of private sector dominance in space exploration. The design of SpaceX's Dragon capsule is unlike any other. It's sleek, modern, and engineered for efficiency. The materials used are cutting edge, from carbon fiber to titanium and advanced alloys, making it more akin to the high-performance vehicles you might see on the roads than anything we've come to expect from space capsules. Inside, it's equipped with the latest electronic displays and touchscreen controls, setting a new standard for commercial spacecraft, unlike the more utilitarian designs favored by NASA or the Russian space program, which prioritize functionality over comfort. SpaceX's Dragon capsule has already completed several key tests, including static fire exercises, pad abort drills, and parachute deployment trials. These successful tests show that the capsule is well on its way to becoming a fully operational vehicle for human spaceflight. With space for up to 7 astronauts, the Dragon capsule could be the first commercial spacecraft to launch and return astronauts from the International Space Station, ISS, a remarkable achievement that could reshape the space industry in just a few short years. Not far behind in the race for space innovation is Virgin Galactic, which has been methodically building its reputation. Despite facing setbacks in the form of catastrophic failures in the past, the company has not been deterred. Instead, Virgin Galactic has doubled down on its commitment to safety, refining ground crew operations, spacecraft procedures, and carrier plane coordination through exhaustive rehearsals and fine-tuning. Their Unity spaceplane, which has experienced its own share of challenges, has taken major strides toward becoming a reliable suborbital vehicle. It has successfully flown with its rocket motors and propellant tanks fully operational, and most impressively, it has landed without incident. The company's next major milestone is a powered suborbital flight, likely to occur within the year, and this could mark a major step forward in human space tourism. On the small satellite front, Rocket Lab is making waves with its Electron rocket, a game-changing vehicle designed to launch small payloads into low Earth orbit at a fraction of the cost of traditional rockets. The company's second test launch, powered by their 3D printed Rutherford engine, is poised to take place soon. If the test is successful, Rocket Lab may bypass further trials and move straight into commercial operations, fundamentally altering the economics of space access and opening up new opportunities for smaller players in the industry. Blue Origin, founded by Amazon's Jeff Bezos, is another company advancing toward its own set of milestones. Their reusable New Shepard rocket has already completed several important tests, including successful booster launches and soft landings with a single parachute. With each successful test, Blue Origin edges closer to its goal of taking paying customers on suborbital flights. The company is also working on the New Glenn rocket, a multi-stage vehicle designed to reach orbit. However, this ambitious project is still years away from completion, held back by technical hurdles and overly ambitious launch schedules. Nevertheless, the progress made so far is noteworthy, with New Shepard already demonstrating the feasibility of reusable rocket technology. At the same time, Falcon Heavy, another heavy-hitting rocket from SpaceX, is preparing for a critical test of its own. In the coming weeks, engineers will conduct a static fire test to ignite all 27 engines of the Falcon Heavy simultaneously. This crucial test is a precursor to the first test flight, which is expected to occur within the first 2 or 3 months of the new year. Once operational, Falcon Heavy will be capable of lifting larger payloads into orbit, significantly enhancing the capabilities of commercial spaceflight. On the government side, NASA's Space Launch System, SLS, continues to face setbacks, largely due to the complexity of its design and the new technologies being employed. Issues with the fuel tank welds and delays in the delivery of the Orion spacecraft's propulsion system have pushed the timeline back, meaning it's likely that the first flight of SLS will occur no earlier than 2020. This delay, though disappointing for many, is not entirely unexpected, as the SLS is intended to be the most powerful rocket ever built, designed for deep space exploration. Alongside the SLS, NASA's James Webb Space Telescope, one of the most ambitious astronomical projects of the decade, has also faced delays. Its launch, initially planned for 2018, is now slated for 2019. The delay, while frustrating, is seen as a necessary step to ensure the telescope's instruments are fully ready for the immense task ahead. The European Space Agency, ESA, is also making significant strides, particularly with its Ariane 6 rocket, which is currently under development. The Ariane 6 is designed to be more cost-effective and versatile, crucial for competing in the rapidly expanding global space market. ESA has shifted more responsibility for the development of the rocket to the private sector, allowing for greater innovation and faster progress. The Ariane 6 will come in 2 main configurations: the Ariane 62, which can carry up to 4.5 tons to a sun-synchronous orbit, and the Ariane 64, capable of carrying up to 10.5 tons to a geostationary transfer orbit, ideal for communication satellites. These rockets will be key players in Europe's independent access to space. As part of the development of Ariane 6, ESA is also overseeing upgrades to its launch facilities in Kourou, French Guiana. The new launch pad for Ariane 6 is being designed with some significant changes, including horizontal preparation of rocket stages instead of vertical, a shift intended to streamline operations and increase efficiency. Despite the progress, there's still a chance that delays at the spaceport could affect the timeline, pushing back the first launch of Ariane 6, which is still planned for 2020. In parallel, ESA's Vega C rocket is also making progress. This smaller vehicle is designed primarily for launching Earth observation satellites as part of the European Union's Copernicus program, but it will also serve a variety of other satellite missions. With its higher capacity than the original Vega rocket, Vega C promises to be an essential tool in ensuring Europe's continued leadership in space technology. The space industry, driven by both private and public entities, is experiencing rapid change. While setbacks and delays are inevitable in such a high-stakes field, the pace of innovation is accelerating. As new technologies are tested, refined, and launched into the cosmos, humanity's presence in space is becoming increasingly diverse, commercialized, and accessible, transforming not only how we explore the final frontier, but also how we envision the future of space exploration itself. The upcoming Vega launch, set to carry the European Iola satellite into orbit, remains on track for an early 2018 launch. However, another exciting mission is drawing much anticipation: the Transiting Exoplanet Survey Satellite, TESS. TESS mission has successfully completed all its pre-launch tests and is poised to be the first astrophysics satellite launched with the support of SpaceX. The planned launch window for the Falcon 9 rocket, which will carry TESS into space, spans from March to June 2018. TESS isn't the only significant mission on the horizon. Another major exoplanet hunting satellite, known as KOP, is also progressing as planned. This satellite is managed by the European Space Agency, ESA, and is being led by the University of Bern, which designed and built its key instrument. The satellite's structural components, along with its supporting systems, were constructed by Airbus in Madrid. Prior to its launch, the KOP satellite underwent rigorous testing, including exposure to extreme vibrations, intense sound levels, and vacuum conditions, all to ensure it can endure the harsh environment of space. Set for a launch in late 2018, the KOP satellite will be launched aboard a Russian Soyuz rocket. Meanwhile, another mission, the Bepi-Colombo mission, is preparing for its journey to Mercury, one of the most enigmatic planets in our solar system. This ambitious mission, a joint project between the Japan Aerospace Exploration Agency JAXA and ESA, is now ready to embark on its historic trip. The mission involves several complex components: a Mercury Transfer Module, MTM, a sun shield to protect the spacecraft from the sun's extreme heat, and two scientific orbiters. One orbiter, provided by ESA, will study Mercury's surface, while the other, provided by JAXA, will focus on the planet's magnetic field. The spacecraft was meticulously assembled in a clean room at the European Space Research and Technology Center, ESTEC, in Noordwijk, Netherlands, before being sent to the launch site at Kourou in French Guiana. The Bepi-Colombo spacecraft is set for launch in mid-2018, beginning its 7-year journey toward Mercury. This mission marks a significant milestone in space exploration. The Bepi-Colombo spacecraft, a collaborative effort between ESA and JAXA, represents one of the most complex and ambitious space missions ever devised. The spacecraft is designed to unlock the many mysteries of Mercury, a planet that has intrigued scientists for years. Bepi-Colombo consists of 2 orbiters and a transfer module. These orbiters are uniquely designed to study Mercury in unparalleled detail, not only by getting closer to the planet, but also by analyzing its unique features, such as its unusual magnetic field, mysterious surface structures called hollows, and even the potential presence of ancient ice hidden in the planet's polar craters. One of the orbiters, called the Mercury Planetary Orbiter, MPO, is provided by ESA. Its primary mission is to explore Mercury's surface and interior. The MPO is equipped with a variety of instruments designed for remote sensing, aimed at observing and mapping the surface of the planet in extraordinary detail. These instruments will help scientists understand Mercury's geological history by investigating its composition, surface materials, and internal structure. For instance, by studying Mercury's craters, scientists hope to uncover clues about the planet's past, offering insights into its formation and evolution. The other orbiter, the Mercury Magnetospheric Orbiter, MMO, is provided by JAXA and will focus primarily on Mercury's space environment. This orbiter will study Mercury's magnetic field and its interactions with the solar wind, a constant stream of charged particles emitted by the sun. The MMO will help scientists understand how the planet's magnetosphere behaves, shedding light on how these interactions affect the planet's surface and its atmosphere. However, one of the most formidable challenges for the Bepi-Colombo mission is coping with Mercury's extreme environment. Being just 3 times closer to the sun than Earth, the planet experiences temperatures that far exceed anything we encounter. The heat and radiation from the sun on Mercury are 10 times stronger than what we experience on Earth, which means the spacecraft needs to be specially engineered to survive these harsh conditions. In order to protect the spacecraft from intense solar radiation and heat, advanced insulation materials and specialized protective coverings were developed, particularly for the solar panels and antennas. The spacecraft's design and development process was incredibly challenging and took many years of testing and fine-tuning. Engineers worked tirelessly to ensure that every component could withstand not only the extreme temperatures of space, but also the powerful radiation from the sun. Detailed mechanical and electrical tests were conducted, along with propulsion system assessments, to guarantee the spacecraft's readiness for this perilous mission. In addition to the extensive engineering work, the team behind Bepi-Colombo underwent rigorous training to prepare for the mission. The preparation process included simulating the space conditions that the spacecraft would face, allowing engineers and scientists to work together to refine flight procedures and rehearse how to deal with potential issues. The training also focused on teamwork and collaboration, ensuring the team could respond to unexpected challenges during the mission. Reaching Mercury itself presents a considerable challenge. Not only must the spacecraft contend with the planet's extreme heat, but it also has to overcome the sun's immense gravitational pull. As the spacecraft approaches the Sun, it will need to slow down significantly in order to be captured by Mercury's weak gravity. Surprisingly, it is harder to send a spacecraft to Mercury than it is to send one to Pluto. This is because Mercury's proximity to the Sun requires vast amounts of energy to break free from the Sun's gravity and slow the spacecraft down enough to settle into orbit around Mercury. To achieve this, the spacecraft will need to perform a series of planetary flybys. These flybys will involve the spacecraft passing by Earth twice, Venus once, and Mercury itself 6 times before it reaches its destination. This slow and intricate journey is part of what makes the mission so lengthy. It will take approximately 7.5 years to complete. These planetary flybys will provide the spacecraft with gravitational assists, gradually reducing its speed and altering its trajectory. This delicate choreography of gravity assists will eventually allow the spacecraft to enter orbit around Mercury. The development of this mission has been a long-term effort that stretches back over a decade. For many of the engineers, scientists, and technicians involved, the launch of Bepi Colombo represents the culmination of a lifelong dream. The spacecraft's final assembly and testing were completed at the European spaceport in Kourou, French Guiana. The logistics involved in transporting all the components to the launch site were extraordinary, with 4 cargo planes and 70 shipping containers required to deliver the spacecraft's various parts safely. Interestingly, Mercury has already been visited by spacecraft in the past. NASA's Mariner 10 mission was the first to fly past the planet in the 1970s. 4 decades later, NASA's Messenger mission arrived at Mercury, mapping its surface and uncovering surprising evidence of water ice in the planet's permanently shadowed craters. Despite these monumental discoveries, Mercury remains one of the most puzzling planets in our solar system, with many unanswered questions about its surface, atmosphere, and magnetic field. Now, with the launch of Bepi Colombo, scientists hope to take their exploration of Mercury to a new level. The mission promises to provide unparalleled insights into the planet's geological composition, its magnetic field, and its interactions with the Sun's solar wind. The data gathered by the mission's 11 scientific instruments will help to answer questions that have baffled scientists for decades, giving us a clearer understanding of this mysterious world. The dual approach of having 2 spacecraft orbiting Mercury, one studying its surface and the other its magnetosphere, represents a groundbreaking advancement in planetary exploration. This combined approach will offer new perspectives, helping scientists piece together a more comprehensive understanding of Mercury's complex nature. The data gathered by these spacecraft will be stored on board like a massive hard drive and sent back to Earth whenever the spacecraft can be reached, giving us a window into one of the most challenging and fascinating environments in our solar system. The communication between the spacecraft and Earth is far from instantaneous. In fact, the spacecraft can only send data back every 16 hours. During these periods, the data collected over the course of the last 16 hours is transmitted to Earth via a powerful high-gain antenna. While the speed of this transmission might seem painfully slow when compared to the fast-paced internet connections we are used to, it is, in fact, remarkably fast for a spacecraft so close to the Sun. Solar interference and high radiation levels from the Sun itself pose significant challenges to space communication, making every bit of data transmitted crucial. As the Bepi Colombo spacecraft approaches Mercury, it faces an entirely new set of challenges in terms of propulsion and energy management. The spacecraft is equipped with a solar electric propulsion system, one of the most advanced technologies in space exploration today. The propulsion relies on 4 cutting-edge ion thrusters powered by xenon gas. These thrusters function by ionizing the xenon gas and then using electricity to accelerate the ions to incredibly high speeds, generating thrust. This method of propulsion is far more efficient than traditional chemical rockets, which would require significantly more fuel for the same journey. The ion thrusters provide a more sustainable way to navigate through space for months without depleting the spacecraft's fuel. However, the spacecraft's ion thrusters need a continuous source of energy to remain operational. Fortunately, the Bepi Colombo is equipped with solar arrays that collect sunlight and convert it into electricity. As the spacecraft draws closer to Mercury, it encounters another significant challenge. Mercury's proximity to the Sun means the solar flux, essentially the amount of solar radiation the spacecraft is exposed to, is about 10 times stronger than what we experience on Earth. This increased energy is beneficial in terms of powering the spacecraft's thrusters, but it also presents a potential danger to the spacecraft's solar arrays. Too much heat could cause them to malfunction, potentially jeopardizing the mission. To mitigate this risk, the spacecraft is equipped with an advanced heat management system. The solar arrays are covered with special white coatings and tiny reflective mirrors that help deflect some of the intense solar heat. The angle at which the arrays are positioned also helps reduce heat absorption while still ensuring that the spacecraft collects enough solar energy to power its systems. Additionally, the spacecraft features multi-layered insulation, thermal blankets, and radiators that manage heat distribution effectively. If the temperature exceeds safe limits, an emergency signal will be sent to Earth, alerting the mission control team to take swift action to protect the spacecraft from damage. The spacecraft's engineering is designed to handle these extreme conditions, allowing it to continue its mission of gathering valuable data about Mercury's surface and environment. The Bay Colombo is scheduled to reach Mercury by late 2025, at which point the two orbiters, separated from the transfer module, will begin their scientific missions. By 2026, the spacecraft is expected to be fully operational, sending back groundbreaking discoveries that will illuminate many of the mysteries surrounding one of the most enigmatic planets in our solar system. The primary scientific goal of this mission is to understand the fundamental composition of Mercury. Despite being one of the closest planets to the Sun, Mercury is largely shrouded in mystery, and much of what we know about it has been derived from indirect measurements. All planets in our solar system share a common chemical composition, yet the distribution of these elements varies significantly from planet to planet. The study of Mercury's surface will provide key insights into how elements are distributed and what this reveals about the planet's geological history. One of the mission's most exciting tools is an imaging X-ray spectrometer called MIX, which will be used to map the atomic composition of Mercury's surface. This instrument works by detecting the X-rays that are emitted from Mercury when sunlight strikes it. To understand how this works, imagine being at a party wearing a shirt washed with special detergent. When the party lights hit the shirt, it glows. Similarly, sunlight causes the surface of Mercury to glow in X-rays, which the MIX spectrometer can detect. By measuring these emissions, scientists can determine the precise makeup of Mercury's surface elements. Each element emits a distinct signature of X-rays when exposed to sunlight, essentially allowing the spectrometer to count the atoms on Mercury's surface. This technology provides an unprecedented level of detail and will result in the first ever X-ray images of Mercury's surface. The MIX instrument is also capable of detecting X-rays produced when particles from Mercury's magnetosphere, charged particles that originate from the Sun, interact with the planet's surface. These interactions are critical for understanding how Mercury's magnetic field affects its surface and may provide important clues about the planet's internal structure and behavior. These insights into the magnetosphere's influence are essential in piecing together the broader picture of Mercury's geophysical properties. In addition to studying the planet's overall composition, Bay Colombo will focus on some of Mercury's most puzzling geological features. One of these is the presence of hollows, which are strange depressions scattered across Mercury's surface. These depressions are characterized by bright interiors and sharp, fresh-looking edges, suggesting that they are geologically young features. Scientists suspect these hollows are linked to the presence of volatile elements such as sulfur and sodium that are released into the atmosphere following impacts or volcanic activities. However, the formation of these hollows is still not fully understood, and more detailed observations from the Bay Colombo spacecraft will be necessary to unravel their origins. In some areas of Mercury's surface, scientists have observed alterations caused by the removal of volatile substances, like sulfur, chlorine, and potassium, through vaporization. The MESSENGER mission, which previously studied Mercury, provided some initial clues about these processes, but it was limited by the resolution of its instruments. Now, Bay-Colombo's advanced capabilities will allow scientists to create clearer three-dimensional models of these surface changes and offer high-resolution images for more detailed analysis. One of the most significant discoveries of previous missions, such as Messenger, was the identification of water ice in Mercury's polar craters. These craters, which are located in areas that never receive direct sunlight, remain incredibly cold, making them perfect environments for preserving water ice. If Bay-Colombo's instruments can confirm this finding, it would provide crucial insights into the history of water in the inner solar system. The presence of water ice on Mercury ties into broader theories about the origins of water and organic materials in the solar system. Some scientists hypothesize that water, along with organic compounds essential for life, was delivered to the inner planets, including Earth, by comets originating from the outer reaches of the solar system. Understanding how these materials were distributed could shed light on the origins of life on Earth. Despite its proximity to the Sun, Mercury remains a vital piece of the puzzle in understanding the formation of our entire solar system. By studying Mercury's composition, its magnetic field, and its geological history, scientists can gain valuable insights into how the inner planets formed and how Earth came to be the habitable planet we know today. Furthermore, by examining Mercury's surface for clues about the presence of water and organic materials, Bay-Colombo is helping to address some of the most fundamental questions about the potential for life beyond Earth. The Bay-Colombo mission is not only a testament to human ingenuity and technological advancement, but also a collaborative effort involving scientists and engineers from around the globe. This mission will provide an unprecedented wealth of data that will enhance our understanding of Mercury, its geological history, and its role in the broader context of the solar system's formation. As we approach the completion of this mission, we are poised to answer some of the most intriguing questions about the planet and ultimately about the solar system itself. The data returned by Bay-Colombo promises to offer new insights into the evolution of Mercury, its environment, and its potential to hold clues about the origins of life across the solar system.